Hey everyone, welcome back to another video. In this video, we're going to create a Crossy Road and voxel slash blocky sort of theme portfolio. We've got collision detection. We've also got some interactions, like when you click on Pikachu, he jumps really cutely. And this is kind of like copied to some of these other ones, like Bulbasaur here and Charmander, as well as Squirtle. Then on the back here, we also have some projects, so you can click on them and kind of just read about the projects, and then you can visit them if you want to. And you also have some other hidden gems for more information, just some playful personality things. And of course, we also need the Crossy Road cameo, our biggest inspiration right here. So this is actually a portfolio I was working on with a friend, so I just recreated it for this intro course. So this intro course is going to cover a lot of things. We're going to cover some exercises. We're also going to cover how to read documentation, how to think like a programmer, how to figure out things that seem difficult, how to break down things. So hopefully it'll give you the right mindset, so you'll eventually won't need as many tutorials and you can kind of figure things out on your own. So you don't need any experience with Three.js or Blender whatsoever. But you do need some experience with HTML and CSS and JavaScript if you can make like static websites. If you can make static websites, like if you just go to a typical static web page and you're like, okay, I can make that, then you should be good to go. Yeah, so I just want to make like a brief comment about creative web development, or the title. So it's a very, very broad term. It's very, very broad. And there's a lot of other terms that you might hear. So you have like creative technologist, UI engineer, UI/UX engineer, UX engineer, design engineer, graphics programmer, Three.js developer, WebGL developer, creative developer. Creative web development has so many job titles. And in all those job titles, they overlap very often. And, people are going to specialize in one area compared to others. Like some people are really into like CSS and JavaScript animations. Other people use no-code tools for like motion design, like After Effects, or like Jitter, which is an online tool, or Principle. Others are focused on like low-level language stuff with shaders and GLSL. Others are more focused on Blender. Others are focused on the UI design part with like Figma and things like that. So when you enter the creative web development field, there's so many niches and areas to specialize on. When it comes to these terms, I generally don't like to define myself within these terms. At the end of the day, you're just someone that creates something really cool. So you should view yourself as someone that creates something, whether you do UI design, whether you do shaders, whether you do 3D art with Blender, whether you do CSS or JavaScript. You're all doing something and creating something that makes other people happy. So the moment you start slapping labels on yourself, like design engineer or creative developer and all these sort of things, like they're cool to kind of describe the work that you do, but don't let it subconsciously limit you on what you think that you can do. Often I see that designers will say that they're designers and they think that they can't code, but then they later find out they can code. Or people that code, they're like, I'm a coder, I can't design. And then they find out later that they can design. So, don't view these as like separate concepts. View them as you just creating something that's really cool, whether you're designing or whether you're coding. Over time, as you explore these different areas, you'll kind of find, what sticks with you and what interests you the most, and then you can start specializing while still being somewhat of a generalist. So my area of focus, or my specialization, is definitely around 3D art with Blender. So that's why most of my videos on this channel kind of include Blender on them. The really awesome thing about the creative web development field is that you kind of can blend yourself into a multitude of different roles outside of the creative roles, right? Like if you know Blender and you actually don't like coding, you can just transition into a 3D artist at that point. Or if you like coding and you like shaders and you like 3D art and I think I said programming, then you can become like a game developer or something like that. Or maybe you're like, okay, I like 3D art and animation, so maybe you become like a animator who's also into music theory and music design and things like that. And then maybe you're eventually, instead of just working with websites, you go into like AR and VR and all that kind of cool stuff as well. Because you have 3D knowledge, you can contribute to AR and VR, even though you're just primarily programming with the web. Additionally, all your skills and like if you have like UI design skills, it's going to help you if you want to become a UX researcher and understand how users use your website and things like that. You can translate all these concepts between every single field, right? If you know how people view 3D art conceptually and the theory behind that, you can translate that to your 2D UI designs. And then if you become a UX researcher, you kind of already build up that intuition across multitude of art fields, which will make you better when you're doing things like heuristic evaluations. So the really, really awesome thing about creative development, creative web development in general, is that you can kind of mix and shape your career however you want. And a lot of skills really, really overlap. So that's kind of why I really, really like it. And you kind of never get bored because you can always just like quote unquote switch your specialization or learn something and use what you learned to build upon the knowledge of the other domain that you learned previously. So I think it's really, really cool. And yeah, so without further ado, let's get started. All right, so let's create a new general file. So this looks a little bit scary. They all look kind of weird and kind of scary, and that's totally okay. But there's one way to visualize this 3D scene that will make it a lot easier, not only with Three.js, but also in Blender. So just like the real world, when we are working in the real world, we have certain things that we need in our scene, right? So we can categorize this whole thing, this whole picture as some sort of scene. So you can think of this point light like a light bulb, and the icon kind of does look like a light bulb. And then right now we have a cube, but we could make some flowers, right? And then we would have flowers in the center of our scene. But now we would just have a cube. So you can imagine a cube here. And then here, this is our camera. And then just like in real life, this is a camera here. So yeah, essentially what you're looking over here is just something that you can visualize in real life, just like here. So now let's navigate around a scene, right? Like in real life, you can walk around. So how do you do that? Well, you can use your middle mouse button, just click down on it to rotate your camera. Then when you hold shift and use your middle mouse button, you're going to be doing this action called panning. Another thing you'll see me do a lot is zoom in and out, and you can just scroll up with your middle mouse button and down like so. Or if you're on a laptop, you probably have to use 2 fingers. You can also hold Control or Command on Mac and hold down your middle mouse button to do a smoother kind of zoom. But for the most part, I usually just use my tick scroll with my middle mouse button. I should have also mentioned that on the bottom here, you'll see the things that I'm hitting and some of my mouse inputs, like when I left click and things like that. Not everything shows, like I'm hitting my middle mouse button and it's not really triggering that as well as it should be. But yeah, in case I don't mention something, which I'll try my best to, try and look here a little bit. And if you can't find it, just post a comment below and I'll take a look. So spend some time just using your middle mouse button and then randomly clicking shift sometimes to navigate around your cube. So now I'm going underneath the cube, and then I'm going back all the way at the surface, and this will feel really, really weird at the start, but over time you'll kind of get used to it. If you're on a laptop without a mouse, you probably have to use 2 fingers to rotate, and then hold shift and 2 fingers to pan. Alright, so before we continue, let's come up to File and Save, or just Control S, or Command S if you're on Mac, and let's just call this Voxel Portfolio, but you can call it whatever you want, and let's just save it here. Alright, so let's make some adjustments to our cube. Let's say we want to scale it. We can hit S on our keyboard to scale it. And then we can lock it on specific axes. So you can see, if you come up here, you can see the specific axes here. So the green one is Y, the X is X, and the Z is up and down. So we can scale it with S, and then we can hit Y to lock it on the Y axis. And then we can hit X to lock it on the X axis, or Z to lock it on the Z axis. Then you can left click to confirm that transformation. And now you can see our block looks more of like a rectangle. Additionally, if you wanted to do all of them except a specific axis, you can do like Shift Z. So now I only scale along the X and Y axis, but not the Z axis. The next thing you have is G to move it if you want to move it. So G in this case stands for grab, and same like scale. You can move it along a certain axis just by pressing that letter, like so. And you can also do Shift Z, and so on and so forth. And you can just change between these until you left click to confirm it. So now my cube is over there. The last one that you'll need to know is rotate. So if you hit R for rotate, you can see my object is rotating. And similarly, you can do RZ, and now it's only rotating along the Z axis. RY, it's only rotating along the Y axis. And RX, it's only rotating along the X axis. You'll notice that what you see, the dotted line from your cursor, is relative to this orange dot. And this orange dot appears on every single mesh that you have, and this is what we call the origin point. All of your transformations will be relative to this origin point. You can see now, since the origin point is exactly in the center of the object, when I hit S to scale it, it's kind of evenly scaling the mesh. Now watch what happens when I change the origin point. You don't have to do what I'm doing. I'm just going to show you. If I move the origin point over here on this side and confirm that change, now when I scale it, you can see it's scaling from here. Isn't that really interesting? So when I do SY, you can see it's kind of going like this instead. Or when I do RX, it's kind of rotating like this instead of the center of that object. So I'm going to undo that origin point. So now when I go back and do RX, you can see that just like that. So I'm going to leave that undo, but that is an important concept to know. Yeah, so pause the video, take some time, just play around with your cube, mess it up, do whatever, and also get comfortable navigating and doing all that sort of stuff. So generally before 3D artists start modeling whatever they're modeling, they kind of have an intuition on what sort of quote-unquote basic shapes that sort of complicated thing that they want to model is made of. So when I mean basic shapes, you can add a shape. If you do Shift A, you can see you can come to mesh. There's a variety of different objects here, but if you come to mesh, this is kind of the one that you're mainly going to be working out of. You can see we have a bunch of primitive shapes, right? We have a sphere, we have a plane, we have a cube. So cube is what they gave us by default. We can also add something like a plane. So when I click on that, you can see that there's a plane there. So let's just move this cube out of the way. And now there's a cube here, and we can do the same thing like we did the cube, S to scale it, Y, and so on and so forth. And then I can also Shift A again, and then come over here and look for a sphere. And now you can see we have a sphere in there. And we can do the same thing. S, scale it, R, rotate it, so on and so forth. So given all these basic meshes and objects and shapes, adjusting them will give us the model that we want. All right, so let's take a look at what we're modeling. We're going to be modeling this tree as our first object. Now, unfortunately, we only have a 2D image, so it's kind of hard to visualize all three worlds. But if you take a chance, you can kind of see what kind of objects it's made out of. Like, let's say this really small stem here. What do you think this is made out of? Well, it seems like it's just a cube, right? So it's like a cube, and then we just stretched it really long, and this would be our branch sort of thing, right? And you would be correct. It's just a cube that we scale up in the z-axis. Same thing with this sort of thing right here, right? We just have a 3D cube. So if I draw this, you can see we probably have a cube something like this, which means that this is also a cube, and then this is also a scaled up cube as well. So by analyzing the basic shape, we realized that we need 4 cubes. 1 cube for the trunk, 1 cube for the bottom bush, 1 cube for the top bush, and 1 cube for the very top bush. So I'm in a new Blender file, but here's your first optional task before we continue on. And this is what I call the Think Like a 3D Artist Intuition Development exercise, which is kind of a long-winded way of saying, when you look at a real-life object around your house, try and think of what sort of object would make that. So let's say we have this water bottle here. So what could this be? Well, it kind of looks like a cylinder. So do we have a cylinder? If you do Shift A, go into Mesh, indeed, we do have a cylinder. So we could possibly also use a cylinder for this one right here. What about this one? Well, it kind of looks like a sphere, but it's like half of a sphere. So do we have a sphere? And yes, indeed, we have a sphere. Later, I'll show you, instead of just transforming the object, I'll show you how to actually edit the object. But this is going to be your first intuition. It's like, oh, that could be a sphere. And then this kind of looks like a cylinder. So if we wanted to make a bowl, we could just move the cylinder up here and kind of scale it down, just like this. And then we kind of already have the beginnings of a bowl. And then for like a fence that you see, oh, it looks like a bunch of cubes that I just scaled up and scaled down a little bit. So yeah, just spend some time looking at your objects around you and things around you and try and see, you know, what sort of objects, if you could edit them in some sort of way, could they be made out of? And this is how you develop your 3D artist intuition. And again, don't worry if you mess up. Over time, this will get better and better, and you can grow and learn from your mistakes. So let's do that. I'm just going to select one of these objects, and holding Shift, you can select multiple objects. So I'm going to select all of these while still holding Shift and left click, and I'm just going to hit X, and I'm just going to delete them. So let's add our first cube. So I'm going to do Shift A, I'm going to do cube, and I'll add a cube here. So I'm just going to do exactly kind of what this looks like. So I'm going to scale it down, right? And I want to do Shift Z this time. So I just want to scale it on the X and Y axes to kind of get a stem looking trunk. And then I'm just going to do SZ, and I'm going to scale it up just like that. Now, if you don't like the angle that you're working with in the viewport, there's these things called orthographic views that help out a lot. So if you come up to this gizmo over here, you can see that when I click on this thing, it's going to only look at the other axes. And this is what we call an orthographic view. Basically, everything is the same distance from the camera. So you don't have to do this, but let me just take this object here, and I'm going to do GX and move it really, really far away, right? And it's kind of obvious that this is farther than distance, but look what happens when I go in the positive x-axis orthographic view. It looks like it's exactly here, right? And then if I do GX, it's actually moving along the x-axis, but I can't tell because I'm in an orthographic view. So the benefit of the orthographic view is sometimes you don't know which objects are taller, or sometimes you don't know which objects are wider. So you kind of want to, quote unquote, get rid of an axis and only pay attention to what you need. So let's say this object, let's say we move it up here, and then we would have to try and find an angle to determine if this one is longer or this one is longer, and it would be kind of a mess. So instead, what we just do is go to an orthographic view, right? And just by eyeballing it in this orthographic view, we can tell that they're the same length. Additionally, it helps us align things better here. Imagine we had to align it here. We would kind of have to guess, this looks about the same level, right? But then if I go to the orthographic view, you can see we got pretty close, but it's not as easy as it would be if we just did an orthographic view. So let me just delete that, and that's kind of, so these views are really helpful. And now you can see that if you have a numpad on your keyboard, that's really helpful to quickly jump to like the side view. You'll hear people say left view, right view, positive Z axis, right? So you can highlight over these to see the shortcuts for them. Okay, so let's add our cubes. So I'm going to do Shift A, and instead of coming here, you can just type cube. So I'm just going to type cube and hit enter. So if we go to our reference, we see that we have this stick, right? And then each of these is about 40%, I would say, of that stick. So let's do the same thing. Again, if you want to scale this down a little bit and move it up, so you can totally do that. And then I'm just going to move this down here, maybe S Shift Z a little bit, like so. Now, instead of adding another cube, since the middle bush is going to be the same size as this one, we can actually duplicate it. So the way to do that is with Shift D, and then by default, it'll be selected. You can right click to cancel the movement, and then it'll just place it in place. Or let me delete that. If you do Shift D, since it's already in the grab or the G move command, you can automatically lock it on the Z axis. And then you can just click up and drag and left click to confirm it just like that. So we can do the same thing for the top bush. We can do Shift D, lock it on the Z axis, move it around here and just scale it down. And then maybe this time we want to scale it up, except on the Z direction, and kind of just place it just like this. Then let's move this down a little bit. Yeah, and congrats. If we look at it, we pretty much made this tree, right? So if you made this tree, you can definitely make variations like this tree. Now we did successfully create the tree, and it looks fairly similar to the one in the image, if not identical. But there's kind of a few other things that I want to show you to speed up your workflow later down the road. So you can just watch for now, but I want to talk about some of the issues with our current model that will be a headache later down the road if we don't fix it now. So let's say we don't like the size of our tree. Well, you know that holding Shift, you can select multiple of them. When you select multiple of them, you can actually perform operations on them together. So they'll all scale at the same time, they'll all rotate, and so on and so forth. You can also box select, so you can left click and drag to select everything in your view, like so. You can see it's collecting. You can see it's selecting like so, and that'll be okay to scale the tree, right? But what Blender is doing for our tree here is that it's taking the average of all these origin points, the center of them, and scaling it like that. So what if our tree was like sitting on a plane or something? So again, you can just watch, but let's say I add a plane for our ground and it's our tree's like sitting on this plane, right? So we select all our tree objects and like, oh, that tree's too big. So we decide to scale it down. So we scale it down. Now look what happens when I go to the side. Now we have to move it all the way down here. And then just like, oh no, that's too small. So then we go up here and we have to kind of do like this, right? Now that's not terrible, but when you're working with multiple objects and doing the same thing over and over again, that's going to be really, really annoying. So one way to fix that, instead of having to select all the objects at once, is to join them together so they become one single object. So if with all of them selected, the one with the strong orange outline, which we generally call the active object, that origin point will become the entire joined object's new origin point. So since this is the last one, if I do Control J, again, you can just watch. Now you can see it's all one single object, right? And if I hit S to scale, it's going along that origin. So if I select all of them instead, and then still holding Shift, make this one the active object, and hit Control J, you can see the origin point is now along here. So what if somehow we had our origin point down here? That way when we scale it, it'll be relative to our ground. That way we wouldn't have to move it anymore. So you can actually adjust this origin point. If you hit Control period, or if you're on Mac, Command period, you'll see that you get these axes. And then what you can do is just G and Z, and you can see that it'll be moving that origin point, and you can just put it at the bottom here, right on the center. So here's where you would want to use orthographic views to make sure that you really get it there, just like this. Cool. And now you just place it at the bottom. And now to confirm that, just do Control period or Command period if you're on Mac to get out of that mode. So now look what happens when I scale it. And now you can see even when I go to the side, even when I make it big, we don't actually have to make any movement adjustments at all. So now your origin point might not be placed perfectly there, but you kind of see the concept that we're going for, right? Okay, so I'm going to do something to get back to where we were. You can just watch. I'll explain this a little bit later. So the second issue with the model is that we have a bunch of overlapping geometry. So when you have a simple scene, generally this is not an issue at all. And if you're just going for like renders and things like that, it's not always a big deal. However, for us, this is a particularly a issue. One, primarily because of texturing, which I'll cover a little bit later, so you can just ignore that for now. And then the second thing is the browser is very, very weak compared to like Blender software or game engines, or like when you download a game onto your computer, right? The browser isn't as strong. So the issue with overlapping geometry is that we're pretty much wasting information. No one will ever see this cube behind this other cube, right? So what we have is this extra information that no one will actually ever see. And then let's say we want a color there. Well, we would save that color data in a file, right? But if no one sees it, then that's just extra space into our file. And then for the web, we kind of want to control for this as much as possible. So there's a few ways to fix this. One way is to bring the model out of it, right? And kind of keep it a little bit gapped there. Or there's this feature thing on here called snapping, and you can choose a variety of snapping methods, like face in this case. So if I do G, you can see it's moving along this face of that object. And then if I do Z to lock it on the Z axis, you can see it's only snapping to this face. So now it's perfectly sitting on top and it's not overlapping. Let me turn this off. So that's one way to fix that. So let me hide this cube. You can do that with H, or you can come here to the scene outliner and click this eyeball here to temporarily hide it. If I come down here, yes, we don't have overlapping geometry, but we still have this huge square here that will be storing information like colors and things like that. So we don't want that either. So I'll talk about how to fix this in a little bit, but let's rehide our cube and let's take a look at how we can optimize our modeling so that we kind of avoid all these issues. So what I'm going to do is select everything and hit X and delete it. Okay, so let's analyze this top bush before we start modeling, because this is the one that I want to do first. So we kind of had two issues with this top bush. One, these two cubes were overlapping each other. We fixed that, But then on the underneath of the top cube, there was still a face there that was taking up information that we didn't need. Additionally, it looks like these two are connected. So given all that information, is there some way we could create a cube and edit that cube in order to make this top thing rather than add another cube? And the answer is actually yes. So what I'm going to do is Shift A, search and add a cube. And then if you come up here, you can see this thing called edit mode. So now when you go into edit mode, you're going to see some more things show up, and you can left click, box select, select multiple, and so on and so forth. So what we're in right now is vertices select, and then you also have edge select. So when you go over here, you can click on the edge, and then when you click over here, you'll select a face. And when you go between these modes, which you can change with your numbers, your number keys at the top of your keyboard, you can see if I hit 1, I go into vertex select. If I go into 2, I go into edge select. And if I go 3, I go into face select. So kind of just get used to that. Depending on the mode that you're in, your transformations are going to affect your object in different ways. So here I'm in face select. You can see when I hit G to move it, it's kind of different. When I go into vertex select, I can select a vertice, hit G, and you can see what it's doing to my object. And then I can select multiple with holding shift, just like the same way we can select multiple objects, right? Same with box select and so on and so forth. Just get used to switching between the modes and just like seeing what you can do with your cube and just have some fun. Now, it would be kind of annoying if you always had to go into object and edit mode just like this. So the hotkey to switch between object and edit mode is just tab. So you can see as I hit tab, I'm going between object and edit mode. Now, I don't like tab being this hotkey, primarily because I use a lot of other things in Blender. So what I like to do, if you come into edit preferences and go to key map, you can see this thing here called tab for pie menu. And this is what I have check marked. And what it shows when I hit tab is the two modes here, but all the other modes that I can quickly access. So if I just do tab edit mode, tab object mode, you can see it. I can just go back and forth just like that. If you prefer the default way of Blender, you can totally do that. And we won't be using any of these other modes in this video, but as you start using other modes, I really recommend you to turn on the pie menu. All right, so let's just go back into object mode and delete this cube and add a new one. And let's go back into edit mode. Thing to do in edit mode is what we call an inset operation. So what an inset does is it kind of takes your selection and tries to make that same exact shape, but just smaller. So if I select this face, if I go into face select, again, you can hit 3 there or come up here and click it. So I'm selecting this face and I hit I for the inset operation. You can see that it's kind of making a smaller version of that face in here. And you can, if you don't like the speed of it, you can hold shift to make it go a little bit slower, just like this. You can also type numerical values if you want to, but I'm just going to be eyeballing it. So like the photo, I think it was about here. So we can just left click to confirm it, or if you want right click to cancel it. But I want to confirm it, so I'm going to do left click arbitrarily around here. And then like the other faces, you can scale it if you want to. So I'm hitting S and I'm hitting G and I'm hitting R. All those operations are still working as well. Now we don't want to rotate it or move it at all. We just want to bring it up. But if we bring it up, it kind of does this, right? And that's kind of weird. So that brings us to the second really common edit transformation, and that's called extruding. So if I hit E for extrude, you can see by default, it's going to lock in the axis direction that you're extruding in. So in this case, it's extruding to Z, but you can hit Z to unlock it and it'll extrude up, but we just want to do directly up. So now you can see I can just bring it up, eyeball it, and just left click to confirm, just like that. And now, guess what we have? We have a connected object here. We have no overlapping geometry. And if you want to, you can select a face, press H to hide it. You can see there's no hidden face there. So if I do Alt-H to unhide those things, you can see that we do indeed, when I go back into object mode, have our top bush. Okay, so let me delete this. And the next thing I want to talk about is the trunk origin point, right? So let me add a cube again. You can just watch. You don't have to do anything. Let me add a cube and let me just quickly make our trunk. Let's just say this is our trunk. So remember, we want our origin point to be at the bottom of the tree trunk. That way, when we change things around, it's not going to mess up anything. I did show you one method. If I selected, do control period, and move it down with GZ arbitrarily here, it's going to be perfectly fine. Again, we can turn on snapping here and do GZ and just snap the origin right over here and to the bottom. And then hit control period to confirm that. And everything is perfectly fine. Another alternative is to use what we call this thing right here, the 3D cursor. So if you want to change where it is, it'll be shift right click. And you can see I'm changing its position around the world. And when I do shift A and add a cube, you can see my cube is now added over there instead of the world origin. So the 3D cursor has a lot of other uses. We can also use it to set the origin point. So if I go into edit mode and I select this for things like this and do shift S, you can see we have a lot of options related to our selection as well as our cursor. So if I do selection to cursor while if I do cursor to selected, it'll take my cursor and teleport it to my selected things. So since I selected this face, what it's going to do is take the average of these 4 vertices, or this face, since I'm technically also selecting the face, it's going to put it directly at the bottom of this face as well as the center. Then I can go back into object mode and do object set origin to 3D cursor. Obviously nothing changed because it was already there, but this is the other alternative of setting an origin point. The other alternative of setting an origin point is actually adjusting the model. And if you go into edit mode and hit A and move it around, notice that the origin point doesn't change, whereas in object mode, the origin point is adjusting with the model. So essentially what you could do is kind of place it in edit mode. Let's assume it's up here, that you just place it here in edit mode and go into object mode and it'll be working. Now, what if I told you there was an even faster way to set the origin point to the bottom of this tree trunk? So let me delete this. And it's actually not a way of setting the origin point, but per se using the right sort of starting mesh. So instead of using a cube, I'm going to use a plane. Whoops, let me actually delete this. I just want to start from the origin. Not that it matters, I just like it. So what we can do is shift S. We can do cursor to world origin. It'll snap right back there. Now let's do shift A and add a plane. So now look at this plane. The origin point is directly in the center of this plane, right? Which looks exactly like when we had a cube, the bottom face of that cube. So now what we can do is just go into edit mode, and we learned about extrude. So what we can do is just extrude it up, right? Hit A to select everything, and then shift Z and scale it down. Just like this, and then go back into object mode. And you can see that, voila, we have a tree trunk. We didn't have to adjust the origin point or anything, we just had to extrude it. So if you do it really quickly, it's just shift A, add a plane, go into edit mode, E, extrude, A, S, shift Z, just like this. Whereas, again, if you add a cube, so let's do the same thing, add a cube, let's turn on vertex snapping this time, control period, GZ, snap it to this vertex like here, control period to confirm it, S, shift Z, like so, and then now it's not in the world origin, so just move it here and just do shift S, just like this. So, yeah, so the plane is significantly easier, significantly less amount of steps. So for our case, using a plane is actually better than using a cube when it comes to a tree trunk. Yeah, so for when it comes to a tree trunk, at least for us, we actually want to use a plane instead of a cube. Okay, so the next operation I want to talk about is loop cuts. So again, we have to go into edit mode for hits. And if you hit Control or Command R, you can see you get this yellow line thing here. And this is what we call a loop cut. Basically what it does is it gives you more geometry by slicing, quote unquote, slicing your mesh. So if you scroll up or down on your mouse or laptop D-pad, you can see you can add the number of slices. You can also type it, so if you hit 9, you can see it's going to give me 9 there. For us, I'm just going to add 2. And then when you left click to confirm it, you can see it'll start sliding. And then you can right click to make it centered, so it'll just be centered. Or if I do Control Z, get rid of those, let's do Control R again, go up to 2, you can decide where you want to place them. And since, again, they're just like any other edge or any other vertex, you can see as I switch between them, I can like select the face in between them now, just because we sliced it up. So if you want to select a loop cut really quickly, you can hold down the Alt key and you can see it'll select that whole loop there. So now when I do G and Z, you can see I can also move it just like this. Now the reason I'm showing you a loop cut here is because, again, we don't want extra geometry. So if I go back to this tree here, you can see this trunk kind of goes in between them. And again, that means that trunk, that invisible trunk, is using some sort of information that we don't really need because we'll never see it. So by using this loop cut, we have more geometry here to work with. So if I go into face select and hold down Alt, you can see it's going to select that full loop there. And I hit Alt E, it's going to give me this alternative extrude menu. You can also come up to face and see these extrude options here as well. But generally I just use Alt E, and you'll see this thing called extrude faces along normals. So what normals are, it's like a direction pointed off of the face. Generally it's perpendicular, meaning if this face is directly up and down, the normal is going to be pointing 90 degrees from this face. So like 90 degrees, so it'll be pointing that way. Same thing with this face, it's kind of looking outward, so it's going to be 90 degrees and it's going to be pointing that way. So if I do Alt E, extrude along normals, you can see what happens. Right, this face is 90 degrees is going this way, this one's going this way, and so on and so forth. So what we have now is our tree, right? We have the base, we have our trunk, and then we also have the tree. All right, so again, if I hide this, you can see we have no geometry in there. Now, it's kind of tedious to always have to hide something in order to see something else, right? Because sometimes you might forget that you hid something and you kind of just wondered what happened. So if you hit Alt H, it'll unhide that. So there's these things in Blender called modes. So if you hold down the Z key, you can see we have a rendered mode, a material preview mode, and a wireframe mode. So if we go into wireframe, you can see now we can see through a mesh. And this is a really quick way of just looking through your geometry without having to hide anything. We'll talk about these other two in a little bit. But let's go back into Solid. You also have this thing up here called X-ray view. So when you click on it, you can also see through your object. And if you come here, you can see there's some options for your X-ray and how much you can see through that and so on and so forth. Now, the really nice thing about like X-ray or wireframe is that when you select things, you can actually quickly get the things behind that you can't see. So if I go into edit mode here and I go to vertices select and I box select here, you can see I select all four. Now let me deselect that by clicking somewhere, go into solid view and do the same exact box selection. Look what happens when I go on this side. I can't see that vertice, so I didn't select it. And I can try as much as I want to. I can even select this back one here because I can see it, but I'm not touching that one. So I have to come over here, hold shift and select this one and deselect this one by holding shift and clicking on it. So now I select everything, but instead what you can just do is go into wireframe, box select, and select all of those, right? Just like that. So these views are definitely going to help out a lot. Now, again, just like holding tab, I also like to come into edit preferences, key map, and to this thing called extra shading pie menu items. Now when I hold Z, you can see we have this thing called toggle overlays and toggle X-ray. So if I go back into solid view, instead of coming up here to toggle it or using the hotkey Alt Z, I can just come here and do toggle X-ray just like this. Okay, so now I can delete this. And what I want you to do is pause the video and try and recreate the tree using everything we know. And then come back and return to this video. All right, so let me show you how I would make my tree. Okay, so the first thing I'll do is add a plane for our tree trunk, scale it down arbitrarily, go into edit mode and extrude up. Again, this bypasses any transformation we need for the origin point, like so. Then what I do is go into edit mode and add 3 loop cuts, like so. And then I'm gonna go into wireframe, select these bottom two and SZ to scale them up a little bit. In this case, SZ is effectively doing the same as if I highlighted one of these and do GZ and move them up. And this is going to be our bottom bush. So what I'm going to do is SZ and kind of just eyeball it and then GZ and kind of move it somewhere over here. Then I'm going to go into face select. And since they were already selected, I don't have to select them. But again, if you accidentally deselected it, you can do it with Alt and click near the edge and it'll select that whole loop. Again, but since we're in wireframe, we can just box select and it'll also do effectively the same thing. They kind of have the same size as the top one. So what I'm going to do is I'm actually going to select this loop cut right here, and I'm going to GZ and move it down a little bit, like so. Kind of eyeballing it as well. And what I'm going to do is face select this with Alt, right? Get all these, and then I'm going to hold Shift and Alt and select this loop right here. Again, since we're in wireframe, we can just hold down Shift and left click and drag to select through our object. Now what I'm going to do is do Alt-T, extrude faces along normals, and just move my mouse up until I get a tree shape that I like. Super, super cool. And then now for the top bush. This belonged to our trunk originally, but now what you can see that it's effectively like an inset face. So what we can do is select this face and just scale it up to the size of the top bush. And then we need a top bush. So what we can do is just E and extrude it up, right? Oh, sorry, I have snapping on. Let me turn this off. And I did right click cancel, but I still had the extrude. So it's kind of overlapping. So make sure that you don't actually accidentally do that. Anyway, since it's overlapping, I'm selecting it anyway, so I can just do GZ and bring it up a little bit to get our top tree, just like that. So let me go back into solid view, and voila, we have our tree, except this time we did it well. You can see there's no overlapping geometry, no wasted geometry, and our origin point starts at the bottom. Super, super cool. All right, so let's rename our object. We can come up here and you can see it's called plane. Or you can click on it and just hit F2 and you can rename it here, or you can come over here to the outliner and double click here. And I'll just call this tree. Then we can temporarily hide it and move on to our character. Okay, so you can use whatever character you want, but I'm going to be going for like a kind of a human kind of character. So just by looking at Crossy Road's character, you can probably see that you can actually make a lot of these. Even this default chicken, sorry the image is a little bit blurry, but you can see we kind of have a cube here, and then the body is a cube, right? And then a loop cut, and then you can extrude out the head, and then this is also probably just a single cube extruded this way and extruded this way, top also a cube, or it's an inset and then an extrude up as well. Same thing with the feet. You can see probably a cube or a plane starting there, extruded downwards, a loop cut on the side, a loop cut on the side, and then extrude on that side, extrude on this side at the same time. And if you can make this character, you can probably make this character or this character and so on and so forth. Now there are some techniques that would probably speed up the workflow for a lot of these, which I'll show in a little bit. But let's take a look at some of the human characters of Crossy Road. But when taking a look at one of these characters, you kind of see that for the most part, they're kind of just made out of a bunch of cubes, right? So the body is probably like a cube or plane again, and then, you know, same thing down here and so on and so forth. Okay, so before we move on, I kind of want you to do a drawing exercise, even if you're not good at drawing at all. I kind of just want you to like visualize the side view of your object. So let's say this is your head, and then this is like your body or something, and then you have your legs, and they kind of look like this. And then you have your arms right here, like so. So this is like the side view of your character. And then you can imagine the front view, so like we have something over here, and then it'll kind of be like this, right? This is the body, this is the neck, these are going to be the arms like so, and then these are going to be the legs, and then we have the feet like so, like so. So whatever character you're doing, try and just either in your head or actually draw it out, you know, kind of visualize what primitive objects you need for your character. Alright, so let's start a character. I'm going to Shift A and add a cube, and then I'm just going to bring it up. If you want a thinner head, you can definitely scale it down. If you prefer working this way, you can totally do that as well. It's not really a big deal. I'm going to leave mine a cube. And now we need a neck. So there's a few ways to approach this, and it kind of depends on you. So one, you can use the method we learned already. You can just hit I to inset it, and then maybe S and Y just to make it a little bit thinner, and then E to extrude it. So there we have our neck. For the body, you can do the same thing. You can E, but instead of extruding down and then using Alt-E to extrude along normals, which you could totally do if you wanted to. So if I do Alt-E and do like this, that would give us our body, right? And that wouldn't be too bad. And then, of course, you can scale it how you want it and shape the body. So that's one way to do it. Extrude and then extrude again along the normals. Or what you can do is E, and then right click to cancel the movement, and then scale it up first to get a shape that you want, like so, and then you can extrude it downwards, like so. So you get the same exact result, just two different methods there. And then there's this third method that you might be using a lot as well. And this is what you'll see a lot when it comes to objects that should be separated. And you're kind of like preemptively doing that in your own brain. So what you can do is click on something here and do P, and you can see it brings up this menu called separate. And you can separate that mesh by selection. So right now we only have a cube and our tree that we hid and that point light and camera. But watch what happens when I do P and separate by selection. You can see I can no longer select that thing because it became its own object. So if I go back in object mode, you can see now I have two separate objects, and you can rename this one as well. It has the same name, so it automatically tagged on that ID there of 1. But now you can see it's its own separate object. So since it's its own separate object, I can just scale it up. But notice that its origin point is at the default object's origin point. So again, we know how to fix that. Blender, we don't have to do all that fancy stuff. We can just come up to objects at origin to geometry, and I'll try and take that average of that geometry and place the origin point there. So now we pretty much just have a plane that's sitting right there. We don't have to add another one. It's just right there. So that's really helpful because now we can just scale it up, right? And shape it how we want. And then go into edit mode, A to select everything, E, and bring it down. But now we have kind of two objects here. There will be a lot of scenarios where the P separate by selection rather than combining the mesh is going to be the method that you take. For us, it's not particularly going to matter that much. Now, obviously, like we did before, you can join them. So Control J, and then now you can see we have one object. If we go into edit mode, you'll see that it's not connected though. So essentially what we did, we actually saved out a little bit of geometry, right? We, instead of having these lines for inset, right? We don't have those anymore because they're separate objects. They effectively look like they're joined together, but they're not joined together. See up here, if I move this, these are joined together, whereas down here, there's no join at all. So if I do this other thing called A and do P separate by loose parts, you can see it's going to give us our two objects again. So couldn't we also do it with the head and the neck, right? Why do we have the neck and head connected? Well, honestly, it really depends on your use case. Like, let's say you're animating the head and do you want it to affect the neck? The reason I'm showing you these different methods is so later down the road, you won't be kind of surprised when you see them. So let me just quickly delete all of these and start again. Shift A, add a cube, bring it up. And this time I'm going to do the P separate by selection method, go into edit mode, select this. I'm going to Shift D to duplicate this face, right click, cancel the movement. It's still selected, so P separate by selection. And now go into object mode, select it, right click, set origin to geometry, scale it down for the neck, so SY, something like this. Go into edit mode, A to select everything, E to extrude down. And now I'm going to do the same thing. This is selected, P separate by selection. Now that becomes its own mesh. Again, same thing, right click, set origin to geometry, scale it up a little bit, just get the body like so. A to select everything in edit mode and bring it down. So now you can see I have three separate objects here, like so. And instead of having to hide this and see this face here, there's this thing called local mode. So if you hit the backslash on your numpad, you can enter local mode where you only see the object there. So if I go back, you can see it hops between those. You can also go to view and, oh, I should have mentioned you can also see the orthographic views in the viewport. But yeah, you can also come here, local view, and do toggle local view, and you can see the hotkey is numpad slash, but then you'll go in there, and then you can just come back here and remove from local view and so on and so forth. I should have also mentioned that there's a lot of other really awesome things that you can do to quickly navigate around your scene that you can see in these menus. I highly recommend check. One that I like to use a lot is period key on my numpad, and that kind of just jumps to your selection. So in the view menu, it's just frame selected, so you can see frame selected. It'll just jump to whatever selected object you have, like so. So now if I wanted to name this, I would have something like head, right? And then I would select this, and then I would something like neck, and then I would something like body. And again, if I go here, you can see we will never see this face, so we can actually just delete it, go out of local view, and so on and so forth. Now, if you want to reset the origin point for all of these to be in the center, you can quickly do that by selecting both of them, set origin, right click, set origin to geometry, and now I'll calculate the centers for both. So now that we're moving on to the legs, you can actually realize that maybe we actually did a good option here. So if I go into edit mode, you can see I can just add two loop cuts, right? Like so, just like this. and go out here and just extrude these down. Add 2 more loop cuts, right click cancel, left click, right click cancel. Hold shift and alt, select both of these loops, or wireframe and box select. Whoops, we don't want those, just those. And then GZ and move it down. Whoops, I accidentally selected that. I can hold control and box select to quickly deselect it as well. Move that down, face select, and E and extrude over here. So if I go back to solid view, we kind of already have our thing started. Same thing here, we can add our arms, right, and so on and so forth. But now so I'm going to undo all those changes. Now let's take a look at if we did the other way. So again, sorry, I keep going back and forth. I just want to make sure this is really, really coherent. But here, I'm just going to do the same thing. I'm going to inset, I'm going to extrude. I'm not going to spend too much time styling it the same way. But then same thing here, E extrude, right click cancel, scale it up, E extrude it down, wireframe, bring it up a little bit. I don't want it too messy. Okay, so now that we have this method, which if I put more time into would look identical to this, right? But look what happens when we want to add our legs. If I add a loop cut, like 2, you can see what happens. It slices through our entire thing. So while effectively we would get the same exact thing, right, that this method did, what we're adding here is all these extra lines. So obviously what you could have done is at this neck point, you could have separated that object. So the neck and body could have been extruded together, which is okay. Whereas you separated the body, which is what we did over here. And now you can see it's just a simple clean cut just like this. So for us, yeah, the top doesn't really matter if you decide to inset or not. Whereas the body, choosing to separate it actually really benefited us a lot. So I'm going to delete this, and we should be good to now go here. But it's kind of tedious that since the legs are the same, and since the arms are the same, and since all this stuff is the same, it's kind of annoying that we have to do it all over and over again. So Blender actually has these things called modifiers, and they're like functions that basically do things to your objects that speed up your workflow. So if you come to add modifier, there's a lot of really, really cool ones. And one of them is called the mirror modifiers. Again, like adding a mesh, you can just start typing and you'll see mirror modifier right there. And you can hit enter and select it. And you won't see anything right now because it's just mirroring it on top of itself. Watch what happens when you add a mirror object. So I'm just going to take this eyedropper tool and select our head. And we still don't see anything because it's along the x-axis. Watch what happens when we do it along the z. And you can see what happens is it's perfectly mirroring across the origin point of this object, equally spaced onto the other side. So we can just get rid of this just to see it's equally spaced over here. With the graphic view, just H to hide it, you can see what it's doing there. Now it can also mirror across itself. So let's get rid of this and let's go into a body. And what I'm going to do is add a loop cut straight down the center. Right click and cancel that. So it's straight in the center. And then select these vertices like so, and hit X and just delete those vertices, right? So now we just have half our body, but then we can do add modifier, come over here and search mirror, right? Just like this. And now you can see if I go into edit mode and I change one thing on this side, it's going to mirror that change on the other side. We also want to turn on clipping, and this will kind of prevent our stuff from going through each other. So if I do GX, you can see the kind of like clipping or going through each other. So we want to turn this on, and I want to do GX. You can see it's not going to go anywhere. And then we also turned on merge by default, which means once we apply this modifier or it finalizes our transformation, these vertices will merge instead of overlap each other. What we're technically doing is what we call procedurally modeling. That means if we want to, we can come back and change this a little bit later, very, very simply compared to if we're just hand modeling it, which people generally refer to as destructive modeling. So think about it this way. If I go back into object mode and hit Control A to apply my modifier, or I can come up here and do apply. Now if I go into edit mode, you can see we no longer have the mirror modifier. So if I extrude here, it's not going to do anything over there. So this is what we call destructive modeling, because now it just becomes a lot more tedious to edit. But if I leave in the mirror modifier, go into edit mode, this is more procedural, because if I want to change things, right, I can change things. I'll talk about procedural and destructive a little bit more, but I kind of just want to briefly bring that up. Yeah, so we have a lot of options now. We could add a loop cut here like we did for the thing and just extrude our legs. Or we can do the separate method. So I'm going to do that. I'm going to go into solid view. I'm going to select this face, shift D duplicate, right click cancel, P separate by selection. And now you can see we have this separate object here. And since it came from an object with a mirror modifier, it also has a mirror modifier here. So I can go into edit mode and just E and extrude it down a little bit like so. And this will kind of be our belt. So we can call this belt like so. And then what we can do is the same exact thing, go into edit mode, select this, shift D duplicate, right click cancel, P separate by selection. And now these will be our legs. So we can do legs, go into edit mode. And this time we don't want our legs to be the full width. We kind of want a gap there. So what we can do is turn off clipping this time so we can move it and do GX kind of like so. I can go into wireframe to do this. Now I can just select all these and do E and extrude it downwards like so. And then we can do the same thing here. I'm just going to extrude the feet this time, but you can totally separate it for the shoes as well. And now if I go back, you can see we have our legs, a belt area, our body, our neck, and so on and so forth. And then of course, make sure we don't have any extra stuff. So we can go in here. Yeah, we kind of have some stuff here, so we can delete these like so. Same thing with the leg, I guess over here, we can delete these. No one's gonna see those. Now, if you want to edit like the size of this belt, then you'll need to select all three of them, go into edit mode, go into wireframe, select all, and then select all these top ones and do SZ, for example. So you can scale all of them at the same time and adjust it that way, GZ, that kind of stuff, so on and so forth. And then of course, if you don't like this, you want to make this a little bit longer, you can totally do that as well. Again, you didn't need to have a separate belt and legs. If you just wanted to loop cut and extrude, you totally could have done that as well. So yeah, you totally have so many options. Honestly, just play around to get something that you like. That's all I'm going to be doing. Okay, now we need to add our arms. So lots of ways to do this. If you wanted to use the cursor method, which is something we learned way back, if I do Shift A and add a cube here, you can see that is going to add a cube here. GX and then maybe GX a little bit again and snap it over there. So that's a really quick way. If you just start, let me just show you. If I add a cube here, scale it down a little bit, and I do GX and try and snap it here. I'm holding control, by the way, to quickly toggle this on, even though it's not showing it. I have vertex on, so it's going to snap to a vertex. It's not going to work. Whereas if I move it out a little bit first and then do GX and then snap it, you can see it's going to do that. Of course, you could also use a plane and rotate it 90 degrees. But yeah, so this time I'm just going to go out a little bit, maybe come over here and extrude this a little bit like so. SY, whatever. And then now the really cool thing is, again, we can add a mirror modifier, so we don't have to do that. And this time we can use our object as our body. And now you can see that we have this little thing here, and every change we make on this side, it's going to happen on that side as well. Super, super cool. So you have that method, and then you also have like that duplicate method. So Shift D, right click, cancel, P separate by selection. It becomes its own object. Then you can go to edit mode, A select everything, S Shift X, just scale it along the Z and Y axis, go bring it up a little bit, edit mode, E to extrude it out, R loop cut like so, E extrude it down just like that. So same exact thing there. Yeah, so you have a lot of options. Honestly, for the arms, it doesn't really matter which method you choose in this case. It's not going to change much at all. And then of course you can edit it how you want to edit it. Just make sure you're selecting the things that you want to select, and do it like so. Super, super cool. So now we can rename this F2, and I'll just call this arms. And then of course you have the other ones. You can add a loop cut and extrude, right? Or you can do an inset and extrude. So you can do an inset, bring it up here and extrude like that, so on and so forth. So many options here. Okay, so the last thing I want to do is add some hair to our head. Now there's a lot of approaches here, so you can just watch for now. And then based on what you want to do, I recommend trying and figuring out which method might work best for you. So let's say you want a simple haircut. You can just add like a loop cut over here, right? And then you can just select this with holding Alt, or maybe the top one as well, and just do Alt E extrude along normals. So now you kind of have like a simple hat or something. And then I guess if you wanted to, you could inset this and bring it up. And then instead of hair, you'd have a hat there. If you wanted to make it hair, you could maybe add another loop cut here and select this loop with Alt, and then hold Shift Alt and select this loop, and then select this loop, and then also this one as well, like so. And then you can do Alt E, extrude along normals. Now you can see it's kind of uneven, so maybe you like that, but you can also hit S to make it scale evenly when you're extruding along the normals. So you can move it up a little bit, and you can see we kind of have like a Elvis Presley sort of haircut here. And of course you can always make adjustments here, like GX and kind of so on and so forth. And again, if you don't want to extrude it from the head, you can totally separate this by selection first, and now it becomes its own thing. And then you go into edit mode and so on and so forth, just like that. I should mention, if you want to quickly get rid of a loop cut that doesn't change your geometry, you can do Control X to quickly dissolve that. If it does change something like this and you do Control X, it might completely mess up your geometry, so just be careful of that. And sometimes it won't actually remove the loop cut if it's a major part of your geometry, so just be careful about that. And then of course you can do that duplicate by selection thing. So what you can do is Shift D duplicate, right click, cancel, piece separate by selection. You don't have to use a mirror modifier, but if you want to, you totally can. Go into edit mode, select these, extrude it down or something. You know, I don't know, it's really up to you. You know, add loop cuts and kind of just play around with it. So maybe you want this one to go down this way, and then this one you kind of want it to go a little bit like this, like down here. You know, so maybe you don't want a mirror modifier, but you totally could. So you kind of have that swag, and then maybe some, you know, like a mohawk or something. So you can inset over here, extrude out like that, and then we got some swag hairstyle like this. So what I'm gonna do for my hair is kind of just like get an arbitrary shape. So I'm gonna go to side view here, and what I'm gonna do is select this and select the side of the head, Shift D duplicate, right click, cancel, piece separate by selection, and I'll just call this hair. And then let's also set its origin point, because right now it's sharing the parent object's origin point. So right click, set origin to geometry. And let's go back and let's just scale it down to, I don't know, like some sort of shape that I want. And all I'm doing right now is kind of just like making it the kind of the shape of the hair that I want. So maybe you want it to come over a little bit. So you can totally do that. And what I'm going to do is go, and then I'm going to add like a loop cut here. And then I don't know, maybe like a loop cut over here, because I kind of want to bring it down a little bit. So I'm going to select these two and kind of bring it down a little bit here. And then maybe I kind of, maybe I kind of want another loop cut. I don't know, maybe around here. Then I can hold Alt to select this loop. Obviously there's no loop because it's a plane, but it'll do the same thing. And then I can move this a little bit because maybe I don't want this to be, then I'll just select these and extrude over down here a little bit. And then I can expand over here. Kind of want some, GY. Let's move it in the back a little bit, just like this. And then maybe extrude this down a little bit, just like so. So you can see we kind of have our hair there, and I'm just going to position it a little bit better there. Okay, now what we can do is add a mirror modifier, like so. Let's just go in here and do this. And then what we can do is go into edit mode. And if you want to quickly select this whole thing, you can do Alt, but you can also hold down Control, and that'll pick the shortest path between your two selections. And then you can just do E, and then lock it on. For me, it's on the X-axis. Oh, make sure you turn on clipping, GX, so it smashes together. Same thing for this side. So what we want to do here is hold Control and select this, and then do E, and then lock it on the X-axis and snap it here, like so. Now, because we extruded the top here, as well as the back here, what we have is two vertices here. So this is what you can see, that they're overlapping, and we don't want this. So what we can do is hit A and merge and by distance. And if you adjust this, you can see removed one vertex here, or you can change it up a little bit. But again, we only had one overlapping vertex, which is this one right here. So it kind of just merged it. Now you can see when I move the vertex, it's not overlapping or anything. So instead of doing Alt E extrude along normals and hitting S to scale evenly, which we totally could do, that is a destructive procedure, which means later when we want to change this with Alt S, which is scaling along the normals, it's going to be really, really kind of messy. So instead of extruding it, what we can do is actually add a modifier called a solidify modifier. And now you can see when I increase its thickness, it might be going the other way, but you can change that just by dragging this other way or changing the offset. and then clicking even thickness, right? We want even thickness, and then you can do that a little bit. Wait, let me just zoom in so you can see what I'm doing here. And now we just play around with this, and until we apply this modifier, we can just keep on adjusting it until we get something that we like, and that way we don't have to keep selecting everything every time and adjusting it. Now, because it's a modifier, you don't actually get to edit this stuff that you're seeing because it hasn't been applied yet. So you only see this, and if you adjust this, it's going to adjust the solidify modifier. Now, in edit mode, if you want to hide it, you can click this, and then when you go into edit mode, you don't see it anymore. You can do the same thing for object mode and hide it like that. And as you can tell by using solidify instead of extrude, we kind of have a more procedural workflow here. And then of course, we can still edit it. We can still go in wireframe, bring this down a little bit. It's kind of clipping inside, which is okay. Yeah, and it doesn't really matter that it was clipping for us, but like I'll just keep it outside. Yeah, so we kind of have all our parts of the character. Just play around with it, edit it how you want it. There's really no right or wrong answer here. Kind of just have fun and create your character. All right, now we can start being a little bit more organized because we have so many objects. So what we can do is just box select everything, or you can just come to the outliner and kind of select what you want. So like so. So if you want to skip one in between, what you can do is click the first one, hold shift, and it'll select everything between. Then hold control instead, and that'll add to the selection. And then you can hold control shift, and then it'll select everything between this and this one. That way you can avoid this, because if you just hold down control, it's just going to select two of them. But if you do shift, it's going to select the one in the center, or you can hit control and click it on it twice to deselect it. Either way, lots of ways to do that in the outliner. Then hit M, new collection, like a new folder on your computer or something. And you can just call this character or whatever you want. And then for the tree, you can show the tree again. You can see now the tree is a little too small, or maybe our character is just too big. It doesn't really matter. Either way, one of them has to change. So I just moved my tree up a little bit, new collection, and we can call this trees, and then create that. And then by putting in a collection, you can quickly hide everything. So you can see if I minimize these, I can disable both of them or re-enable them just like this. Super, super cool. And then of course, if you want to give some clothing, maybe like a dress, maybe you can delete this and just bring this up here. So we have snapping, GZ, just snap it here. I don't know, maybe add a loop cut here or something. Hold Alt to select everything. Alt, maybe just separate by selection so it becomes its own thing. So it's technically a belt, then hit Alt-E along the normals, S to scale evenly, and then maybe you kind of have like a dress here or something, maybe something like so. And then you could select the inner loop. Holding Alt, you can select the inner loop here, S, and then do Alt-S to scale along the normals a little bit, scale evenly with S, maybe something like this. And then you can inset this a little bit like so and kind of extrude up here like so. And then you can go into edit mode, wireframe, select this side. Let's select the back as well. Let's go into solid view, GX, and just smash those together. So we kind of have a dress there, and then maybe scale it up a little bit. So yeah, now we kind of have a dress. Same thing with the footwear. I don't know, maybe you want some boots here, so you can like select this. Alt-E, select this loop, Shift, select these as well. P separate by selection, so they're kind of their own boots now. Maybe a loop cut here, Alt-E along normal, so we kind of have some boots here. Yeah, I don't know. Yeah, so then we have boots. We can hit F2, boots. This, we can call it dress. And then it looks like we have something extra here, so we can go into edit mode, wireframe, delete this face here, go back. And then if you don't want it completely like a stick figure, you can add like a loop cut here and then like extrude this face out here, so it kind of looks like they have hands. Yeah, so a lot that you can do with what we're doing here. Yeah, so I mean, honestly, just like play around with your model, do kind of whatever you want. I'm gonna deselect these, maybe scale this down a little bit. Like so. Let's see, really up to you what you kind of want to do with your model. I mean, you have so many opportunities. And then maybe I want heels, so I'll give it like 2 loop cuts here or something. And then I'll delete these like so. And then now I kind of have these gaps here. So what I can do is actually select these edges and hit F to fill them. So like here, I can select these two edges, hit F to fill. And I can select this loop here with Alt and hit F to fill like that. And then here I can have some heels. And then it looks a little bit too big, so I can go into edit mode, wireframe, probably select these. Whoops, let's go to edge select and just select these. GY, move it up a little bit here. Kind of like so. And then maybe scale this down a little bit, SC a little bit up, like so. Maybe bring these down a little bit. And maybe the head is a little bit too big, but now we have an issue here because it's going to take the average of the origin points to scale, and you can see when I scale this is going to happen. So what you could do is apply your modifiers, and now when you scale it, and then reset objects at origin to geometry, and then it'll work okay. But we don't want to get rid of our procedurally modeling yet. So what I'm going to do is select this object, do Shift S, and do cursor to selected. And if you come up here, you can see by default, it's on median point. It might be bounding box center for you if you're on Blender default, but you can change the transformation pivot point to 3D cursor. So now when I select both of these, you can see it's going to scale around the 3D cursor rather than the average of these origin points. So if you want, you can make your head a little bit smaller, bring it down a little bit like so. Make sure when you are changing your other things, like you do bounding box center, right? Because if you select all these, you can see it's going to start scaling around the origin point, and maybe you're okay with that. You know, if you want that behavior, or if you just want bounding box center, which is I assume is usually the default. For us, median points and bounding box center doesn't have a difference for us. Then you can also see things like individual origins. So you can see each of these are getting scaled along their individual origins rather than the average of them, like so. I guess we could have also done active element. You can see active element. So because this orange one is active element, it's going to scale along the origin point of this object here. And you can see it's the same thing as moving our 3D cursor there. But yeah, I'm going to leave it on bounding box center. And then maybe you want some shoulder straps. So this is kind of being covered. So what we can do is go into wireframe, select this. GZ, just snap it over here so it's not overlapping or being hidden. Go into edit mode. 2 loop cuts maybe, SX like so, whoa, SX like so, and then GX just to move it somewhere. 3 face select, hold Alt to select the whole loop, Alt E extrude along normals, S to scale evenly, maybe a little bit along the Y a little bit more, like so, and then we kind of have some shoulder straps here. Now if you don't like how everything is blocky, I intended to keep everything blocky just for simplicity purposes. But you can totally do a little bit more advanced things, or you can hold Alt to select this loop and scale it up a little bit. And you can see it's no longer blocky. It kind of gives a more outward vibe. You can also just select both of these if you want this a little bit wider than the sides, like so. Yeah, and then obviously there's a lot of other things that I'm not covering in this tutorial. For example, if you want to like bevel, you can do like Control B and use your mouse wheel to adjust the number of cuts and things like that. And you can see it just makes it a little bit more curved, and then you have a lot of other options here. So obviously there's a lot more than you can do than what I'm showing in this video, but I'm trying to just keep it really simple. But yeah, I definitely want to show you all this cool stuff because I really like Blender and it's really cool. And after this video, I definitely encourage you to start exploring other creators and their tutorials and creating your own things. Of course, don't forget to save your file. Okay, so I have my updated character here, and make sure you have your updated character as well. And your character, like mine, if you come to that outliner, you should see all these wrenches, which means you have a bunch of modifiers on them. Once your character is done, don't apply your modifiers yet. What we want to do is in our character collection, right-click and duplicate the collection. This will duplicate everything inside of there. Then let's name this character, and then with modifiers, or alternatively you can right click create a new collection like so and just call this modifiers and then drag this collection into that collection. So if we ever need to change something, we can quickly come back here to the ones with modifiers to change that one instead. But now for now, let's just hide that so we don't see it. And now for our character, we can come over here and hit apply for each of our objects. Now that would be really tedious, right? We can do Control A or Command A if you're on Mac for every single one. But that's really tedious to apply for so many. So there's actually a really easy shortcut. If you just select everything, I'm holding Shift, select everything. If you hit F3 on your keyboard, there's this thing called Convert, and you type Convert to Mesh. And this will apply all your modifiers for you. And now you can see all those wrenches are gone. That's a very nice little hack that is good to know. We can start joining things that make sense together. So let's select, for example, here, Control J, and this will be our arms. So F2 arms, maybe something like this. This is the neck, that's okay. I can join the dress together. So I'm gonna select those, Control J, and call this dress. This is still legs. I guess I can just see the ones that are not. Okay, so this is hair. So we can join all the hair together. So Control J, F2, and just call that hair. Okay, so we have arms, and you can use your arrow key your up and down arrow keys just to look at what you have. All right, so let's start adding some materials. So you can select any object you want, and coming down to the material tab, if you can't find it, it's right here. It kind of looks like a ball. And then you can hit new, and it'll add a material to that thing. And you can see it has a lot of things that kind of describes how it will interact with light and how it'll kind of look. So, right, you can like change the color, you can like play around with these and so on and so forth. But notice how we're not seeing anything update on our object. And that's because we're still in solid mode. So now what we can do is go into material preview mode. And now you can see when I change the color, we can see the color is also being changed. I can also do things like change the roughness and then change how metallic I want it. So if it's really metallic, I'll turn it to 1 and so on and so forth. Now it doesn't look like anything like we expect it to look, not in Three.js and not even in Blender. And that's because we're in this mode called material preview mode. If we want to be a little bit closer to what it'll look like in Three.js, we would go into rendered view. Now I don't want to do it in here, so I'm going to go back to solid, and Blender actually has a dedicated tab for us, all set up for us already to start adding materials and lighting to our scene. And that's what they call shading tab. So if you click on the shading tab over here, you can see that our object that we selected, it has a material, it has this thing called a principled BSDF node on it. So these are things what we call nodes. And if you adjust it here, you can see it also updates in the material panel over here. The reason we use this node-based system is because it's a lot more visual and a lot more easier to craft custom materials when you need to. Now we don't have to worry about that because we're just going to be using this default material. But in the later you can see all these nodes and you can create like functions to create custom materials and so on and so forth. Anyway, by default in the shading tab, you can see we're already in material preview. But we want to go to rendered view. And this way we can actually see lighting on our scene that kind of looks a little bit more like Three.js. So if I go to rendered view, you can see that we still can't see anything. And the reason for that is because we don't have any lighting in our scene. Now I disabled the collection with my point light in it, but let's see, I turn it on. You can see my point light is there, and you can see it's starting to cast some light there. So if I turn up the power, you can see, okay, now it's affecting the mesh. And if I bring it closer, you can see, oh, it's starting to light up our object. And now I can also like Shift A, add a different other kind of light, maybe like a sunlight, and you can see the shadows are adjusting to the sun. And now you can see when I play with something like the color, like so, and the roughness. Let me get a little bit closer here. You can see there's going to be a little bit more reflection like so. Now, if for some reason you don't see nodes, make sure you check mark use nodes over here so you can see it. And if you select an object with no material, you're not going to be seeing any nodes here. Now, the reason it won't look exactly the same way in Three.js is because Three.js exists in a browser and it does its own mathematical calculations, whereas Blender, you know, it's its own software and it does its own mathematical calculations for the lighting and things like that. And the other reason is because there's different kinds of materials. So if I go into Three.js, you can see there's this thing called Mesh Basic Material. And if you scroll through the properties that it has, very few of those properties also appear on our principled BSDF, right? Like metallic is missing, roughness is missing, but this is the best performing material, which is why it exists. And sometimes this is all you need. Now, if I search for mesh standard material, like so, you can see that if you want to read it, you totally can. But you can see here that now we also have the roughness and the metalness factor, which is exactly what we have in Blender. I'll talk about that a little bit later, but I just wanted to draw that parallel right now. So when we use this material and we export it to Three.js, it's going to automatically convert it into a mesh standard material, which again is more performance intensive than a basic material. But for us, we need a standard material, so we're going to be using a standard material. So if you want to know how it looks, you can just play around with the sliders on the docs, whereas in Blender, you're going to have a very different result. So now you might be a little bit confused. You're like, okay, I've seen all those cool things on Blender. Like, why does ours not look that cool at all? It kind of looks a little bit lame. The answer is, in our render engine, if you come over here, we have two render engines. What we're on by default is called Eevee, and this is the real-time rendering engine. So it's going to be less realistic than Cycles, which is a ray tracing engine. So there's a lot of options in Eevee that are optional, depending on what you need, that you can activate, and it'll get fairly close to Cycles, if not indistinguishable at certain, depending on the job that you do. But before I talk about that, let me just quickly talk about roughness, because this is kind of the one that we're going to be playing for a little bit. So if I just take a screenshot. So roughness basically just says how rough is a surface, or how rough is the material. So let's say your surface is like this, and you can imagine like it's a knife or something, or like a sword, right? And like a metal sword or something. When it's really smooth, what happens is the light just bounces right off of it, right? So imagine these are light rays, it's just bouncing straight off from it. So that's what gives it that shiny appearance, because the surface is so smooth, it's reflecting all this light, it becomes shiny. So if you increase the roughness to 1, which means super rough, you can think of something like dirt. So you can imagine this is dirt with all the crumbs and everything. What happens to light is it pretty much like scatters over here. So the opposite of shiny, I think like matte or dull, they call it. That's what this will look like. Whereas if you turn the roughness to 0, it'll look really shiny. So if I go back here, you can see when I turn the roughness down, it kind of starts looking like plastic. And if I turn it up, you can see it's very matte and dull. And if I turn this up and turn up the metalness, you can see it's starting to look like aluminum or like a knife or something like that. So if it's shiny, then we should expect to see some sort of reflection, right? So if I turn this roughness down, how come we don't see anything? We're in this real-time engine, and it's kind of saving on performance by not doing all those calculations. So you can tell it to turn on by clicking ray tracing. And now you can see that we can start moving this around and seeing those reflections on our semi-shiny surface here. Now, again, you can just watch here, but when I switch to Cycles, it's even more realistic. So I can hit Control Spacebar just to expand this window temporarily, and Control Spacebar to go back, but you can see that it's a lot more realistic in Cycles compared to when I go into Eevee, right? So look at Eevee, look at Cycles. Cycles is a lot more realistic. For us, we're not going to be dealing with the render engines too much at the moment. It's just good to know for the future. If you want to know how your material might look, I suggest coming to the docs and just putting it in here to see what you like. So let's start adding materials to our object. So what I'm going to do is just expand this a little bit. And if you want to close a panel, you can come over to the left and join the areas by clicking and dragging when you get this cross area. Or you can right click and do join left, and it'll close that for you. So I'm going to stay in material preview. I don't really care about render too much. And what I'm going to do is just go for a very sort of semi-shiny roughness, maybe like 0.4 or something like this. And then for the color, I kind of want to go for like a skin color, so maybe something like that. And it'll be for the arms as well as the neck. So I'm just going to hold shift and select these. And then with this as the active object, instead of trying to replicate the material, I can just do Control L and do link materials. And now these will have the same material as this one. So now when I click on here and go to material, you can see it's sharing the same material. And then I can rename this skin, for example. And you can see it's called skin down here, and it shows you this number 3 here, which means 3 objects are using this material. And you can see that indeed they are. Same thing for the legs, for example. Instead of creating a new one, I can come here and select skin, or I can do it in the shader editor and select skin as well. So I'm going to do the same thing for hair this time, but this time I will add a new material. I want the similar roughness to the skin, so 0.4555, so I'm just going to copy that. go back to the hair and copy that in there. Now, if you don't want to do that, what you can do instead, let me get rid of this material by hitting this minus sign here. What you can do instead is come over here, select your skin material, and then hit this duplicate icon here. And what this will do, it will make a copy of that material, so it'll save that roughness data. And then what you can do is just adjust the material appropriately. So you can see I'm kind of bringing it down a little bit here, just like so. And now instead of naming it skin, I can name it hair, like so. Okay, but now what about this dress? What if we want to give different colors to different areas of this dress? Well, we can do that by hitting the plus. This time, it'll say, okay, this object has 2 materials to it. Now, right now it's empty, but we have 2 material slots. So what we can do is, again, select our hair material or skin, duplicate it, and this one we can call this dress, and you can call it red. And then for this one, we can do the same thing. So this one we can also do dress red, duplicate it, and then here we can call it dress white. And then for dress white, we can come over here and just, I don't know, maybe change it to like white or something. And then what you can do is go into edit mode and select the faces that you want your specific materials on. So let's say maybe at the bottom here, I want white, so I can hit assign. So now this has all the white. Now this has the white material, and this one has well, this is brown, so let's maybe make it a little bit more red, right? So maybe something like this, like so. So that's how we have it. And if you want to, you can add another loop cut, and a loop cut like here, so maybe you want a stripe here of white and hit assign like so. So now you have like a stripe there. Super awesome. So again, you can do the same thing for the boots as well. You can select one, dress white, maybe duplicate it, call it boots. And then I don't know what color this should be, maybe like orange or something. Yeah, and I don't know what color this should be, maybe like brown or something, I don't know. So for our eyes, what we can do is actually add another mesh. So I'm going to shift right click to put the 3D cursor somewhere arbitrarily on here and add a plane like so. And then I'll do RX 90 like so, scale it down a little bit, and then SZ like so. Now I don't want it overlapping, so what I'm going to do is go into edit mode and just hit E and extrude it just so slightly. And then I go into local view, go back here and delete this back face because we'll never need it. And then come back out a little. Now it's still clipping inside because the rotation of the head probably does not match the rotation of this. So what I can do is come over here and look at the rotation on the Z, and you can see it's 180.69. So what I can do is come over here, hit N, and then do 0.69 here. And now you can see our eyes. Now you can see our eyes all good. And then let's just scale it down a little bit. SC looks kind of creepy right now. Then again, let's do a mirror modifier here. Mirror modifier. Select our object right here, which is our head. And then we can give it an eye material. So we can do new. We can call this eye. Whoops, I could have duplicated it, but honestly, it doesn't really matter. No one's going to be paying attention. And then we can change it to something like very dark there. So if I go back, you can see, okay, there we have our character. And again, if you want to, you can go into render view and kind of take a look in Eevee. And if you want, you can try in cycles and so on and so forth. So my character is done. Just make sure the eyes, you rename those eyes and make sure they're in your collection over here. I accidentally left them outside. Let's also make sure to have a copy for the one with modifiers. So Shift D duplicate, right click cancel, and then just hit M, and then go into modifiers, character with modifiers, and move eyes 0.001 into there. It's automatically hidden, so you can't see it, but you can see it is indeed here for us. Super, super cool. So now we can apply this eye mirror modifier. Alright, so let's just go to solid view, hide our character, and go back into layout. Yeah, so honestly, I don't really know what's next. I do recommend you just try and make variations for these. So like for the tree, for example, maybe let me just do Shift S, cursor to world origin, Shift A, add like a plane or something. Just move it over here, scale it down, and then, I don't know, go out, edit, extrude, add some loop cuts over here, make a tree branch like here, and then add another loop cut, extrude like here, select this, Alt-E, extrude along normals kind of thing, right? So then you can make different tree variations, so maybe another loop cut here, E extrude over here, like so. I'm just doing it quickly, I'm not even thinking about it. Alt E along normals, so on and so forth. Like totally okay. You know, and then you can just keep making variations to your trees however you want to. It's really kind of up to you. So yeah, just play around. I'm not even thinking about it. I'm just having fun making my trees. And so on and so forth. Yeah, make variations, and then if you want to do like grass, for example, like I'll call this like grass, for example. Go into edit mode, E, extrude. You know, it doesn't have to be anything complicated. You can just make some grass strands just like this, like so. And this would be considered grass. You can make flowers, so let me just make like a flower or something. Again, it doesn't have to be complicated. E, Alt E, extrude along normals, so on and so forth. E, extrude along here. Maybe E, extrude along one more time. And then maybe E independently this time, so we don't have them joined. So then we kind of have like flower petals, right? So this kind of looks like a flower, albeit a very low poly flower. And then you can like move these up a little bit. So GZ, and then you kind of have like a square flower if you materialize that. Of course, you can make this a little bit thinner. So S, I'll probably scale that down a little bit. So you have a flower, you have some grass, you have some tree variations. And then you can make some rocks. So let's add a plane again. And then you have something like, I don't know, GX, SY, E extrude, maybe inset here like so. G Shift Z, move it somewhere over here, extrude a little bit here. And then maybe Shift right click somewhere, Shift A, add a plane, go into edit mode, E, and extrude out. And then make some smaller rocks over here randomly, something like so, GZ. And then maybe something on the bottom down here, so maybe some more crumbs over here. Now there is a lot of overlapping geometry, so ideally you don't want that, right? So you would select it, GY, and snap it to the face, right? You don't want it overlapping. But again, you know, it doesn't really matter for us that much, so if you want to just leave it overlapping and not put in the work, that's totally fine as well. So then we can all join these together, and then this would be like one rock variation. You got a rock, you got a flower, you got some grass. Of course, you can make grass variations. You can make as many tree variations as you want, and so on and so forth. And of course, you want to give them materials. So this rock here, we can create a new one called rock, and just make it like gray or something. Flower, it can have several. So again, add multiple material slots. One for the center, which will probably be like white or something. So I'll just call this. So I'll just call it flower center, and since it's at the top, the whole thing will be white. But I can just do Control I to inverse, and I'll call this petal, and I'll make this like a rosy red or something, and just hit assign. And then let me just select these faces down here, and I'll call this stem, and I'll just make it green or something, call it stem, and hit assign. So let me go back into my preview. So there we have our flower, and then we can create grass. And then here we can add some design to our trees. So add like a loop cut, and then maybe something like so. I guess I also want a loop cut down here. And then we can add like 3 materials. So one we can call a trunk, like so. We can make this a little bit brownish. So that looks okay. And then what we can do is select this whole thing. So let's go into over here, just like so. Hold Control to deselect that. And then I also want to select this top. So I'm going to hold down Shift and select the top. And then, whoops, I have to deselect this again. Cool, just like that. Let's go back to material preview. Let's create a new material and call this tree leaves, like so. And then hit assign, and it can be like green or something. And then these bottom faces here can be a little bit more darker green, for example. So I can do new, and I'll call this tree leaves dark. Assign it here, and then maybe make it a little bit darker in the green area. And this, I don't like this green at all, so I'm just going to darken that. And yeah, I mean, honestly, I don't really know. There's just so much you can do with like planes and cubes and cubic worlds, right? Like even if you want a fence, you can extrude a little bit, and then SX, make it a little bit thinner. Whoops, sorry, we probably should add a loop cut first, but that's okay, we can add it after. Let's go into wireframe, just bring this up a little bit, and then scale it down. Go into edit mode, SY. And there we kind of have like a fence for our places. And I don't know, maybe you want like a car or something. So maybe create a car shape. Let's XX a little bit, SY, I don't know, something like this. E to extrude it up, 2 loop cuts like so, SX scale it up a little bit. Maybe move this back a little bit and then extrude this up like so. And then, yeah, just hit A to select everything, kind of make it a little bit bigger. Shift right click somewhere, Shift A, add a plane, RX90, go into edit mode, hit A to select everything, E to extrude out, and then maybe just move it a little bit like so, S, make it like a little bit bigger, and then give this a mirror modifier like so, and then select our car object, and then we also want to do it on the y-axis, so our single mirror modifier is now making a car. And then we have a car here, so totally like that. And then we can maybe add some like loop cuts here, SY, and kind of extrude the center here. So we can have something like so. So I don't know, maybe a few more tricks that I like to talk about. So if you have a numpad, you can do Control+ to increase your selection. Also come up here, select more or less, and select more. And you can see that it's doing the same exact thing. And if you want to repeat the last process you can do Shift R, and it'll just repeat that last process that we did, which was more. Then if you want to select all the linked objects, you can do Control L. Since everything here is connected to each other through extrudes and insets and things like that, it'll select everything. But let's say this rock here, for example, which were all separate objects, right? If you're going to wireframe, you can see none of them are joined. If you just select anything, even like a single vertex, and do Control L, it'll select the entire linked object thing if it's connected. So you can do like Shift or something, like on 3 different things, do Control L, and then I'll select those 3 different objects. So really fast tip there. So a few more tips and tricks there if you're curious. Yeah, so just make some stuff and give him some materials, don't forget, and I'll see you on the other side. So what we want to do now is add our ground. So we can do Shift S, and let's just do cursor toward origin and Shift A and add a plane. And this will be kind of our walking area. So if your plane starts clipping, as in you can't see it anymore, what you can do is hit N, come over here, and go into View, and change your end to something a little bit larger. I think by default it might be at 100, but you can change it up to 1,000, like so. That way you can see more of your plane. Obviously it depends on your computer performance, but most computers should be able to handle 1,000, especially in solid view. Particularly in solid view, it should be okay to hold a little bit longer end here. And of course, now your objects might be a little bit inside, so just make sure they're up a little bit. And then for a character, now we can kind of join our character all into one object. If you want, again, you can safeguard it and duplicate this collection, and just call this before joining, character before join, and then hide it if you want to. Doesn't really matter anyway. I also noticed I have a plane added into my character here, so make sure I also do have that, so let me delete that with X. Let's hide that, and this is actually our ground plane. So we can move this to a new collection called ground, create so, and then for all these we can just select all of them, and for us we want the origin point at the bottom, but none of the objects have the origin point at the bottom, so let's just select this one, Control J, and let's go into Control period, GZ, snap it to this vertex, and hit enter, and then just Control period to confirm that. So now we have the origin point there, and now we can turn on face select, face snapping, GZ, and just snap it to the face there, GZ, hold Control, and just move it somewhere arbitrarily. Okay, so in Blender, there's a lot of ways to scatter objects around your scene. I'm not going to be covering those because I don't want to overwhelm you with so many Blender tools. So what we're just going to do is do Shift D and Shift D and just kind of move your trees how you want them. And if you kind of want them in like a row, there's this really cool modifier called array. So you come over here and do array. So search for array. It's also in generate. You can see the path of it. So add modifier generate. Array is also right there. And you can change where it's being offset. So you can do like diagonal patterns. You can increase how much you want, so on and so forth. And then, of course, if you don't want it diagonal, you can just do this, and then you kind of have something like so. And then you can just repeat that. And then you can shift deduplicate, RZ90, and so on and so forth. And yeah, kind of just place everything everywhere. Now, the whole time we've been doing shifty, and what that means is I'm creating a complete separate clone that's not linked to this object in any way. You can see when I scale and adjust this, it's not affecting this one. And that makes intuitive sense, right? But there's also this thing called instancing. So if I do Alt-D instead of Shift-D and just move it somewhere, like let's say here, and I edit this, look what happens. It's editing the original one as well. And then vice versa, if I edit this one, you can see it's going to be editing the instance of it. Now, the reason we have instancing is because if we have something that's identical to each other, we don't want to select all of them and change it. So one, it saves on time. And then second, it also saves on performance because we're kind of already telling the 3D software like, hey, this is identical, so don't waste your time trying something new for it. So if you know you want to adjust certain objects, you can do Alt-D instead of Shift-D. This way, next time you decide to change it, you won't have as many issues because you don't have to select both of them to change it. The last thing I want to show you is an image texture because somehow we need to display our projects into our 3D world. So let's quickly model like a sign. Honestly, it doesn't have to be that good. I'm just going to scale this up as something like a billboard like here. I'm going to hit I to inset in here and then E extrude inside like here. And this will be kind of our sign. Obviously you could like put a pole there or something, but yeah, let's just say this is our sign. Let's go into our shading tab. And here what I'm going to do is give it a new material. Again, you can also come here and do it. And I'm going to add another second slot. So one will be for the frame for the billboard, and one of them will be an image texture that we can put on here. So let's go to material preview. And for the frame, I'm just going to, I don't know, make it like brownish or something like that. It kind of looks like wood, right? And then for this one, I'm going to create a new one. Wait, let me just name this frame, and I'll call this project 1, like so. And this time in here, what we're going to do is do Shift A and search for an image texture, like so. And then plug this image texture's color as the base color of the principled BSDF. Then let's go into edit mode, select this face here, select project 1 and hit assign. So we can't see anything because we have no image here. So now what you want to do is find a project image on your folder. So you can just do open. I'm just going to select something. Okay, just do this. And now you can see my image is appearing there, but it's kind of messed up. And the reason it's messed up is because 3D software is doing mathematical calculations on a 2D image, trying to project it or calculate the 2D image position in a simulated 3D space, right? Because technically, when we're looking at a computer screen, we perceive 3D, but in reality, it's just 2D, right? So this point is further away from me in this 3D simulated world, but in real life, this point is actually the same distance from me as this point because my computer screen is flat. And basically, UV mapping is giving this 3D software a map on how to project a 2D image texture into a 3D space. So if I come over here and I go into the UV editor and I select this face, you can see this is the map that I'm currently giving it. So let me expand this a little bit. So if I hit A to select everything, you can see this is the map that I'm giving it. And as I move it around, I'm basically telling which 2D pixels do I want to show on this 3D face. So same with the other transformations, you can do G to move it, you can do R to rotate it, and you can do S to scale it, and then you can lock it on specific axes like so. Obviously, this one only has 2 axes, so you can only do Y and X locking and so on and so forth. Since it's rotated 90 degrees, all I can do is just do R 90. And then since it's going the wrong way, I can just hit minus after I typed in 90 and then hit enter to confirm that. And now I can just scale it up a little bit to get the thing, to kind of get everything I want, like so. And you can see now my project is fully there. Now it's really squished. And if you think about why it's squished, well, look how long my image is and look how long my frame is. This is clearly a lot more stuff that I'm trying to fit in something a lot more small. So what I can do is I can simply just scale it up along the x-axis, just like this. And now you can see that, hey, I do indeed have my project here. And now I can just uniformly scale it just to get something that I want. So I can scale this up a little bit, the outer frames of the edge, just to make it even. And there, voila. So now we have like a small sign with my project on there. And again, if you want, you can just edit the center instead. So you can do Alt S and scale this up, SY, SZ, and so on and so forth. And then you can select this and then just, increase this. And then you can just actually increase this instead in the Y direction to thin it out a little bit. Now, before we use these images, one thing we should do is compress them. Because if we don't compress them, they could be really large and cause a crash on our browser. So there's this really popular thing called Squish made by Google that is a free online, easy to use image converter and compressor. So let me just drop my image in here. And generally WebP format is going to be the smallest file size for the best quality. And you can see that on the right is after compression and on the left is before. So you can see we have a lot of detail here. And then when I switch it over, we kind of lose a little bit of detail, right? We lose a bit of the color as well. So if I turn down the quality way down, like, I don't know, maybe 9.8, you can definitely see, okay, we definitely lost a lot of detail there. We got discoloration, we're losing color there. However, look at it from far away. Like you can tell, but from far away is very, very difficult to tell. From close, it's almost extremely obvious, right? But from far away, it's very, very hard to tell. We reduced our file size by 96%, which means our experience is going to load significantly faster, and we barely lost any quality. So again, all about trade-offs here. If you need more quality, then you should go for it. But I don't really need that quality at all, so I can download it at 42.6. Now what I can do and go back in Blender is re-navigate to the WebP file and add it instead. And then I can go back into Solid, Material Preview, and then hit Alt-R just to refresh the images just to make sure. And then this doesn't exist anymore, which is why it's red. You can exit that out and then do PC background.webp instead. So it's the same image, it's just compressed in a smaller format, and you can see there's virtually no difference. Obviously, this is a lot more discolored now, but from far away, no one's going to be able to tell at all. And our camera will kind of be far away in our experience. So again, just to recap, let me take a screenshot of this screen. Right, so when we're working with 2D textures, we only have the U and V coordinates, right? Or I'll just say X and Y coordinates, so X and Y coordinates. Whereas in the 3D world, we have the Z coordinate, the X coordinate, and the Y coordinate. And somehow a point in 2D space, like here, let's say this is like 3, 7 or something. This point of 3, 7 has to go into some sort of translation here. Let's just say, I don't know, 5, 10, and 7, like so. And that's exactly what the UV map is doing. It's mapping a 2D coordinate to a place in the 3D world in a 3D coordinate. I guess I also kind of didn't expect why connecting this color of an image to this base color for this Principal Boot BSDF node makes any sense at all. So how does this work? Well, by default, we have this base color, and what's telling the 3D software is that take all the pixels that you see on your screen right now. So imagine your screen is a bunch of pixels that you can't see. Wherever this object is on your screen, it's going to be coloring those pixels as base color of white, right? This area of your screen is the pixels on its screen right now are white because we're telling the 3D software to make the base color white. Now, if I move this over here, the pixels on your screen over here are now being painted white. The pixels from over here didn't suddenly move over here. The pixels are still here. They're just changing their color. So what an image technically is just a bunch of colors, right? It's a bunch of pixels of colors. So if I really, really zoom in here, you can see we have these pixels, right? What a base color is, it's just saying all these pixels that you see here, this one, this one, this one, this one, this one, so on and so forth, just make it a solid color. Whereas for an image, for each pixel of an image, the color might be different, or it might be the same, or something like that. Now there's a little more complexity there, but if you don't think of it as like quote unquote a color and an image, rather an image is a combination of a bunch of random colors, then it makes sense that instead of using a full flat color, we can just simply use an image as our color instead. Yeah, so just to really drive that point home, like imagine you're looking at your computer screen, like out, not the software, just your computer screen in general. It's made up with, millions of tiny little pixels, right? And those pixels aren't like physically changing their location. They're just recoloring based on what's happening to the screen. So all the pixels on my computer screen that are showing this, those are going to be taking those colors. Now, when I rotate this isn't actually rotating at all, right? Because we have a 2D screen and my computer isn't rotating. It looks like it's rotating, but it's not actually rotating. What's happening is that let's say it was over here, the colors on the pixels on the screen are just coloring it in a way that it kind of makes it look 3D. So typically the mistake is when people look at this, they're like, oh, it's a color. And then when they look at this, they think it's an image. But an image is really just a bunch of colors. Yeah, so that was definitely a huge thing for me to overcome initially when I was first studying. So hopefully that makes sense. And if you need a better explanation, feel free to reach out. Yeah, so as I build my scene, if you want to make like a pathway or something, you could totally use loop cuts, right? Like cut over here a little bit, and then maybe add a cut over here, and kind of have like a path. I don't know, maybe something like here, and then you could give this like a dirt material. If you wanted to, you could either select these and like even extrude it downwards, so you kind of have like a downwards path. You could also just extrude it upwards instead, and then have like a upward path instead. So honestly, just use your creative freedom. And again, if you want to get rid of the edges that don't contribute to the geometry, you can do Control X to quickly dissolve those, or you can do X and do dissolve edges, just to make sure it doesn't break anything. Alternatively, you could make like pathways themselves, so maybe like a plane or something. You don't have to use it from the original ground, right? You can just make your own. SY, go into edit mode, E, extrude this up a little bit or something like that. And then maybe you want like something on the side. So maybe let's just delete this half, delete these vertices here, and then add a mirror modifier like so. Do it on the Y here. Then you can go into edit mode, add like a loop cut here, like face, extrude it upwards a little bit so you can have like a nice path walk there. And then you can shift duplicate this and make a variation. And then you can make like a modular, I don't know, maybe something that's can connect. So you can like select these and you want it to open, so you can like delete those faces. And then you can select these and fill them like so. Right here, you can select these and fill them, and then you can select these two and fill them. So now what you have is a pathway that's open and then a pathway that's closed off, and then you can make another pathway like so. And this one is like extruded a little bit. What we're technically doing right now is what we call modular components. Now there's more systematic ways to do it, to like make it snap to grid so you don't have to like manually place them every time and they'll like perfectly line up, and there's all those sorts of things. But I encourage you just to have fun rather than think about all the planning and everything, and just experiment, do something creative. So sorry, I forgot to talk about the camera because this plays a big role when we're designing our level. So let's talk a little bit about the camera. And if you don't have a camera or you accidentally deleted it, just, Shift A and search and add for a camera, and it'll spawn at your 3D cursor. Now, if you want to view your camera, you can hit, if you have a numpad, you can hit 0 on your numpad and it'll jump to your camera view. If you don't have a numpad, you can come up to view and click on active camera here, and it'll also jump to there. And you can see the hotkey, and you can see the hotkey for this is also numpad 0. So if we look at the camera, there's a lot of options we can play with. So here we have different types of cameras. So perspective, probably the most kind of common camera you see and use every single day. And then there's orthographic camera, and then panoramic. Orthographic, I did talk about orthographic views going in the side, right? How there's no distance changed from the camera. And this is the same thing with orthographic views. So let me go back into there, and let me change this to orthographic. And let me select this and do GY, and do GY. You can see it always looks the same size no matter how far away it goes from the camera. You can also look outside from the camera. You can see it still looks the same size as if it was here. If I select my camera again and change that to perspective, now if I move it back, you can see the trees definitely look a lot smaller than when they're up here, right? This is like 1.5 cursors. And then up here, it's now the size of 2 of my cursors rather than like 1.5. So if we take a look at Crossy Road, it seems more like an orthographic camera. They actually use something called an isometric camera, which some arguably use interchangeable with orthographic camera. But that's kind of like a topic for another day, and I don't really want to get into the weeds of that. Other than just kind of identifying that Crossy Road does not use a perspective camera, it is kind of a good enough direction. So let's go back to our camera view, and if you want to go for an orthographic one, you can, or if you want to go for a perspective one, you can as well. So if you want to quickly angle your camera, what you can do is move your view somewhere and then do Control-Alt-0. And what they'll do is snap your camera to your view. Now again, if you don't have a numpad 0, you can just align to the view that you want, come up to View, do Align View, and you can see the hotkey Control-Alt-Numpad 0, Align Active to Camera View. Other thing you can do is when you select the camera, you can just G and move it while you're in the camera view. And then you can do GX, and you can see it's moving along the X-axis, and GZ, and so on and so forth. Now, if you want to move it back and forward, you can do GZZ and hit the axis twice. So this is a new concept, so GXX. And what that does is it moves it along the local axis of that object, given its rotation, right? So let me show you this camera here, GX. You can see it's going directly on the X-axis. Now watch what happens when I do GXX. You can see it's now going left and right based on its rotation. Because if I look at this, the camera's rotated a little bit left, which means its local x-axis is a little bit slanted, whereas the global x-axis never changes, but the local one can. So again, if I rotate it a little bit like this and do GXX, you can see it's doing the local x-axis. Another really cool thing to know there. So again, you can rotate it, so RZ just to rotate it, and then you can just keep moving your camera with G, RZ, and so on and so forth. So if you wanted to do it that way, you could totally do it that way as well. You kind of usually use a combination of both. And then there's another option here. So if you go hit N and you come down to View and go into View Lock, you can do this camera to view thing. You can just use your regular hotkeys, right? Middle mouse button and Shift to pan, and just your camera will follow you as you change your view. So maybe you get something like this, or you can now try orthographic. And it'll be a little bit jumpy on orthographic, but that's totally okay. You can still move around just to see how it look, like so. And of course, you can play around with like the orthographic scale and stuff, and just, you know, see how that looks. Same if you're in perspective. I'm not going to be covering paranormic, but yeah, you can play around with this and so on and so forth. So once you get like a camera angle you like, you can just make sure that it looks fine. So when I do RZ90, that looks okay. RZ90 again, RZ90, RZ90. So that's okay. And then you can select your camera and just move it around your scene and make sure everything is looking okay. It doesn't mean you can't change your camera position later, but I think in this tutorial, we're just going to keep a static camera rotation and camera view the whole time. So as you traverse your scene with your camera, just make sure that everything looks okay and you're kind of viewing everything. Okay, so I finished my scene. I didn't spend too much time on it. You could totally spend more time on your stuff and put some cooler stuff. I was planning to put some more cool stuff, but I didn't want to spend too much time on it, so I kind of just made it into like a park. Just to recap, these are going to be our major ones that we need, which are going to be our project billboards that we click on and it pops up a user interface. So these are going to be the only ones that we're going to be interacting with. So I kind of just want to make a small recap on it, right? I'm in the shading tab up here on Blender. And if I click on it and go to the material tab, you can see I called it project 1. And it's just an image texture attached to the base color here. And then on the left here, we have, again, the UV editor, which is just our map on putting our 2D image into a 3D space. And of course, you can adjust it how you want. And of course, I'm on the wrong image here, so let's just find the image that I want to be. So it's this one. And you can see as I adjust this, we're just mapping this 2D image into this 3D space here. Same with this one. If I go into edit mode, you can see that I called it project 2. Same thing here. I also called it project 3. So I should probably rename this. So that's what I'm going to do. Whoops. I'm going to call it project 1, and I'll call this one project 2, and this one will be project 3, like so. And optional, but if you want to be organized, new collection, and just call it projects. So the collections you create in Blender aren't going to translate into Three.js, but for the Blender file itself, it's good to be organized. Yeah, so I'm going to go back into the layout tab, and I kind of just want to talk a little bit about my scene. This is a completely optional section. You kind of don't have to watch this if you don't want to. I might cover a little bit more intermediate things, but you know, it's you don't really have to watch this if you don't want to. So if you want to know how I created some of my things, like this ground here, if I go into edit mode, you can see that it's just a bunch of loop cuts. Wait, let me go into wireframe. You can see it's a bunch of horizontal and vertical loop cuts. So in Blender, if I add another plane here, let me just quickly add a plane, and I go into edit mode, there's this thing here called subdivide, which I'm just right clicking and doing subdivide, and you can see it slices it horizontally and vertically, and then you can increase the number of cuts here. So you can see I can kind of bring it up a little bit like so, and 10 seems to be the max, but you can always just hit A and subdivide everything again. And some people just like to right click and just do subdivide instead of play with the number of cuts. If I go into wireframe, this seems to be about the same size as this one. So let me just go into edit mode, and you can see that down here, it's a little bit extruded downwards rather than extruded up. And then what I did was I just went into top view, and I just did a selection of about 3 wide. Sorry, I should be in face select. Let me go in face select, and I just did a selection of 3 wide, like so, just using box select and holding shift. And then I kind of just like laid out my plan like so, like that. Sometimes I use the circle tool, which is another way to select objects, but I'm just going to show you what I did. So let's say this is kind of like my path, right? Then all I did was extrude downwards like so. What I do is I give it another material, and then this material is going to be for the regular grass itself, right? So I'm just going to leave this like yellow or something. But since that will be by default the yellow color, right? Let's just make this a little bit more pronounced. Then since I have the ground selected already, what I can do is come over here and create another material, which I'm just going to make something really noticeable, and then just hit assign. So then I immediately create my path. And since I have all of this selected, and we talked about growing, I think, in an optional section, you can grow your selection again with just Control+, and you can see it'll add to this side and this side as well. Or again, it should be in select and more, and you can see it's Control Numpad plus, which is more, which is the operation I just did. Then since we already assigned our path to the path material, we can just hit deselect, and now we only have the sides. So now we can just do Alt E, extrude face along normals, hit S to scale evenly, which is a new concept. If you don't hit S, you can see look at the corner when I hit S, it scales evenly, and if I don't hit S, it's not going to scale evenly. Now, these are already edge loops, so alternatively, you can just hit Alt and select them, right? And you could have extruded that way. So that's kind of what I did for the top here. I just hit Alt, and it selected the whole loop. Same thing here, I'm going to hit Alt-Shift and click over here to click onto the side. Make sure you don't get one of these instead. So just here, like so, and like so. And you can see now what we can do is just hit E and extrude it upwards a little bit. So that's how I made my path here, if you're kind of curious about that. Alternatively, if you don't like that method, the path could just be a plane, right? So you have a plane, right? Let me just see. Like the plane is going to be the base color. And then on top of the plane, let's say I'm just going to duplicate it like so. Go into edit mode, E, extrude it upwards. And wait, that's a little bit too big. Something like this or something. And so what you have here is underneath this green thing, it would actually just be the brown thing. So the brown plane right here, and this would be the green field or something like that. And then you could add some loop cuts. If you wanted to extend the path. So something like this, right? E to X, something like this, which is what we have here. So this would be a plane extruded outwards. And then you could totally just extrude upwards and add the edges that way as well. Additionally, if you wanted to do like modular components, which I mentioned earlier, these could be like a series of objects that you connect to each other and snap together with vertex selection. So you also have that option as well. Now, are there pros and cons to each approach? Definitely. It depends on your use case and things like that. Again, for us, I don't want to get into the details primarily because this is a beginner course. Now you might be wondering like, okay, there's so many vertices here. Is that going to affect performance? You know, why did you use this method versus like a method like this or something modular? It looks cleaner. Now it is true that if you have more vertices, you have more data, you have more information to store, and yeah, you might sacrifice a little bit of performance compared to something like this. But at the end of the day, speed matters a lot when it comes to client projects. So this approach is very, very fast. And if you know you're never going to change it, then just doing something one time is totally okay. I like if you were going to use this similar design system in multiple projects, I would definitely invest the time to make a more modular system with routes and paths that you could snap in and use later. What we're doing is kind of just like a one-time, oh, I'm never going to really change it later. So that's kind of why I went with the subdivide method. It's also significantly faster. I think making this path, which I just arbitrarily made up, took like 5 minutes. Whereas making modular components and snapping them together probably would have taken at least a few hours. So there's always going to be trade-offs. I don't want to get into the nitty-gritty details, but I do just want to highlight that there's multiple methods to accomplish the same thing, and I kind of hope that makes sense. So you don't have to understand all of them right now, just like in the future when you find these methods and you develop your intuition on what kind of method to use, definitely keep that in the back of your mind. So for the rest of my scene, they're fairly simple. Right here, you can see they're just a bunch of cubes that I have together. A lot of them are overlapping, and I said that was bad because we're wasting information and things like that. But again, at the end of the day, it's about being happy and being creative. So, you know, we do have overlapping geometry, but if it's not taking away from the aesthetic and it's not going to be affecting performance, which is something you'll develop later with your intuition, then you know, just have fun. Like you're just starting out, just focus on having fun and worry about optimization and all that stuff a little bit later. Now, if you are focusing on having fun and realizing that your scenes are crashing, then maybe that's the time you can start looking into optimization and things like that. But yeah, don't put too much emphasis on it, and you know, don't sacrifice your happiness for it. But yeah, if I just go into wireframe, you can see all of these are just cubes. Well, they were planes that I extruded upwards, and I just duplicated them over and over again. You can see like so. I just did like, wait, let me deselect this. Yeah, I just did like Shift D and then just moved them around, you know, whatever, like so. Here you can just see a bunch of loop cut, just extruded cubes and so on and so forth. So nothing really that special here. For the fences, you can see I have an array modifier like so. So I didn't have to duplicate those over and over again. And a really neat trick to flip something if you want to like put it the way that I do is just scale it in the opposite direction. So I'm going top here, Shift D. Whoops, I accidentally selected this. Let me deselect this. You can see I do Shift D and then I do SY -1, and you can see it's going to flip it that way. It's the same as if you did SY and try and flip it this way. So just SY -1. And then same thing for this side. If you want to flip it that way, it's just X -1. And you can see it flips it that way. And then SY -1 again. So you get this corner and so on and so forth. SX -1, and then you get this corner. So super cool there. So the last thing before we export this for Three.js is I want to add some text. It's actually really simple. If you shift right click to set your spawn point or your 3D cursor, you can just do Shift A, search, and type text. And you can see that we have text right here. And then if you go into edit mode, you can actually just start typing just like a regular keyboard. And if you want a new line, you can just hit enter and you can see that I have a new line. So it's kind of a lot like the other text softwares I used, like PowerPoint and Word and things like that. So what we're going to do is let's do RX90 and then I'll do RZ90 because I want them to be able to see here. And again, remember you can select your camera, come up to view, cameras, active camera or numpad 0 just to hop into camera view real quick. Come into your camera, select it, use G to move around, grab it and move it around just to make sure everything looks nice. I added some elements outside of the screen because if the user is standing here, I don't want them to see an empty outside. It's kind of like, oh, there's life out here, even if they can't actually ever go there. So you can see as I cross the edge here, I still have some stuff in the distance. So it kind of makes it feel a little bit more alive. Anyway, everything seems to be looking okay, but we want to focus on our text here. If you want to, you can optionally come over here and create a new viewport, and you can select 3D viewport, which will be by default because we split from a viewport, and leave this one in camera view, whereas over here, you can play around with this. And if you want to quickly maximize stuff, you can do Control Spacebar and it'll maximize this view, or hover over this one and Control Spacebar and it'll quickly maximize this one. You can do the same thing for this, or the outliner, and so on and so forth. Alternatively, if you don't like the split thing here, you can just right click over here once you get the 2 cross arrow things, and you can just do vertical or horizontal split. I'll do vertical in this case, and it'll do the same thing. Alternatively, you can go into F3, the global menu, and do split, look for split area, and you can just do vertical split. And you can see we get the same exact line. So you have 3 options there to get another view if you wanted to. Anyway, let me just do that again, and enter camera mode here. Okay, so on the side here, we're going to have our text. So let's just make sure we can see it. And let's make sure it's readable when we walk by it. So it seems to be okay here, which is great. So I kind of wanted to point to the projects. So I'm just going to call it projects. And it looks like I oriented it the wrong way, which is totally okay. RZ 180, just flip it like that. And then of course we can just add a sign. So I'm actually just going to shift deduplicate this, and then move it somewhere over here. I'm going to get rid of the modifier, and I'm just going to probably delete the top, I guess, and just fill this in with F, GZ, move it up, like so, probably, and then here, I think I'm just going to extrude it. You could add another mesh if you wanted to, but I'm just going to extrude it. And I want it big enough so the user can read it. So I'm going to go into wireframe and probably just, I don't want it to go upwards, but maybe I'll just go a little bit more downwards instead. But again, do it for your scene and how you want to do it. And then here I'm going to turn on face snapping, and I'm just going to do G, hold down Control to toggle it, and just move it across my face. Something like this. Again, we want it to be readable, so maybe select both of these and increase this, and then increase this a little bit, and then make this a little bit smaller. GY, cool. And since this is a text object, we can't just extrude it, right? We can't use the same hotkeys. There's no face select or anything like that. So what we can do is, you can see we have this object data properties tab down here, and you can see in the object data properties, there's this thing called geometry. And if you do extrude, you can see it's going to add some depth to your text. And you can see just 0.2, we have some depth there. Cool. Okay, now what I want to do is change the font. So if you close geometry and go to font, you can see we can change the font here. Now, I don't have a pixelated font, but if you do, you can just use that. I kind of wanted to match the vibe of the overall scene, right? Because we're kind of going for blocks, so this kind of looks out of place. So if you want to find fonts, you can go to Google Fonts. There's a lot of free resources too, but I just like to use Google Fonts because they have a free public license, I think, which means you can use it in commercial projects. So it's kind of just like a default safety thing, and I just typed in pixel here just to see some pixelated fonts. I feel like this will match. Not exactly, but, you know, close enough. So I'm just going to do get font here, and then I'll just do download all. Then just make sure to extract it, and you don't have to install it. You don't have to install it. You can just navigate it to in Blender. So come over here, go to regular, and just navigate to where you saved it. I saved it in my project folder, and you can see it's right there. So I can just double click there, and there we have our font. So now we can just scale it down, and maybe you want it in all caps actually. So maybe we can do projects. I don't know. Yeah, I mean, it doesn't match exactly, but you know, it's close enough, whatever. And I kind of wanted to point a little bit. So here I might do something. Well, let's extrude it first, GY, and then SZ, and just move it down like a point, like so. I don't want it to be completely merged together, so that'll be okay. And then let's just give this a material right now, and I'll just call this text. Honestly, not a big deal, and just make it like black or something. Yeah, GY, just move it across there a little bit more. I just want to make sure it's readable, so I'm gonna maximize this. It's kind of readable. I guess it could be better. Maybe we can make it like a brownish instead. Like a light brown, and that would kind of like stand out, but also match like the woody kind of vibe. Let's go into edit mode, And maybe let's go to solid here. Let's select these and hit I to inset them a little bit. And then what we can do here is assign a new material to it. So I duplicated from this and I just used a bench and dark bench material, which I could have named better, but anyway, I'm just going to, I guess, add another material, and I'll just call this inner sign and assign it here. And then it'll be like a light brown, so something like here or something. Let's deselect it, that's a little bit too orange. What I'm gonna do is use this eyedropper tool, select this, and then just raise it up a little bit. Cool, and then now we can make this text a little bit darker. Cool, so now we kind of have a sun like this, which if I go back, it looks a little bit better. I feel like the stick is a little bit too small for the body. So let's go into wireframe, just select that a little bit and do SY. Or we can just select this and do GY and move it this way instead. Let's see. So material preview, let's go back. Sorry, I can also be doing it here. I don't know why I'm just going back and forth. Yeah, so we can read projects, cool. And now what we can do is just shift deduplicate this, RZ90. Depending which axes you are, it might go to another one. So like so, and we want to flip it. So what we're going to do is SY -1, right? It's the same as doing SY and then just trying to flip it this way, right? So SY -1, it'll just directly flip over it. Now our text is wrong. So what we can do is take it, RZ180, and just reposition it GX. And I'll call this, I don't know, like main park or something. And now that I'm looking at it from lowercase, I feel like it looks better lowercase. So I'm going to go back to the projects and just call it projects. Cool. So let's maximize this. And yeah, when we're hopping around, like when our character is over here, this is the vision we'll be seeing in Three.js or whatever you determined it to be. And we will be able to read projects and main park perfectly fine. So now we can just convert the text to meshes, because right now they're just text objects. Now when you convert it to a mesh, then you'll have all the normal things when you go back into edit mode, and you can't type anymore. So this is destructive modeling, again, because you can't just come back and change the text later. So normally what you would do is make a duplicate, put in another collection, and that way when you need to change it, you can come back. Or you can just save a copy of your file if you wanted to. I'm never going to revisit this, so I'm just going to convert it now. So I'll do F3, convert to mesh. And now you can see when I go into edit mode, you can see we have our text, and we can go into phase select, vertices select, and all that other stuff. Okay, so let's just join it to the sign in case we want to move it later. It'll be easier to adjust that way. And now we can just, move it just like this if we want to. So yeah, we can just maybe move it to the edge, maybe move this grass thing out of the way. I don't know. And of course you could have put it on the same sign rather than have two separate signs. Really up to you there. Okay, so I'm going to close the camera view one. I don't think we need it, and we can always bring it back. Whoops, I accidentally just moved it. Join that, and honestly, and we're not going to be animating, so we can actually just get rid of this too, which we should have done at the start of the video. Okay, so now as you can see, if I scroll through here, I have a bunch of wrenches for a lot of things. And yeah, I didn't rename properly, that's fine. It's okay. But anyway, we have a bunch of modifiers. So right now what I want to do is, instead of organizing my file, I'm just going to file and save incremental. It's the same thing as saving a copy, except it'll just automatically just add a number. You can see I'm on 3 now because I've done 2 incremental saves already off camera. But it'll just add another file to your folder. Now you can do file save as, and then you can do this like before exporting or something like that. And this way you kind of have your state for the changes and then another one for after. So what we can do is hit A to select everything and do F3 and just do convert to mesh. And again, that will apply all our modifiers for us. So all of these used to be array modifiers. They no longer exist, but let me just undo that. So you can see this was an array modifier. These were all array modifiers like so. Yeah, let's do it again. A, F3, convert to mesh. It's right there, and just hit enter. And now you can see all the wrenches are gone. If I go through my outliner, we did have these that we would change later for organization purposes, but they're hidden, so it's all good. All right, so now we want to be able to click on these objects. So if you want them to be able to click on the object when they're hovering over here, like in their camera view, and it's over here, and they can click here to open up the HTML element, then I recommend joining them as one object, like so. For everything else, I'll say you can join them together other than the moving parts. So the character and all these signs, all of these other. So for all these other objects, technically on performance, it's actually better to join all of them, especially since they're not moving. So the way to do that is select everything that are moving. Everything else that's static, you can do Control I to invert your selection, means select everything that you didn't select originally. And then you can like select the ground or something and just do Control J. Cool. And now you can see that you have all of this selected here. And we still have this light here, so we can just delete that right now. We don't need that anymore. And the reason we joined them together is because of something called GPU draw calls. Nothing you really have to worry about, but it is an optimization technique to join things together as a single object. So if I hit period on my numpad key, you can see that ground is kind of all this, and then we just have our projects, and then we have our character here, like so. And then this is named boots, but I'm going to rename this and call it character. And the reason it was boots is because I joined all these objects to the boots over there. All right, so now we can do some optimization. Completely optional. We're not going to go into advanced optimization techniques, but just to save a little bit on memory, remember we said that we don't want to have these faces that no one will ever see. So if I go into my camera view, you can see that we'll never see the under bottom face of any of these objects actually. So what we can do is go into object mode and select this one. We can also select our projects as well. And if you select multiple objects and go into edit mode, both of them will be in edit mode at the same time. And what we can do is go into edit mode and we can just select a bottom face on anything. So it could be this one, or it could be on the bottom of this tree. Doesn't really matter. And instead of having to select every single bottom face to delete them, we can just do Shift G and it'll bring up this select similar, and you can hit normal. And you can see it will select all the underside face. So let's go into wireframe and you can see all the ones with their normals pointing down will be selected. Now, for some reason, if you notice that, let's go back into solid view, that your face is, for example, selecting upwards like this, for example, somehow on one of your objects, that means your normals are flipped. And the way to determine which way your normals are is to come up into Viewport Overlays menu and turn on Face Orientation. Now, face orientation is really important because normals kind of just tell the software which way the face is pointing and how to do some mathematical calculations to that face, pretty much. Right? And just to illustrate this, if I add a plane here and bring it up, you can see that on one side it's blue and one side it's red. So its normal is pointing perpendicular directly up and down. If your camera is in a view and you see red, that means it will be invisible in Three.js. So just make sure of that. And if you actually want to see that in Blender, you can actually come up here and turn on backface culling. I'm not going to explain that, but just in case you're curious, that's how you do it. And now you can see when I go here, the plane completely disappears on that side. Because the 3D software is normal, it's like, oh, the face should be calculated on this side, not this side. And if you want to flip it, you can go into edit mode, select that face, hit Alt-N and flip it. And now you can see it's invisible. Well, I have it selected, but it's only like so. You can also do Alt-N and you can see that there's other options here like recalculate outside, recalculate inside. And sometimes this will work perfectly fine, so you don't have to flip. So if, for example, I select, let me just make something like, so let me turn off backface culling. And let's just do Alt-N and flip. You can see all these are red. Now if I hit A and Alt-N, recalculate outside, it's going to fix that automatically for us. Now Blender won't always do a good job. So if I zoom in on the text here, you can actually see that this inner here needs to be flipped. So we can do that really quickly. Alt-N flip. Same with here, Alt-N flip. And if it looks fine with backface culling, then you might actually not even have to flip it. Same thing here. Normally you should flip your normals before joining your objects. That way you can do Shift G, select similar, and against normal. And if this text was by itself, it would select everything else there. But luckily, we don't have too many normals that are bad here, so I'm just gonna fix this up real quick. I don't think anyone will ever see that side, so we could probably delete that face, but oh well, it doesn't matter. Like so. And then we have like some small issues here, but probably not noticeable. So again, let's just turn on backface culling. We can get rid of the normals because everything looks blue, so we can come over here and turn off face orientation. Let's just go to material preview. And let's go into camera view, select our camera, G, like so. Yep, projects looks good, everything looks okay. No issue with backface culling. Cool. So now what we can do is select our object here, also select our projects holding shift, go into edit mode, and just select a bottom face, any bottom face, assuming it's blue, by the way. So okay, they're all blue, great. So let's turn that off and shift G and select by somewhere normal. And it seems to select everything on the bottom. Let's just check. Cool. And then I should just be able to delete these faces. And if I go back, you can see that we just deleted a lot of vertices, but nothing on our scene changed. And if I come down to the bottom here, you can see all our bottoms are completely gone from all our trees and everything. Super, super cool, just like that. So we saved out a little bit on our memory. Okay, let's delete this extra plane. I don't know why it's still there, so I just hit X to delete. And I'm going to rename ground to level. Then we have our project 1, project 2, project 3, and level. And then we have our character. So these are going to be the ones that we're exporting. Okay, so what I'm going to do is just organize this a little bit better. I'm going to create a new collection. So I'm going to create new, and I accidentally had it in here. Whoops, that's fine. I'm just going to move it out. And I'm going to call this for export. And I'll just drag these two in here, and then I'll also drag character in here. And then everything else, I'm just going to hit this check mark so we don't see it. All right, so now just move your character where you want it to spawn, so, or your starting point, not spawn, sorry. Well, I guess technically also spawn. So that's where my character will start. Okay, so now we're ready to export. Again, go into your camera, select it, make sure everything looks good. It's all good if you have to re-export. It's not that big of a deal. Things will happen. Anyway, let's come over here and just click our level, hold shift and select the bottom one. This is everything that we want to export. And let's do file, let's come to export, and we're going to be using this format right here. There's a lot of other file formats that you can export your 3D model as. This is going to be the most well optimized for the web. Okay, so now what we want to do is come over here and click remember export settings. That way we don't have to do it every single time. We can come into include, and we only want to do selected objects. That's why we selected these before. So we only want to export the selected objects. In transform, you'll see this thing called Y up. That just means up and down is going to be the Y axis rather than the Z axis, which is very standard to the GLB, GLTF coordinate system. So in Three.js, up and down is the Y axis, whereas in Blender, you can see that up and down is the Z axis. So that's something I'll talk about in a little bit. Anyway, let me come back here to GLTF, and you can see, and it seems like they didn't save that, which is kind of weird. Oh well. I probably have to export it before they saved my options there. Anyway, again, selected objects, Y up, this is all good here. Now we can go into data and open scene graph, things we don't have to worry about here. Mesh, you can see we have UVs and normals, which is good. Remember, we used those UV maps that we did for this thing right here, our project images. So we want to export those. And of course we want normals, which is why we checked them. So that's why we did that. For material, we can just leave everything default here. It might take off a little bit of quality from our images, which might not be a terrible idea. You can see that Blender also has the option to create WebP. We did that with our conversion software online, so we don't have to check this. If you don't want to sacrifice quality anymore, maybe just turn it up a little bit. But you can see export, we're exporting the material. And it's automatic, which means it'll take the format that we're taking, so we don't actually have to change this. And then just other things that we don't have to worry about. Shape keys is a more advanced concept, so we don't need that. Armature and skinning, things we don't have. Lighting standard, that's totally okay. And then we don't have any animation, so we can uncheck this too. Even if you leave these in, you know, it's not really a big deal. So, but since we don't have any of those, we can just uncheck them. So in some previous videos, I've covered these in more detail, but for us, we'll just include, you know, our selected objects, Y up, which is a standard coordinate system in a lot of 3D software, UV normals, and material, just export it like so. Yeah, so now you just come here and give it whatever name you want, and I'm just going to call it portfolio, and just hit enter and add .glb, and then you can just export it. Yeah, I guess I just want to credit the authors of the images that I got, completely free on Unsplash, so just there. Yeah, so now if you want to quickly view your model to make sure everything is okay, you can come up to 3js.org/editor and come to File, Import, and navigate to your GLB file. So this is mine right here, and I can just double click and insert it. So the controls are similar, but a little bit different. So zoom in and out is still middle mouse, up and down. If you want to pan, you're going to use right click. And if you want to rotate, you're just going to use left click. So slightly different controls, but yeah. And here you can see the green arrow is now up and down, which means it's the y-axis. Z is typically blue and X is usually red. So we can't see anything because we don't have any lights. So we can come up to add light, and you can see just like in Blender, we had all those different kind of lights, and same thing in Three.js, we have all different kinds of lights. So let's say I add like a directional light, which is like a sun, and you can see that it kind of just looks exactly like a sun right in Blender, right? If I add a sun in Blender, right? So you can see that it has the line to show which way it's rotating. And so here you kind of see that, okay, Three.js and Blender, they kind of have a lot of similarities. And again, that's very similar to like a real photography studio. Except instead of playing with intensity here, you might have like a small handheld device that plays with the intensity of your light, so on and so forth. So when you think Three.js is like Blender, is like, you know, your IRL studio, things kind of just become more natural to you. If I write this in code, for example, instead of tweaking it like this, you know, let me just, I don't know where to type it. Let's just put it here. It would be your light that you created, and then dot intensity, or whatever the property name is, and then you just set it. So like 5 or something like that, right? I don't remember the syntax, but that's pretty much it. So here we would type 5, whereas in code we would just like write 5, right? So Blender actually has this thing called scripting. So if you do some Python scripts, you can actually write code in Blender to make it do things. So you can actually like target your sun. I'm not going to write out the code, but you can target your sun, and then you can target your sun's property, intensity property, and then you can just set it equal to 5. So here you can see that when we're using a user interface, we're just using code that someone else wrote. And here you kind of draw the parallels between Three.js and Blender. So I hope that makes sense, and I hope that kind of clarifies things before we jump into Three.js. Anyway, right now, kind of just expect your model and make sure nothing is invisible. And it seems like nothing is invisible, which is great. So we'll revisit this a little bit later, but let's now move on to learning the basics of Three.js. So just create a new folder. So I'm just going to create a new folder, and you can name it whatever you want. I'll just call it Voxel Portfolio. Super, super cool. And I'm going to be using VS Code as my code editor. So you can download it free for Windows or Mac, but you can use whatever IDE or code editor that you want. It's not going to be that big of a deal for this. Okay, so now we just navigate to our folder. So now we just navigate to the folder that we created, like so, and just select that folder. So let's come here and create our index.html file, our main.js file, and our style.css file. Cool. And then in index.html, we can use this Emmet abbreviation, just exclamation mark, hit enter, and it'll fill out the default necessary stuff. If you're not familiar with Emmet, I'll be using it a lot, but you can read up a little bit on Emmet here, and then more on the Emmet website a lot. It's just a faster way to write code. If you don't want to use it, that's totally okay, but I'll be using it throughout. So we want to link the JS files and the style.css files. So we can do that. I'm going to use another Emmet script source. You can see it's already there. I can just hit enter, And then I just can go into my /main.js file like so. It's the same directory. So I'm just navigating there. And then we want to link up our CSS file. So link CSS, another Emmet abbreviation, as you can see here. Just go there, /style.css, and you can see it's right there. So let's just make sure it's working. Let's go into main.js. Let's do alert, and I'll just do hello world, like so. And then in style.css, we can do our global selector and do some resets. So P0, our Emmet abbreviation, rather than typing padding and then all that other stuff, we just do P0, M0, and then we want border box sizing. So whoops, box sizing, and then just hit enter border box. So if you're not familiar with box sizing and why we choose border box, it just makes consistency a lot better and width calculations a lot easier. You can totally read about it if you want to, but if you're familiar with CSS frameworks like Tailwind, Bootstrap, you know, it's pretty much standard just to use box size and border box. And if you've done CSS in the past, it's probably likely with border box. Okay, so now we need some way to run this HTML file so we can actually see what's on it. So what I'm going to do is go to this gear down here and click extensions and then look up live server like so. And here in this live server, you can see this top one. I haven't installed, so you'll probably see this. You can just hit install and then make sure it's installed and make sure it's enabled so you can enable it. And then when you come back here, you should be able to right click on your index.html file and see this thing called open with live server. So now when we open it, you can see it's going to navigate to our index.html file, and our alert that we created does indeed show here. Cool. So let's just make sure our style.css is also working. So we can just do a quick background color, aqua, like so. And indeed, it is also working as well. So if we refresh the page, cool. Everything seems to be working. So we can get rid of this. I'm doing Control X to quickly delete a line, like so. And then we can save all our files. Now, instead of going to each one and hitting Control S to save them, I have a keyboard shortcut. If I come over here, go to keyboard shortcuts and search for save all, like so, hit enter. You can see I have Control Shift S as save all files. So if I do this, Control Shift S, and you can press enter just to confirm it, but it's right there. This will just automatically save all my files. So if I hit enter, you can see this dot up here says it's not saved. Control Shift S, it'll save both of them just like that. Then we can use Control W to quickly close this tab, and we can also Control W to close that as well. All right, so now let's take a look at the Three.js documentation to get started. So if I come into the documentation, let's go to installation. It'll kind of tell you the two ways to use Three.js. So one of them is with npm and a build tool, which is what I always use now, but we're going to be going for a more simple approach, which is you import it from a content delivery network or a CDN. The reason we're going for option 2 here is for simplicity, and for beginners, using a CDN is probably more understandable and less overwhelming. So at the end of the day, Three.js is open source. All their code is freely available here, and if you want to, you can contribute to it. So Three.js, at the end of the day, is just code that someone else wrote that we're going to be using. You know, if you take a look at some of the stuffs, let's take a look at the camera. You can see like, okay, here we have a camera, here we have another camera, and it's got some stuff that we can use. And then obviously their camera uses other things that they've written and so on and so forth. So Three.js, all of this code is just an easier way to work with WebGL, which is the web standard for working with 3D graphics for the web. So in the past, there was a lot of other methods to work with 3D on the browser. Today, the modern standard is going to be WebGL, and it was like this for a really long time. And you can see if you go to Can I Use Website and type in WebGL, you'll see that all major modern browsers natively support WebGL, but now we're seeing the rise of WebGPU, which is going to be better than WebGL, but you know, we're still seeing a lack of support here. However, Three.js has kind of started transitioning to WebGPU, you know, as it becomes more supported. However, since WebGPU is not there yet, we are still going to be using WebGL. So WebGL is based on OpenGL ES, so it has its own quote-unquote shader language called GLSL, and it's a very low-level programming language like C, for example. So if I go in the docs, you can see, okay, it kind of looks like a bunch of math stuff, and you know, buffers. What are those? You know, really scary stuff. But I just wanted to point that out. Like WebGL, GLSL is very low language, which is why Three.js exists. Because if I go here and look up GLSL, and I don't know, just select one of these here. Now it ends in .js because they're using it as a JavaScript thing that they're exporting, right? So the file is in JavaScript, but the code in between the backticks here is GLSL code. So you could have a .glsl file if you wanted to. But you can see here, look at this, looks extremely scary. Kind of looks like C code, for example. So to really drive this point home, again, Three.js is code that someone else wrote. But I just want to kind of give a more metaphorical explanation to kind of show you how to think about this. So let's say you have a computer, and you have a 3D object that you want to put on that computer. Well, we know that computers communicate in zeros and ones, or that's their language, but humans aren't programming in zeros and ones, right? Not anymore, at least. So what we do is we create a programming language, and we call that C. Since this is pretty close to zeros and ones, well, that's kind of over exaggeration, but it's close to computer language. We call that a low-level programming language. And then we have high-level programming language like Python, right? And then Python is actually written, its base language is on C. You can see here Python is written in C. So for Python, we call this a high-level programming language. Now, typically, if the lower the language, the easier it is for the computer to understand, which means less work and better performance if you code with a low-level language. However, the lower you code it, generally the more harder it is for humans to understand. So that's why Python, for example, is a lot more popular than C, because Python is easier to understand. And it'll save a lot of time. When you work with a high-level programming language, you'll save a lot of time. And even though it might cost on performance compared to C, the trade-off is kind of worth that effort. That does not mean that Python is easy by any means, or whatever you do with Python. It just means that there's kind of this differential here that we distinguish as developers and people that work with technology and things like that. So this is kind of the same exact thing with Three.js. So while Three.js is not a programming language, it is a library that makes our life easier. And it has a bunch of JS code, JavaScript code, and GLSL code that makes our life a lot easier. So we can think like GLSL is pretty close to zeros and ones, right? It's like C. And then we have Three.js, which is like a little bit above that. And it kind of just makes things a little bit easier. So just an analogy to real life, if we have a camera, for example, a real life camera is a bunch of math and engineering feat, right? That's what a camera is. To a photographer, it might just be a camera with a bunch of functionality, like shutter speed, aperture, all that kind of stuff that they can tweak. Whereas to an engineer, they would look at it and think about the math behind it and things like that. So when we create cameras, simulated cameras in simulated 3D environments, well, that's a bunch of math, right? GLSL, a bunch of math, which is ultimately, again, computer language, a bunch of zeros and ones. So what Three.js does is they took the time to write all those math for us, so we can just use a camera rather than having to code the math to simulate a camera. So if you need more customization, you'd go very low level language and code your own camera. However, Three.js cameras are usually more than enough, perfectly fine. And then you can have something that's even more high level than these coding languages, right? And that's exactly what we just used, which is Blender. So again, that does not mean Blender is easy to understand by any means. It just means here at Blender, we're primarily working with user interface, right? You can write Python scripts and all that kind of stuff, but you're primarily working with a user interface, which is based on code that someone else wrote. However, at this level, you're working with a lot of code, but not very much math. I mean, definitely math, but not as much as a low-level language. So over here, you'd be working with a lot more math and code, whereas here, it's probably code and a little bit of math, or maybe a lot of math, but not as much as over here. And then with Blender, you're also working with math occasionally, but it's facilitated with a user interface. So again, this is not an entirely accurate metaphorical hierarchy, but hopefully it kind of shows you that everything is a little bit connected here and there, if that makes sense. A lot of times what I see is when people get into Three.js, they think it's completely different from Blender, for example, and it's a completely scary different thing than Blender. However, when you see the connection, it kind of becomes a lot less daunting to pick up, and it makes it easier to pick up. So hopefully the metaphor that I used here kind of helps you structure your brain when we dive into Three.js. You know, the worst thing you can do is think that something is difficult when you get into it. So I kind of want to structure your brain to think that, okay, Three.js is actually not that difficult. The big common mistake I see is that when people go from Blender to Three.js, they think, or vice versa, they kind of think these are completely two separate different things. Like, oh, Three.js is technical, it's coding, it's going to be much different from Blender, which is more creative and artisty and things like that. And then their brain kind of gets stuck in this loop like, okay, these are two separate concepts. I can't transfer anything over. My goal with this long explanation is to kind of create the connections that, okay, Blender and Three.js, yes, they're different. Yes, they're difficult to understand, but see the connection between them, and it becomes a lot easier for your brain to understand this when you're going into it because you have more confidence and you think, okay, I can do this. It's not that different. It's not that hard. By no means is it easy, but getting your brain into that mindset will make learning a lot better. So hopefully that helps. Again, it's not entirely accurate, but hopefully that helps. Yeah, so let's just come back to option 2, and we should just be able to good copy and paste this. They do have a CDN for us, so we should be able to just navigate to it to see it. So we paste it in here, replace the version number. Hopefully this is going to be the latest one. So just replace it right here, hit enter. Okay, and indeed you can see, look at all this Three.js code. You know, yeah, it's just code that someone else wrote, and it's really long. So if I search for things like camera, you can see we have cameras, a bunch of cameras, GSL, lots of really scary stuff. Yeah, so yeah, anyway, we have it there. So we're gonna go back and let's just copy this, go back here. You can do Control P just to quickly search for a file, go to index.html, and we want it before main.js, which means we can access it when we come to main.js. So we'll just paste it right there. And we want to change the version number, so I'm going to highlight it, Control D to select the next instance of it, and then just Control V this. So I'm going to copy this and just Control V to replace it just like this. And you'll also notice here that they recommend using node.js to serve your HTML file. We might have to do this later. I'm not exactly sure. I haven't worked with live server in a really long time, but I think we should be fine just with open with live server. All right, so let's go here and go to creating a scene. Now, I recommend you read through this before I go through it, but I'll just kind of explain it at a really high level because it kind of looks extremely scary, but it's not too bad. So the first thing we're doing here is just some JavaScript syntax, import everything as 3 from 3. So basically, if I go back to what we're importing from the content delivery network and search for export and go to the bottom, you can see it's exporting all these things, right, as an object. So you can see the brackets there. So all this stuff like to buffer geometry, for example, you can see that it's being exported. So what we're doing here is importing everything as 3 as an object from 3. So that means when we do 3.scene, for example, there's likely a scene in here, right? And you can see indeed there is a scene. And since it's a JavaScript object, we're using dot notation to access it, right? In this next thing, we're creating a new camera. Again, if you want to look it up, you can do perspective camera, and you can see indeed it's part of that exported object. And then we're just setting some parameters for the camera. Again, here it's no different than just in Blender. So if I go into Blender, Shift A, add a camera, right? And we come over to camera, we have the perspective camera, we have focal length and things like that, right? So you can see they describe it. The first attribute is field of view. The second one is aspect ratio. And the next two attributes are near and far. So while they're not exactly one-to-one to Blender, when you play around with them, you kind of have the same exact effect. So I'm sure you're familiar with aspect ratios, like when you post on Instagram or when you post on YouTube, 1920 by 1080 and images and things like that. So you're kind of familiar with this. And if you played games before, you've probably heard of field of view and things like that. So I don't want to go into the technical explanations of what these are, but you've seen these when you played video games or worked with things in the past. And again, we have the near and far values, which is something that I showed earlier and also exists in Blender themselves. So it looks scary. It looks like it's code, but it's actually very, very simple here. And then here, this looks scary again, but we kind of need what we call a renderer. I mean, that's exactly what we have in Blender, right? We're kind of rendering a scene or a visual viewport, right? So that's kind of all we're doing. And it renders all our 3D stuff into a Canvas HTML element. So if you're not familiar with the Canvas API or the Canvas HTML element, you can take a look at the docs. But you can read here, the WebGL API also uses the Canvas element here. So we're going to be using the Canvas element. And it's really cool because you can imagine it like a painter's canvas, for example. And all our 3D scene lives inside this canvas. It's just like any other HTML element that we can style. So that's all we're doing here. So because we want our renderer or our experience to take up the full screen, we're going to be setting it, well, they set it to window.innerWidth and window.innerHeight, which means our experience will just take up the entire screen. Sometimes you might want your canvas to only take half the screen, for example. So kind of really depends, but for us, we're going to take up the entire screen. Okay, so now that you understand this, we should just be able to go and copy and paste this. So let's just copy and let's go into main.js and just paste this like here. And then let's come into here to make sure that everything's working, but it's not working because it says cannot use import outside a module at main.js. So what we have to do is go back into our index, and then we have to set a type here, and we'll just set it to module, just like this. And now when I come back here, that error is gone, but we have another. The reason we're getting this error is probably because the path is not correct. So let's just go back to installation, make sure we got a correct path. So I accidentally replaced the @ because I don't see an @ here. So what we can do is come back here, and right before the V, we can hold Alt for 2 cursors to place a second cursor and just hit add an @ just like that. And now you can see our error goes away, so everything should be working. So I made a little small split screen here. I might go back into full screen a little bit later, but just to make it a little bit easier. So what I want to do now is kind of just look at what this did inside our DOM elements. So if I do Ctrl+Shift+I to open developer tools, or right click and just hit inspect, it'll bring up this developer tool panel here. So if you're not familiar with developer tools, well, it's just a handy set of tools that a lot of developers use in your browser. There's a lot you can do with browser developer tools that will speed up your workflow, but for us, I just want to inspect all our HTML elements. So here you can see we have our, our classic stuff that we see here. We have our import map, we have our module things, we have our head, right? We have our link, everything that we see here, we're seeing in the DOM here. Now, one thing interesting here, though, is we see this canvas with the Three.js engine. But we never created a canvas, so how is there a canvas on our page? Well, if we go to main.js, we're actually using document.body.appendChild. So if you look up appendChild into the MDN docs, it basically adds a HTML element to the DOM. So you can see that here, renderer.DOM element, we're appending this DOM element to the document.body, which is why this canvas exists here, even though we never typed it up in here. We're just adding it through JavaScript instead. Okay, so that means renderer has to be an object, right? So what we do is just console.log renderer, like so. And if I go to the console here, you can see indeed WebGL renderer is indeed a JavaScript object. And we're targeting with the dot notation the DOM element. So if I go to the DOM element, you can see indeed it is a canvas HTML element, right? Super, super cool. So we're just accessing this and we're appending it to the DOM. So that's kind of all we're doing. And then we can also look for this thing here called set size. So if you come down here and you can see that it's a function with 3 parameters. Okay, so that means we're getting a renderer object from this code using dot notation, which means we can check this by looking at the CDN. So if I go back into the CDN and search for WebGL renderer, which you can see right here, we are creating a canvas, and if it doesn't exist, And if it's undefined, see if it already exists, or we're going to create a canvas element. And you can see create canvas element uses create element ns, which of a canvas. So if I do create an element ns, you can see that it'll create a DOM element based on the string that you pass in. So it's basically creating a canvas and then setting it to the WebGL render and setting the WebGL renderer's canvas to there. And then of course it has to be exported. So if we go all the way back to probably the 39th one, you can see indeed it's right here. Yeah, so that kind of hopefully clears up some of where all this stuff is coming from. You know, at the end of the day, it's just code that someone else wrote. So knowing where that code is and how to access it really helps. If you want to go deeper, you can hold Control or Command and click on this, and sometimes it will work to bring you to the code. In this case, it's just taking us to the type definitions. It does seem like there is a link here to the open source code, which is cool. You could totally check that out as well. And if you're doing the other approach without a CDN or node modules, it'll likely just take you to the code that you downloaded right in your node modules folder. If you have no idea what I'm talking about there, that's totally okay. But yeah, so a lot of ways to look at the code that you're actually using rather than just using it without knowing what's available. And additionally, you know, if you check the docs, it might be there. So if I look up WebGL 3.js docs, you can see indeed it is in the documentation. And so you can see it has the same parameters that we were looking at when we were looking at it in the code itself. Now it's just more explained in the documentation and the things that we can access. You can see all using dot notation. And if I do DOM element, if I search for DOM element, which is the thing that we're working with, you can see that to access it, yep, DOM element, and then it's a type DOM element. And it specifically tells you that indeed it is a canvas. So we did all that discovery and digging deep into the code to see where it came from and how it worked. And sometimes you will have to do that, but for the most part, if you're a beginner, if you are confused about what you're working with, I highly recommend taking a look at the documentation first and kind of just see what you have available to work with. It'll be a really long discovery phase, and you'll use methods that probably aren't optimized because you are not aware of capabilities within the Three.js, but that's totally okay because over time you'll just build that memory and things like that. Okay, so let's just go back to creating a scene and scroll down because we already talked about this stuff. So next we can take a look at this right here. So let's just copy and paste this and just place it somewhere like over here. So here we're creating a geometry or the shape of an object, aka vertices and points in a 3D simulated environment, right? So here it's like, okay, we're creating the structure and shape of our object, and it's going to be a box geometry. And then we're creating a material, you know, how it looks like. So this is like the structure, and then this is like how it looks like. And then we're combining both of those into what we call a mesh. And then we're just adding it to the Three.js scene. So if you can see here, we have a Three.js scene, which again, if you have a Blender scene, you can just like imagine that the Blender interface itself is just, you can just imagine like if you're using Blender with the interface, it's like blender.scene. So we're just adding it to, you know, our scene pretty much. Here we're creating a cube, right? So if I look up box geometry and click here, you can see this is what a box geometry looks like. And you can see here, it has a width and height and depth of 15. So it's going to look the same if I set this all at 1. You can see when I make the width a little bit smaller, now it looks like not a cube. But if I leave everything 1 and 1, it's just going to be a scaled down cube there. And then here we're creating a color material. So we just call it mesh basic material. Again, if you want to look at it, you can just paste it in the documentation and see what's available with a mesh basic material. So you can see here that we can adjust the color and things like that. So here what they're using is the common hexadecimal string. So if I go back into Blender, Shift A and add a cube. That's pretty much all I'm doing. So this is my Blender scene, and I just added a mesh. You can see mesh, cube. And that's all we're doing in Blender, and that's all we're doing right here in Three.js. Blender already has a basic material for us, even though if we go into the material preview, you can see there's no material here, but the fact that we're even looking at it means it pretty much has material, honestly. Right, so there is some material there, it just doesn't tell you that. So in Three.js, we're just like explicitly stating it. Otherwise, you can't see it if there's no material attached to it. I hope that makes sense. And then here it says camera.position.z. So all that's doing is say our camera. We add a camera here. Sorry, let me delete these. So we have a camera. So by default in Three.js, the camera will just start at 0, 0, 0. So all it's doing is it's going along the z-axis, which is going to be toward your screen and outward your screen. So if you can imagine that, right now in Blender it's the y-axis, but this would be like the z-axis. So we're setting it equal to 5. So I should technically be this way. All we're doing is doing gy like this, and about like 5 units this way. Sorry, GZ in Three.js, but GY in Blender. And the camera's not going to start like this. It's going to start something like this. Whoops, minus, just like this. So we created camera up here with those parameters, which by default starts at the origin, and now we're just setting its position Z 5 units towards our screen or towards us. That way, when we add anything over here, right, if I go into camera view and like add a cube, we can see that cube, right? So that's kind of what we're doing right now in Three.js. All right, so let's come back and move on. You can also, again, read this documentation, and you can see that it will be added to 0, 0, 0, same with the camera as well. And that's why it says this would cause both the camera and the cube to be inside each other. To avoid this, we simply move the camera out a little bit, which is exactly what we're doing right here. Super, super cool. So docs are really good. Definitely check those out. Now, the next thing we need to do, because we still don't see anything, is we actually need to render out our scene. So I'm actually going to get rid of this and go back here. And again, you can read this here. So let's come here and copy and paste this and take a look at what we're actually doing here. So you can see that, why don't we just use like a set interval, to render a scene? Well, it says here that they're actually using request animation frame internally, which means in the code itself. So now, what is request animation frame? Well, if you look it up, it's actually a very, very common way to animate things. And it's used internally by a lot of animation libraries and things like that. So the way I like to see request animation frame is kind of like movie strips, right? You play them over and over again, like every single frame, right? And this is the same with movies. You have frames per second, things like that, right? So this is kind of how I see request animation frame. This is one frame, it calls itself again, so on and so forth. And, things between these frames are going to be changing. So that's kind of all this kind of says. There's some more technical issues that you have to stay consistent with sometimes, but not really a big deal for us. So don't worry about it at the moment. So now if I go back here, you can see, oh my gosh, we actually see a cube. That is so absolutely incredible. And now you can see the canvas is not responsive, which we'll fix a little bit later, but that's totally okay. And you can see Ctrl+I, go to elements. Indeed, the canvas is still there. Everything is okay. And we see a cube because we're finally rendering our scene. So indeed, what we're doing right now is playing a frame, every single frame, but every single frame looks exactly the same. So what Three.js is telling us to do is add some animation to it. So all we have to do is add cube.rotation.x, cube.rotation.y, and add some sort of value to it, like so. And now if I go back here, you can see, oh my gosh, we have a spinning cube. That's so, so cool. Again, if you don't know where this stuff is, you're like, how do you know about that? Where do they just come up with this stuff? You can take a look at the documentation. So we did call it cube, but we could have equally called it something else. We just called it a cube because it looks like a cube, right? Because we set the width, length, and height all to 1, 1, 1. If we change this, it's no longer a cube, so we could change the name, right? But what we're actually using is a 3.mesh, again, which is code someone else wrote. So let's take a look at the documentation here. So let's come over to the docs. Let's look up for mesh. And you can see that indeed is an object right here, and we can click on that. And then we can search for rotation, right? But we don't see anything. And you can see why, because it's actually a child of a parent class. So you can see that indeed it says here, see the base object 3D class for common properties. So if I come here and click the object 3D, and then I search for rotation, whoops, it seems like there's a lot. You can see here that indeed we have a dot rotation property, which is what we're accessing right here. And you can see that it's the object's local rotation in radians. So if you click on Euler angles, you'll kind of see that oh, it kind of seems similar to Blender. It's a very, very common way of orienting things. So again, if I go into Blender and come over here, you can see by default it's on XYZ Euler. You have other methods of determining how you want to rotate your objects. These are more advanced concepts, but you can see by default it's on XYZ Euler. So just like in Blender, we have RX, we have RY, we have RZ, so on and so forth. So that's what we're doing here, which is targeting the X, the Y, and we're adding 0.01 value to it on every single frame. So if I do that in Blender, you can just watch. You don't have to really do anything here. Let me just add a timeline. I'll insert a keyframe. So you can just watch. If you don't understand what I'm doing, that's totally okay. I'll just do RY, I don't know, somewhere over here, odd channels. Let me go back here and let's do, and then let me do RX and something like over here. And I'm just going to re-insert. And I'm just going to play here. And you can see that it's kind of doing the same exact thing that this is doing right here. So here you can imagine this is like a request animation frame timeline in Blender. And if you want, again, you can just actually print out the cube itself because it's an object. So console.log, right? And we just want the cube. Come back to here, go into your console. Here we can see it's a mesh. Here you can see we have a rotation, and you can see it has an X and a Y and a Z. Now at the time that we're logging it, it already has some really, really large values. So if you want to see the rotation on every frame, then you can also just print that out. So if I get rid of this with Control X and then paste it over here and then do dot rotation, right? You're going to see the rotation go up by 0.01 on every frame that it's called, right? And that's exactly what you're seeing right here. And then, of course, if you want to get rid of one, you can see, okay, now it's just rotating along its local x-axis. Super, super cool. So let's just get rid of all that stuff. All right, so before we complete this scene, how about we take some time to do a small exercise? How would you make your camera get further away from the cube in the Z direction? So it's still looking at the cube, but it is getting slowly further away. If I go in Blender, for example, that would be like this, right? How would we do that in Three.js? In Blender, it's just G and Y, right? How would we do that in Three.js? Well, again, we can look up camera. So we have a perspective camera that we created up here, and it's a child of the camera. It says see the base camera for common properties. So let's take a look at camera. And now it says see the base object 3D for common properties. So now let's go back to object 3D and we can take a look at position. And we can see dot position is a vector 3 representing the object's local position. Default is 0, 0, 0. So that means we can use this property, which we are already using, but now we just confirmed it. And we can just put it in here. So camera.position dot z, whoops, plus equals, and then we can do something small like 0.01. And this way we can actually start from inside the cube and then go outwards. So now we'll go back. You can see we're slowly coming out from the cube. And just like that. Super, super cool. So if you want to make it faster, of course, you can increase this like so. And you can see it's really, really fast. Like so. Super, super cool. So let's just undo that. And yeah, so let's just get rid of all that stuff. Yeah, so that's the result. Congratulations. You've completed your first Three.js application. You know, it's a very dense thing. So, you know, you should be proud of yourself if you got this far. There's a lot to take in. There's a lot to, you know, find and know about and things like that. So take a break, get some water or something like that. But hopefully you realize that, you know, Three.js, it's very difficult, yes. But, you know, this is something you can do, and it's something that you can learn with time. So you should be really, really proud of yourself. Celebrate these wins. And yeah, come back to the video when you're done celebrating. Alright, so let's make a few quality of life adjustments and fix our responsive issue thing here. So the first thing I want to do is kind of just put the canvas HTML element directly in my index.html. Not because that this is wrong, I just kind of prefer it because it's more clear that way to me. So what I'm going to do is come over here and do .experience, which will automatically create a div in Emmet with a class name of experience. And inside here, I'm going to do a canvas HTML element and give it an ID of experience-canvas. So we have our wrapper with a class of experience and an ID. You can also make this an ID as well, because we'll only have one of these. So now you can see we have a canvas. We have two canvases, one that we injected with JavaScript and one that we just created ourselves. Now let's go into main.js. And here, since we're setting everything up here, we can just set our canvas here as well. So const canvas equals document.getElement by ID, a very common selector, and we want to target our experience-canvas. And we can just directly add the canvas here. So canvas and canvas, just like this. And now you can see our injected Three.js canvas is gone, and our Three.js canvas is now the canvas that we passed in ourselves. Super, super cool. The next thing we need to do is keep track of the sizes. So when we resize, our canvas and renderer is going to have a different window inner width and inner height, right? So we have our camera listening to window.innerWidth, our renderer as well. So since we're using this in two different places, we might as well just use an object and refer to that object in the event that, later down the road, we don't want to use window.innerWidth or window.innerHeight and rather want to use the canvas itself. However, for now, we will be fine just using window.innerWidth and window.innerHeight. So again, we can just come up here, and I'm just going to come over here and create a JavaScript object called const sizes equals, and then we're going to have a width that we're going to refer to, which is just going to be the window.innerWidth by default. Whoops, sorry, inner width. And then we're going to have a height, and that's just going to be the window.innerHeight. You can see right there, and make sure you spell that correctly. Now for renderer.size, instead of here, we can do width. We can do sizes.width, sizes.width. We're just accessing the width of the object, the object property with dot notation, and then this one is just going to be height, just like here. Similarly, for the camera, what we can just do here is do sizes width, and then come over here and sizes.height, just like this. So now we need to listen to the resize function and update these accordingly, because when the screen size changes, the aspect ratio of the camera also needs to change, as well as the size of the renderer. So we need to listen to the resize event on a browser. So you look at it, there's actually a window resize event listener, just like on click, mouse wheel, and all those other ones. So let's come down here and let's create a function. So let's create a function, handle resize, like so, on resize. So this is the function we're going to call every time we resize. Sizes.width equals window.innerHeight, which we're going to get every time that we resize. Sorry, I might have said height there. And then we go down, and then we can just do height, and then we can, get rid of the second cursor and just do height. And then we can update the camera aspect ratio, which is the second parameter here, but again, we can also just target it. So camera.aspect equals sizes.width divided by sizes.height. Again, if you don't know where aspect is, it's from the camera object, which you can print out to see that. Then we need to call this thing here called camera.update projection matrix. And matrix projection, these are mathematical concepts that people are using to create the simulated camera. So that's kind of all they're doing. You don't have to go into detail here other than just once you change it, you kind of have to update the math behind it. And it's just telling Three.js to do that here. And then, of course, we need renderer.setSize. So right here. And then we can add the event listener. So let's just copy and paste this. Window.add event listener resize, and then we can just pass in our function here called handle resize. So if you want to see it, you can just do console.log resizing, and let's go into the console. And now you can see when I resize, it's resizing, but we have these bars over here because at the end of the day, it's still an HTML element. So we want to style our canvas to also match what our renderer is doing. So let's come to style.css, and here we have experience. So let's do experience, like so. Let's just do position fixed. Let's do height 100%, width 100%. We can do top 0, left 0, and then we can do our experience.canvas, experience-canvas. I'm going to do width 100%, height 100%, and then we can just do overflow hidden over here. This will get rid of our bars there. So now you can see that when I resize, actually let me get out there so it's not doing that. You can see that everything looks all great. Just to go back, if I go back in here and go into main.js and not call this, take a look at what happens, right? So we have a little bit of an issue there. Now there is one property of the renderer that we also want to change when we're handling the resize and the renderer, and that's called device pixel ratio. So it's basically the ratio you can see here of the actual physical pixels on your computer screen to the resolution in CSS pixels. That means if your computer has a lot of pixels on its screen, then to represent a certain 1 pixel in CSS, it's going to use 3 physical pixels on your screen to represent that 1 pixel in CSS. So this will be good when you have like jaggedy edges and things like that, because you have more pixels to display that sort of thing, right? I mean, imagine you only had like 5 pixels. Imagine your computer screen was like this, and you had to make a curve. Well, you'd like light up this pixel, light up this pixel, light up this pixel. Your screen would only have 9 pixels to show this, right? Whereas, you know, if your screen had a billion, a million, a jillion, a zillion pixels, you could easily make a curve and it would actually look like a curve. Whereas if you only had 9 pixels, it would kind of look like an arrow rather than a smooth curve. So what we do is come up here, renderer.set pixel ratio, like so, and then we use a math.min function. So it's going to take a bunch of values in here and choose the lower of the two. So we're going to get the device pixel ratio, and then we're going to put 2 here. The reason we're choosing 2 is because that's kind of widely accepted as, you know, you don't need anything above 2. Otherwise, it'll make your GPU extremely intensive. The higher your pixel ratio, the more difficult your GPU has to work. And it's kind of just been standardized that anything above 2 is kind of overkill. So unless you're doing experimental work or something highly realistic with only specialized devices, you know, generally 2 is kind of the standard here. And then obviously if your computer does not handle 2, like, you know, if its ratio is like 1 or something, then you're just going to use your Windows device pixel ratio rather than 2. But if you have anything above 2, it's just going to cap it at 2. So it takes the lower amounts of those values. And then we typically also put this in the resize function, because if you're dragging your browser window to, let's say, another monitor, and that monitor has a different pixel ratio and things like that. Okay, so the next thing I want to do is add some controls, just like in Blender, right? It's kind of lame that we can't actually move or do anything, right? So Three.js, if you look up and look for some controls, you can see they have a bunch of controls that, you know, they coded up and let us use. And one of the most common ones that you'll see a lot is orbit controls. And this acts very, very similar to Blender's controls that you have. And Blender also has other different kinds of controls, right? They also have this fly mode. And if you come here, you can see that, okay, Three.js also has fly controls. And if you want to look it up, you can do like fly controls, and then you can click on example, and you can see, okay, this is kind of like the Blender fly controls. And then if you type in orbit controls, you can give out orbit controls a try. And you can see, oh, this is kind of like Blender's, right? And it's also kind of like their Three.js editor, and so on and so forth. So let's add some orbit controls. So if we go back to the docs and go to orbit controls, you can see we can just import orbit controls from here. So let's go back to VS Code and let's just import our orbit controls. So just like this, we need to create a new controls, and we need to set its camera and the renderer DOM element. So let's make this a little bit more organized. Let's put our renderer up here, and then our camera comes after. And then we can put our controls after, just like this. And then instead of here, we can just put our canvas element that we're targeting up here. Then we need to tell it to update, so controls.update. And now you can see we can right click to pan, we can left click to rotate, and we can use our middle mouse button to zoom. Super cool. There's a lot of other things that orbit controls can do, but we're not going to be using them, but you know, definitely explore that if you want to. Alright, so now we're kind of ready to start loading our model in Three.js. Now if you're a complete beginner, you probably don't know how to do this out of the box. So I'm going to assume you're either going to go into the Three.js docs and look at load. And luckily there is indeed a load 3D models here. And it kind of explains that. I'm going to assume alternatively you go into Google and then you type it in there. And then you can see, well, Google's Gemini AI is kind of giving a suggestion here already. Of course you could use other AI stuff like ChatGPT or Claude, sorry. And then you can also explore like Three.js videos on loading models, or maybe another text resource here, and just read through that. So when you're learning, this is kind of expected, and I actually encourage you to seek out multiple resources, primarily because one resource might go down another different route of explanation that is more in depth and might make you more interested or intrigued. You can see here in this resource, it kind of even talks about the version differences and why we use GLTF. Here it also says we use GLTF, but it's kind of more brief compared to this Three.js resource here. When you're learning, definitely explore your resources out there and cross-reference them, make connections. One explanation might click better with you than another one. Okay, so let's just scroll down here and import our GLTF loader. Same way we did our orbit controls, we're just importing it from code that someone else wrote. Now let's grab our portfolio GOB that we exported. Let's just do Control B to open this bar real quick, and then just drag our GLB file in there. Then we can close this out, and let's just copy this loader, and let's hit Control B to close that. So let's just copy and paste this. I'm going to put it maybe before the camera, so something like right here, like so, and then we can update our path. We're in the root directory and the same directory, so we can just do // and then of course change it to the name. So mine is portfolio.glb, so we're going to be doing portfolio.glb. Okay, so let's take a look at what this actually does. Unfortunately, it doesn't show in here, but it says see GLTF loader documentation for further details. So we can take a look at there, and I don't know, just scroll down until we find what we're looking for. So here we have properties, and you can see we're doing loader.load. So .load is what we're looking for, and here we can see the parameters. So the first thing is a URL, a string containing the path to that GLB file. So this is the path that we created in the first parameter. Super, super cool. And then we have this second thing here, which is an onload function. So when the GLB file is done loading, what are we going to do? So since we have a GLB file, I'm just going to rename this, Control D to select next instance and just name it GLB. But on load, what we're doing is adding the GLB scene to our scene. So when we exported our scene, our level and all that kind of stuff, it also has its own scene, and we're just adding that to our own. So if I do console.glb, like so, and now if I go back here, you can see in the console, we indeed do have an object, and it has a scene, super, super cool. And if we open that scene, there's 8 children in there. If you look at the 8 children's name, you can see that their level, project_1, project_2, project_3, these are the exact names that we gave them in Blender, all into this GLB file. So here, our GLB file is just a JavaScript object. And since it's a JavaScript object and its children is an array, and the array is an array of objects, then we should be able to just target something, for example. So if I do console.glb.scene.children, and it's array, so I'm just going to pick the first one, and we see the name is level. So we can just do .name to access the name of that object at the children array of 0, which is in the GLB scene. So now when I print, you can see, okay, we get the name here, which is level. Super, super cool. Now, even though our model has loaded successfully, we can't see it because what it's doing is using a mesh standard material, and that needs a lighting source. The reason we can see this box without any light is because it's using a mesh basic material, which doesn't react to light at all. It just colors it pretty much. So what we can do is go back to the docs, and just look up a light. So here I'm at lights. We can go for like an ambient light, for example. So I can just copy and paste this here, and we can just put it, right after the model itself, just like this. Just like this. And you can see that, okay, we pick a color and then we have an optional intensity. Default is 1. By default, the intensity is 1. And if I go back, now you can see, oh, wow, we see our model. So I'm going to right click and just come up here. Sorry, let me close this. And you can see, wow, we indeed do start seeing our model. And if you want to update the intensity, that is the second parameter of an ambient light, we can just update that. So here, let's put this to like 3 so we can see it a little bit better. And you can see, wow, now we have our scene. Okay, so let's add a default camera position so we don't start from the bottom every single time. So what we can do is go into our animate function, and on each frame, what we can do is console.log our camera and dot position, just like this, right? And then we can get rid of console.log resizing because we no longer need that. And additionally, we don't need our cube either, so we can just get rid of all this stuff right here. And then we also have to make sure to get rid of the cube here as well because we're no longer targeting. All right, let's go find a good camera position. Something like, I don't know, really up to you. I'm just going to start here because that's how I'm planning to look in a little bit in the future. Then I'll just do Control-Shift-I, take a look at what it is. Hold Shift-Alt-Down arrow just to copy this. I'll make this one X and I'll make this one Y. And then here we have about -13. Here we have 39. And then we about -67, which we're going to be changing later. So, yeah, so for some reason, it doesn't seem to be working. And it's probably because we're setting the camera position after we're creating controls, and the order of operations here might mess up a little bit. So if we just move this up here, for example, and now we fixed the problem here, so you can see every time I refresh the page, we are now at this vector. So yeah, we can comment this out for now and close this out. All right, so there's a few issues that we want to fix, and if you look at the edges of these things, you can see they're kind of jaggedy. So what we can do is turn on anti-aliasing. So if you come into the WebGL renderer, we can just search for it, WebGL renderer. You can actually come in here, and there's another property here that is called anti-alias, and you can just set that equal to true. Now, sometimes you might want to keep it off for better performance, or if a stylistic choice, but for us, we definitely don't want those jaggedy edges, so we're going to leave it on for true. And now you can see when I go in here, our jaggedy edges are no longer being shown. All right, now we kind of have a lot of options that we can do. We could do controls first, we could fix up the lighting first, fix our camera first. You know, there's a lot of avenues we can take, and there's really no right or wrong answer for this project, primarily because all of these are kind of independent of each other. However, the first thing that I will be doing is determining if I want an orthographic or perspective camera. I kind of already determined this in Blender. I want to go for an orthographic camera, but if you want to go for like a perspective camera and kind of have it like something like this, you know, you could totally do that as well and follow along with the tutorial if you kind of like this sort of view rather than an orthographic view. So since I want an orthographic camera, I'm going to search up for an orthographic camera and kind of just take a look at what we need. So unlike a perspective camera, orthographic camera needs left, right, top, bottom, near, and far values. Whereas a perspective camera needs a field of view, which, by the way, you can adjust and have fun with if you want to. Now, why does orthographic need all this stuff? You can totally get into the math of it and how the camera works if you want to, but I won't be doing that. I just want to talk about how you would use it if you wanted to. Okay, so instead of a perspective camera, we can just use the orthographic camera, and we can just copy and paste this right here, like so. Save that. At a very, very high level metaphorical example of the difference between perspective and orthographic, you can, when you have an orthographic camera, you can imagine that it kind of looks like this, right? Like this is your camera, so you have to set a left, a right, a top, and a bottom, and it's kind of just like a layer, like. Imagine that if this was from the side of an orthographic camera, it's just like a layer like this, which is why everything kind of looks like the same distance. So this is the side view, and this would be like the back view of the orthographic camera. And then, yeah, if you wanted a little more side view, you can see that, you know, it kind of look like this. So this is like more of a diagonal view. For now, perspective camera, let's say we're in the side view for a perspective camera, you have something like this. From the back, this will look the same pretty much as this. So I kind of hope that this one and this one kind of shows you the two different parameters what we have. So we have a FOV here, and then here we're setting the top, the left, the right, the bottom, and so on and so forth. So we still need the aspect ratio. So let's do const, and let's just calculate it right here, and we'll do sizes dot width divided by sizes.height, So for the left side, we can take the aspect ratio times 50 and make it minus because we want it to go on the left side. And then for the right side, by the way, you can see the order over here. The right side, we can just take this except make it positive. The top and bottom, we can just set it to 50 and negative 50 respectively. So bottom is going to be the last one. So this one can be negative 50. And then near and far can remain the same. We can adjust those later if necessary. So now if I go back, you can see we have an orthographic camera. Super cool. Of course, now we need to adjust this in our handle resize function. So what we can do is just come over here and do const aspect equals sizes.width divided by sizes.height, and then we can just set the according properties to these values. So what we can do is have 4 cursors here and hit Control C. We don't have to highlight anything. So I'm holding Alt to create more cursors, Control C or Command C if you're in Mac. And then what I'm going to do is hit enter 4 times. And then with holding Alt, I'm going to paste 4 cursors here and do Control V, and it'll paste just like that. Get rid of the comma. Let's put our semicolons right now. And then let's come over here and put our cursors again, holding Alt, and we can do camera.left equals this. And then we can change this to right, and then we can change this one to top, and then we can change this one to bottom, just like so. So now when I resize, you can see everything is still looking all good. Okay, let's fix up our lighting. So right now we just have an ambient light, which is just a flat lighting. You know, it's the same lighting no matter where you are in the scene. So how about we add like a sunlight, right? So in Blender, in Three.js, that's a directional light. In Blender, we call it a sunlight, right? I'm actually going to go to the directional light helper, and this way we can actually see our directional light. So let me just copy and paste this and place it in here. So let's just rename this to sun because we already called the other one light. So I just hold Alt and double clicked on them, and I'm just going to name it sun. So now when I go back, you can see, okay, now we have a sunlight, but we don't see any shadows. In Blender, as soon as you add a sun and you go into rendered view, you already have shadows. Now, Three.js doesn't work like that, because when you're working in the browser, if you just automatically add shadows or automatically add something and something else is messed up, that could like completely crash your application and, you know, just cause nightmares. So it's kind of more of a layered approach. Like you add the light, then you add the shadows, then you might adjust the materials and things like that. Whereas in Blender, it's like you add the sun, you automatically get the shadows, or, you know, and then you just tweak parameters from there. And a lot of things are just taken care of for you. Whereas in Three.js, it's a lot more layered and you're kind of doing it with code. So, okay, so in order to enable some shadows, we have to set that in the renderer. So again, this is all in the docs, and if you want to, you can also just console.log the renderer just to see what is available. But we need to enable shadow mapping, so render.shadowmap.enabled, and we're going to set that to true. Now we still don't see shadows because we also have to tell Three.js that our meshes should cast shadows and receive shadows as well. Again, this is all about, you know, like a layered approach. You know, maybe some things in your scene you don't want to cast shadows or don't want to receive shadows and things like that. So in our GLB here, we can do this thing called glb.scene.traverse, and for each child in the scene, we can do something to it. So if you don't know what traverse is, that will check all the descendants or the children pretty much. So remember when we logged out our GLB file, console.log GLB, like so, you can see we have this scene and then we have all these children. So what this is going to do is for each of those child, it's going to print this out. So if I do console.log child here, you can see indeed we get all the children and all the children of their children, because if I go into scene and go into these groups, you can see some of these have their own children. So that's kind of what we're seeing all here. If you wanted to, you know, you could do something like glb.scene.children and do like .for each, right? And then you'd go through for each of the children and things like that. But Three.js provides us by default as part of Object3D this traverse function, so we can just use that instead. So now for pretty much all the objects that are being printed out, you know, all our meshes that we created in Blender and are now Three.js meshes, we want to tell them to cast shadows as well as receive shadows. So first we want to check if it's a mesh, because some of them are groups and these are not meshes. So let's just check. So if child is mesh, we can just do child.cast shadow equals true. And then we can do also, whoops, we can also do child.receive shadow, receive shadow equals true as well. So if I go into the mesh, you can see we have cast shadow set to true, and now we also have receive shadow set to true, but there's two of them, which means I misspelled it. So let me just copy and paste this and make sure I spelled this right. Cool. Now we still don't see a shadow because if I look at my directional light helper, the sun is actually down here. And what happens is the directional light actually has a separate thing called a shadow camera, and that determines where the shadows are being calculated. So since our directional light is existing down here, that means our shadow camera is also existing down here, and our GLB file is nowhere near inside that directional light. So it's still lighting our scene, but our model is not within that shadow camera. So again, why do we have a shadow camera? Well, again, it's like optimization, right? So let's say if your screen is only here, then maybe you don't want to cast shadows over here until you get there, right? So you'd move your shadow camera along with your character for optimization. If you calculate shadows for everything all at once, every single time, every single frame, you know that you might take a performance hit that way. Whereas if your shadow camera remains small and you only cast shadows and receive shadows within a specific domain area like here, it'll be a lot more performant. And no one would know there's no shadows here until you get there anyway. For us, we're not going to worry about that primarily because it's too much effort for a beginner course, but that's just why we have a shadow camera, if that makes sense. So if I go back here and look up a camera helper, so right here, we can actually add this camera helper to the shadow camera of our directional light just to see our shadow camera. So let's copy and paste this, and I'm just going to put it, I guess with my other helper, but this time I'm going to call it shadow helper, and instead of passing in the camera here, I'm going to put it in our sun.shadow.camera. So here we'll see our shadow camera, and now you can see indeed this is our shadow camera, and it kind of looks like an orthographic camera would. It kind of looks like a box. So since our scene is not within our shadow camera box, there's going to be no shadows casted. So let me get rid of this console.log, and let's actually just console.log our sun.shadow, just like this, just to see what we have in here. And you can see, indeed, the shadow camera is an orthographic camera, and we just learned about that, so we have to set a left, a top, a right, and so on and so forth. Before we adjust our shadow camera frustum, or our left, right, and top values, and bottom values, how about we first actually put our light in a place that looks good? So what we can do is target the sun.position, and we can just set its position. So we can try something like 50, 50, 50, 0. So 50 in the x direction should make it left, which is the positive x-axis. And then 50 in the y direction means it should go up 50 units. And then we're not changing its inward and outward on the z-axis. Everything that's within our shadow camera is now casting a shadow. Super, super cool. So maybe you like this angle, maybe you don't. But what I wanted to do is place my light over here and then just cast some shadows downward so we can have our shadows everywhere. Again, that's not the best performance, but you know, for us, it's going to be the most simple thing to do. So I might bump this up a little bit. Honestly, really just trial and error at this point. I think that looks okay. And now what we can do is target the shadow cameras left and right and make it a lot bigger. So let's take the sunlight here. Let's do sun.shadow.camera.left and bump it up to, like, I don't know, maybe like -200. You can see it's now it looks like a very, very large left rectangle, and we're getting more shadows there. That looks like it's overkill, so maybe we can do 100. And then let's just Shift Alt down arrow to copy that line multiple times. We can do right. Right will be +100. We can do top. Which can be, I don't know, we can just do at 100, and then we can do bottom at -100. Cool. So now if I come back here, let me close this real quick. You can see that almost everything is in our shadow camera. Now, if you want to, you could move this camera over here, and then everything would be in the shadow camera, and that would work perfectly fine. However, the angle of the directional light and where it's looking determines the length of these said shadows, right? So if you wanted longer shadows like what we have now, you can leave it at this steeper angle. Now, if I want everything to be in my shadow camera, there's kind of a few things I can do. So I can change the angle or where this directional light is looking, right? I can make it a little less steep and draw it like here, and then this would be covered. Or I can move this up. So if I do like 80, you can see, okay, our shadows are a little bit shorter now and everything is within our shadow camera. But if you want to adjust where it looks at, I think right now it's looking at 0, 0, 0 by default. You can actually do sun.target, where it's looking at, .position.set. And then since we're only going in the positive x-axis, determine on the rotation because it's directly like that, right? We're not going on the z-axis. That means we can just adjust this. If we want it to not be as steep at 0, 0, we can just increase the x value. So if I do 20, 0, 0, just like this, you can see it's a lot less steep. And then if I crank it up to 75, it should look directly up and down. And you can see indeed it looks directly up and down, and there's very, very few shadows here. Now, there's a lot of issues here. You can see that we're getting like these lines, these jaggedy edges, and all these weird stuff and artifacts. Again, this is a math thing that you don't actually really have to care about, but it's attributed to this right here. And what we're seeing, I call it artifacts. They also call it shadow acne and things like that. So we kind of just have to set this. I'm not going to be explaining this in this video because it's kind of a more advanced concept, but it is something we have to talk about and set, so I just wanted to point that out. So let's go here and let's just set it. So we'll do sun.shadow.normal bias, and we're going to set it to 0.1, something small like that, and you can see that fixed out all our articles. And we don't have those lines and jaggedy things like anymore. So if you like the shadows up and down and not pronounced, you can do that, or you can adjust this accordingly if you want a little more angled. And then of course you can also add, adjust the directional light as well. And now you can see when I adjusted the angle, you might have to adjust your normal bias again. So maybe like 0.2, and you can see, okay, now the shadows are a little bit to the right and our normal bias is 0.2 instead of 0.1. So really up to you. Now, if you still zoom in and you look at the shadows, well, they're not artifacts anymore, but they look very, very pixelated. And the reason for that is because of our renderer. We have to set a property in our renderer to tell, to use better shadows pretty much. So if I come over here, and you can see there's different types of shadow maps. And each of these, they're going to have their drawbacks and whatnot. And these are just things you'll pick up over time. So if you don't know about it, you'll probably find it eventually on like a Three.js Discord forum or something like that. So what we can do is do shadow map.type, and we can do 3. Whoops, we can just copy and paste this right here. Just like this. And now when I go back, you can see that it definitely looks a lot better. It looks a lot smoother and so on and so forth. Again, we see those lines there, but that's okay. We can just adjust our normal bias a little bit later. But now you can see before, and if I get rid of this, after, that was after, and now you can see before, which is a lot more pixelated. So again, it could be a completely stylistic choice if you wanted to as well. Now, additionally, if you want your shadows to be even better, you can increase the map size of your shadow map. So if I go back into the light shadow docs, so all lights that can cast shadows are a base class for all of these shadow classes. You can see right here. You can see that we do indeed have the normal bias here, but we also have this thing called map size that you can also increase. So if I come here and go into my shadow map here and do sun.shadow.mapsize.width, and we can set it to like 496, shift hold down arrow and do height and do 4096.0. You can see that also reduced some of our artifacts, and now we have even higher quality shadows a little bit, very, very higher resolution now. All right. Now, it still kind of looks like the colors are a bit high contrast compared to the vibe that I'm going for. Now, if this is the vibe that you want, then you can totally go for it. It's kind of giving a high contrast retro kind of vibe, which is kind of pretty cool. But this is not the vibe I kind of want to go for. So one way to fix this is by adjusting another renderer property called tone mapping. So if you don't know what tone mapping is, basically what you do is take a high dynamic range of values like brightness values and color values and put it into a more limited dynamic range. So why do we even need tone mapping? Well, again, there's a lot of reasons for that, but part of it is also technical capabilities and limitations. If you're a human, you kind of see a wide range of colors. So we kind of see a vast amount of colors. Now this is not true for computer screens. Computer screens can't display all the colors that humans can see. So what they have are color spaces. So let's say these are all the colors we can see. Computers might be able to display something like this. Let's say we have another computer over here and its color space is something like here instead of this computer screen. So this computer screen is over here, this computer screen is over here. So tone mapping is exactly what it sounds like, just like when we did UV mapping. We're taking tones like brightness values and color values and mapping it within, and we're mapping it to another space that that specific computer or software can handle. So not just between computers, but also between different 3D softwares. You know, different 3D softwares operate in different color spaces. So if I go back into Blender here, you can just watch, and I come all the way down to color management, you can see that we have different color spaces here. So I can change it to standard and it'll change. I can change it to raw and it'll change. And then I can change it to like filmic and so on and so forth. And that's kind of the high level idea of why we have so many different tone mappings here. And if you want, you can go into the Three.js examples, type tone to look for tone mapping example. And here you can see they all have different kinds of types as well. And you can just switch between them to see, you know, the color and the brightness differences and all that kind of stuff. So I can just come here and do like renderer dot tone mapping, and I can set it to like this one, for example. Whoops, let me just copy and paste like this one, for example. And if I go back, okay, so the colors are not as high contrast, and this is kind of going for the vibe that I'm going for. However, it definitely looks a lot more dim. So what I could do is come over to my directional light and increase that, right? But now it looks like the colors are completely washed out. So what we can do instead is adjust another renderer property called the tone mapping exposure. So if I do renderer.tone mapping exposure, we can increase that from 1 by default to 1.75. And now you can see the colors are more pronounced, less dim, but it's not overblown and washed out by increasing the intensity of the light. So another thing you can do to adjust the way that your scene looks is actually adjusting the material properties that we had, right? So I think I said it earlier, but the fact that we used, if I go into Blender here, the fact that we used a principled BSDF, it's going to by default use a Blender mesh standard material. So if I come over here, you can see a lot of properties of the mesh standard material. So we can view all of that just by console.logging our child and .material, like so. And if I go back into the console here, you can see that indeed we can see our material. This one I just happened to see that it's frame, so the material name of frame, which I gave to this back here, you can see it has a roughness of 0.5. And if I go back and select frame in Blender, you can see indeed I also have a roughness of 0.5 here, and then I have a metalness of 0. And if I go back in here, you can indeed see that I had a metalness of 0. So that kind of translated over into Three.js. However, you know, if you want to, you can totally adjust it. So a child.material, like metalness, for example, metalness. Let me just make sure I spell this correct. We're doing all the materials right now, but you can set it to like 0.5 or something. And now you can see the colors kind of changed a lot. Yeah, so really up to you and whatnot. Yeah, so again, just like Blender, you know, in Blender you have this interface, whereas in Three.js you're just targeting that object's property and then setting it equal to something. So one's with an interface, another one you're just typing it out. So a small little optional exercise before we move on is try and find any material and change the color of that material using Three.js. You can always go back into Blender, change the color there, re-export the GLB file and replace it, you know, right here, right? But I want you to use Three.js to change the color of a material instead. So when you do that, you know, come back and I'll show you the solution. So here's the solution. We already know that as we go through our child and materials, we see all the materials that we have here. And the names that we give them in Blender, these material names are also translated into Three.js, as you can see right here, name dress pink. So that means all I can do is just check for that specific material name. So all I can do is just do if.child.material.name, check for equality in a string equals dress pink. Then we want to do child.material, child.material, and you can see that we want to change the color, and indeed there's a color property here, and it's of type color, you can see here, so .color, and I don't know what color is. It looks like an object, and it seems like, I know what RGB is, right? But let's say I don't know what color is. Well, of course, I can always come to the documentation, search up color, and take a look at what color is. And you can see what R stands for, what G stands for, what B stands for, and so on and so forth. And it also talks about the different ways that you can set that color, which is really, really cool. So if you want, you can give that a read. But let's just speed it up and just say, okay, so let's just speed it up and say I'm going to create a new color and set it like this or something like that. So I just do equals like here. And how about we make our dress black? So the way we do that is 0. So no reds, no greens, no blues. And now when I save it, I go back, you can see my dress is no longer pink, it's completely black. Now you don't actually have to create a new one, you can just get rid of this and do set RGB like so, and you can see it'll do the same exact thing. I just copied it because it's from the docs, but it's a method of the color, right? So if I go here and look it up, it is indeed a function of the color class that you can just do directly. So you don't have to set it equal to the new color. All right, so hopefully that makes some sense. And I'm just going to get rid of this. Yeah, so now just take the time to adjust things in Three.js, explore other colors or lights, other tone mappings, and things like that. Maybe you want to use a hemisphere light, take a look at some of these examples. And then you're like, oh, let me get rid of the directional light. Oh, cool. Hemisphere light kind of has something cool. On the bottom half, it kind of has a different color than the top half. That's really cool. And then you can look, oh, directional light kind of looks like what we have. So, yeah, just explore around, change the angle of your lighting, change the angle of your shadows, find something that you really like, change your materials in Three.js if you want, change it in Blender and re-export if you want, it doesn't really matter. I also forgot to mention that, we also have color spaces that you can set if you want to, but by default, it's sRGB, which is good for us, so we don't have to change that. But yeah, just have fun, find out what works for you, and so on and so forth. So now what I want to do is be able to click on one of my objects and pop up, like an information panel or something like that. And the way we're going to do that is by using a Three.js raycaster. So you can see that this class is help to assist with raycasting, which they link if you want to read about what raycasting is. But basically what a raycaster is it creates a ray. So maybe you remember from middle school what a ray is. Basically, it creates a ray from your camera or wherever you choose to start, and then it kind of goes towards a value that you update. So what does that mean? Well, here you can see we create a vector 2, so it means x and y coordinates. And then we're setting the raycaster from the camera, and we're giving it the camera as well as where our mouse is on the 2D screen, translated into a 3 vector 2. So just to help visualize that, let's say we have a camera that's right here, and our cursor is kind of moving around across our 2D screen. And then everything else back here is like our simulated 3D space. Let's say our cursor is directly over there and our camera's just right here, just like this. What happens is we shoot that ray. If the ray shoots through an object, we can actually detect those objects, and it can go through multiple objects just like that. It won't be technically infinite. You can actually set the length of the ray. So if you wanted to, if you limit the array of the length, then it wouldn't go through this second object and wouldn't detect that collision. But for the most part, it usually goes really, really far and intersects multiple objects if the objects are close to each other and in the line of sight. So in order to help the mathematical calculation, what they do is normalize the device coordinates. So you've probably seen it before if you've done some sort of interaction. But basically, in JavaScript, this starts at 0, 0 in the corner, and then this is like, I don't know, whatever. I'll just say it's 100 by 100. So when you move your mouse to the right, your X value is going to 100, and when you move your mouse down, your Y value is going to 100. Now, this is really annoying when it comes to mathematical calculations. So the very common standard thing is to take the center of the page and make that 0, 0, and then when you go up, it goes to a value. So in this case, it'll be 1, and then when you go down, when you move your mouse down, your Y value will go to -1, and then when you move your mouse to the right, your X value will go to 1. Sorry, let me just write this out. And then when you move your mouse to the left, it'll go -1 and 0, and then down here, again, this will be 0 and -1. And then this one would be 0, 1, just like this. And this way it's a lot easier to do calculations. Similar idea with the raycaster as well. So if you look at how this calculation actually works, Well, event client X is going to give us a value between 0 and 100 in this case, assuming our screen is 100 by 100. We're dividing by the window.innerWidth, which is 100, right? So if our mouse is over here, which is 50% of the way, we'll have a value of 50, 0. 50 divided by 100 is 50%. If we have a 20%, we would have 20 divided by 100, which is 20%. This gives us the percentage along of the way that we're on our screen in the X as well as the Y, which is down here, right? So since it's a percentage, that means we get a value between 0 and 1. So we multiply this by 2, and we multiply this by 2, which means our range is now 0 to 2. But we don't want 0 to 2, right? That means if we go over here, our X coordinate will be 0, whereas if we go over here, it'll be 2. So what we do is then we take all of that minus 1. And then 0 minus 1 is going to be negative 1. And 2 minus 1 is going to be 1. So what we get is if your mouse is all the way to the left, it's negative 1. And if your mouse is all the way to the right, it's going to be 1. And then if you want, you can console.log this out, and then console.log this out, and then console.log this out. And it's going to be the same for the Y as well. And it's just inverted everything, because typically when we work with coordinate systems, our Y starts here at 0, but for the browser, the Y starts 0 up here instead. So everything's just inverted. That's why we have a minus here and a plus here instead. So then we're telling the raycaster what objects we actually want to intersect. You know, sometimes you have a bunch of objects, but you don't always want them to be intersecting with the ray. So there's no reason to check for that if you don't. By default, this is just taking the entire scenes and all their children in there and saying, okay, raycaster, you're going to see if you're interacting with any of the scene's children at all. And intersects will return an array of objects that the ray is intersecting with. So what they do is they loop through that array that the ray is intersecting with and setting it to a red color. There's no greens, there's no blues, but there is maximum red, so they're setting it to red. And they're doing this on every frame, so the raycaster updates on every frame. And then here, instead of using the internal one, they actually used the window request animation frame, which is actually really common, which is typically what I do. But for us, I just used the one in the getting started docs just to avoid complexity, but here you can see that this is probably more common to use the request animation frame rather than the inner one. Not because it's more performant, just because it kind of looks a little bit cleaner. Okay, so let's just copy and paste this stuff into our code. So let's do here, let's copy function on pointer move, and let's put it with our other event listeners. So right here we have handle resize. We can put our on pointer move here. Let's get rid of this. We don't need that anymore. Now before I add this, I just want to suggest that generally you kind of have a consistent naming scheme when you name your functions. So if you have something called on pointer move, typically you always use that naming phrase of like on resize or on pointer move or on click and things like that. Whereas if you want to prefer handle, then you'd typically do like handle click, handle pointer move, handle resize, things like that. So I've used both naming conventions. Honestly, it doesn't really matter. I'm just going to use on because Three.js is. So I'm just going to highlight this, Control D to select the next instance and just rename this to on resize. And now we can just copy window.add event listener on pointer move and just place it with our other ads. And then we can just copy and paste this into our animate function right here, like so. We don't need this anymore. We already know what everything does here. And then, of course, we can't forget to instantiate this stuff. So let's copy this, and let's just put it up with our other instantiated stuff. So wherever that makes the most sense to you. Now you can see when I hover over objects, you're going to see they're going to start turning red. Cool, just like that. That's pretty cool. So again, if we reinstantiate this log here, and you can see that the ones we're actually going for are groups. So if I open this group here, you can see that project 2 is a group. So we can come over here, intersect object names. If it includes the group name, so child, we called it child in this case, but if it includes the group name, then we want to add it to our intersect object. So we can simply do that just by pushing to that array, and then we just push that child there. And then of course, now what we want to do, we can get rid of that now, is come out down to our intersect objects. Instead of using all of scene children, right, we can just use our intersect objects array. And here what we can do is console.log our intersects, our returned intersects array. Okay, so now when I hover over a mesh, you can see we're getting some stuff returned, right? And if I open it, you can see that the raycaster is suggesting that indeed it hit an object, and it's part of the group because this is what we named it in Blender. But what we want to look for here is the object parent, which is the group that we had, and the name of that, and you can see it indeed it's called project 2. So what we can do is just select whatever child is in there, so the first thing that it's intersecting, and then we can go for the object, so .object, .parent, and then the name of the parent. So now when I hover over Pikachu, you can see it says Pikachu on each frame. This is project 3, this is project 2, this is project 1, and so on and so forth. So now I kind of want to give some user feedback that when we're hovering, they can click on it. So what I can do is come over here and just check. So when I'm not hovering over anything, there's no intersects, which means this has a length of nothing. So we can just simply check if intersects dot length is greater than 0. That means we're highlighting something or hovering over something. Then we can set the document dot body dot style and the cursor of that equal to the pointer cursor. Otherwise, we can just leave it at the default cursor. So we'll just put it at the default cursor. And now when I can hover over Pikachu, you can see it becomes the pointer mouse. Super, super cool. Okay, now what I want to do is be able to click on this and it trigger an event. So instead of console.logging, what we can do is do like an intersected object, right? And we can just set it equal to the intersects.object.parent.name. So we have like an ID of sorts. And up here, we can just create a variable called let intersect object, and we can just have that equal an empty string. And then let's come back to our event listeners, and then we want a click one. So we can do click, and then we can call it on click. Then we can add a function on click like so. Then when we click, we can just console.log intersect object. So when I'm clicking, it's completely empty. Now I'm clicking, it's Pikachu because I'm hovering over it. Now when I'm clicking off of it, you can see that I'm still it's still printing out Pikachu because we never reset it. So what we can do is just come over here, and if intersects length is 0, we can just reset it. So intersect object equals empty. So now when I click, you can see empty string, click Pikachu, click, it's back to empty string. Here it's project 3, here it's project 2, now it's nothing, now it's project 1, and now it's nothing, and so on and so forth. Yeah, so now we can just go back to index.html and make a sample modal. So honestly, make it however you want. It doesn't really matter. I'll have a modal inner wrapper. And then in here, I probably have a modal title. So I'm just going to call that modal title. Oh, whoops. Actually, let me put that inside. I have a modal heading. So .modal header. Inside will be a modal title. And I'll just multiply by 2. But actually, I want to change this from modal title to modal button. So I'll call this exit for now. And then I probably also want a modal content. And then inside here, I probably wanted a modal content wrapper just in case. So if you look at this HTML structure, what I'm envisioning, I guess I should have done this beforehand, was we have a modal. So let's say we have a modal. So this is our modal class that we have wrapping everything. Then we have a modal wrapper. So it's going to be inside so this is the modal wrapper. And then we have a modal header. So this will be like our modal header, which has a modal title. So our modal title can be over here. And then we have a modal exit button over here inside the modal header. And then we have our modal content like here. And then inside of our modal content, we have a modal content wrapper. So this is kind of what I'm envisioning, and that's kind of the HTML structure that you see right here. Okay, so let's just do some dummy content for now. So I'll just call this project 1. For the modal content wrapper, oh, I guess we also need, I guess a modal visit project button. So I'll call it modal visit button. I don't know. You can probably name it something better. And then I also want the content itself. So modal project description or something. I don't know, whatever. And actually these should be buttons. So I'm just going to change these to button. This one should probably also be a button. Well, actually this one's an external link. So I should change this to an A tag instead. And then I'll call it view project or something. And then for, I guess I could also keep this project as well. And then for this, I'm just going to use lorem ipsum, and I'll do 4 sentences of lorem ipsum and just save that. Actually, did that give me 4 paragraphs instead of 4 sentences? I don't actually remember because it's been a while since I used that. Anyway, doesn't really matter. So now we have a modal. So let's go into our here just to see where it is. So it's over here, but we can't see it because it's behind our canvas. So that's totally fine. We can just come in here and we can just target our modal and set z index to something like 9999. Doesn't really matter. Then we can set its position to absolute to take it out of the flow of the document. And there you can see, indeed, we have our modal now. Okay, now I just want to center the modal, so I'm going to use the typical way of centering it. Really common, 50%, left 50%. And then we want to transform it and do translate, -50% and -50%. Like, whoops, like so. So I'm sure you've seen this before, but it's a really common method to center something. Now I'll set a width for the modal. So I'll set a width of 100%, so it takes up the full screen. But I don't want it to always take up the full screen, so I just want to set a max width of maybe like 700 pixels. So now let me just go into responsive mode and turn on responsive. So when it's bigger than 700 pixels, you can see it's not going any bigger, but when it gets smaller, it kind of becomes a little bit more responsive already. Okay, let's update the font before we start styling so we kind of have a better reference. So remember, we got that from Google Fonts called Pixify Sans. If you want to use a different font, that's totally okay. I'm just going to be using this one. It is kind of hard to read, but you know, you can always change it later. So I'll just do get font, and I'm going to get the embed code. And yeah, so then I'm just going to copy this and go into my index.html. So Control P index.html. Let's close this out. Let's make this a bit bigger, and let's just post it in here, like so. Let's go back to style.css, and yeah, we can just set the default font family in the global selector to Pixify Sans, and if that doesn't have it, we can just set it as a default sans serif. Okay, there we have. Well, honestly, just style your modal however you want. I'm just going to show briefly what I'm doing, but I might change it later, and you can just take a look in the code on the CSS changes I make off camera. But I'll just show like the general things of what I'm doing. So maybe like 12 pixels. And then we can give the modal a background color. So we can give it an arbitrary background color. So I like a pastely color. So what I'm going to do is find something pastely. So maybe something over here. I don't know, something cute. I want to go for like a cute sort of vibe. And it can be like a different color for each project or whatnot. So, you know, nothing is really set in stone. So copy this, hashtag. Cool. And then we can have a border, and we'll just set it like 2 pixels, solid, and we can just make it hashtag white. Super cool, super simple, super cool. And then maybe we can make the color of the font also hashtag white. Yeah, and then semantically, this should not be a div. This should be an h1 or something like that. So that'll automatically format for us. Of course, you can always format that if you want to. And since our modal header is wrapping our exit button and title, let's make it span the whole width. So modal header, let's just set its width to 100% of the modal wrapper with the padding. And then we can do display flex, and then we justify content space between, like so. And then we want to set the flex direction, so flex direction, and we want it to be in a row. And whoops, I also forgot the dot here. Okay, so now we have this spacing here, super cool, so everything is justified content and so on and so forth. Okay, so we'll revisit this CSS later. You know, it's really up to you how you want to style it, but this will be my modal for now. So what I'm going to do is create a hidden class. And so I'll just add a comment here, and I'll call this modal. And then I'll call this one for experience, and then everyone knows what this is for, so I'm not going to leave a comment there. But then we can have like utilities. And then one of them can be hidden. And this will just be display none. And now I can go back into index.html and then just put the class of hidden here. And that modal is going to be hidden now. So it still exists in the DOM, we're just not seeing it now. But we'll fix that a little bit later. Okay, now let's create some content for all our modals. So let's just do it in main.js and we can be organized later. So it doesn't really matter where you want to put it. I'll just put it up here with the intersect stuff, and I'll just call it const modal content equals an object. And we can just have an object of objects, so let's just copy in this right here. And then let's place some cursors here with alt, and let's just create an object here. And then let's add some commas here. And then what we have is we have a description. And then if you want, you can include the button text. Instead of view project, you can like view website, view video, or whatever. If you want to, you can also add like custom classes in here. So like it will determine, which classes are shown on which projects. Like maybe you don't want a visit button on one of your projects because there's no visit button, or it's like a view code button or something like that. So you could totally do that if you want. I'm just going to keep it really, really simple. So I'm just going to have the title change. So I'll just call it title. And I'll just leave it all at project 1 right now. Project 1. And then we can have some content. Whoops, we can have some content. And we'll just say this is project 1, hello world. And actually, when I click on these, I don't want them to pop up a modal, so I'm actually going to get rid of that. It'll just be project 1, project 2, and project 3. So now we need to target the modal title and modal project description. So what we can do is come over here and just do const modal title equals document.query selector. And it'll be modal title, so let's just do .modal title. And then let's just query selector the content. And then let's just query selector the content, so we'll do modal project description. Description equals modal project description. And then we also need to target the modal close button, so let's do const, and I think I called it modal exit button. Yeah, so maybe modal close button would sound better, whatever. Let's just put it in here, and let's do modal exit button. Doesn't really matter. So now we have the 3 HTML elements. We can add some event listeners and also update the text of, the inner text of those HTML elements. So let's create a function here called show modal. And then when we show the modal on click, we need to identify which project it is. So we're going to take an ID or a name in there. So what we're going to do is you can call it ID or call it name. I'm going to call it ID because it's technically an ID. And then we can just grab some content. So content equals modal content, which is this object right here. And then it will be the ID, like so. So I'm going to assume, so we can have a small check here. If content exists, then let's set the modal title, which is this right here. And we want to set its text content equal to the content.title. So again, when we pass in a name here that we click on, like project 1, it's going to check here and grab this one and grab this content. So content will be returned is this one. And then we're just doing content.title. So we're just doing content. We're just doing the content, which is this object here, .title. Super cool. And then we can do modal project description, .text content as well equals content and .content. Just like that. And then we can just toggle the class list, the hidden class, which is right here. So what we can do is just do, so actually we need to grab the modal first. So let's come up here and let's just do modal. And let's make this modal. And then what we can do is just do modal.classlist.toggle, and we want to toggle the hidden class. So because it's on there by default, when we hit toggle and click on it, it'll remove the hidden class and then it'll be visible. And of course we need something to hide it, so we can just do function hide modal, and we don't really need an ID here. We can just set the modal .classlist. Whoops, we can just actually do this just like this. So let's come over to onClick right here. Instead of console.logging, well, we can leave that in if you want for debugging purposes. We can just do show modal, and we can call intersect object, but we don't want to do it on every time we click, just if intersect object, right? And we can just make it explicit, equal, equal, does not equal, equal, an empty string. Then we can click on show modal, like so. So now if I click on one of my projects, you can see it's project one. Oh, well, all of them say project one, so let's actually adjust that right now so we can see the difference. So let's call this project 2, let's control D, and project 3, hello world. And now you can see if I click project 3, project 2, project 1, just like that. Super, super cool. And then the exit button doesn't work yet, so we can add that as well. Whoops, I called this exist button, but let's get rid of that. And then let's just add an event listener to this so we can put it with our other event listeners. And instead of making it a window event listener, all we can do is just do modal.exit button, add event listener, click, and we don't actually have to create another one here. We can just do hide modal, that function right there that we already created. So now when I click here, I can click exit and I'll close the modal just like that. Super, super cool. Super, super cool. All right, one thing I forgot in here is the href tag. So let's come back and just put a hash here to go nowhere currently. And let's go back into main. And I did add another one here called chest. And then for these three, what I'm going to do is add a link here. And I'm just going to use example.com as my URL. So I'm just going to copy that. And then for these here, I'll just paste example.com. And then for the chest, it's just going to be about me modal. It's going to use the same modal, but we're not going to have a link. So what we can do is target the modal project visit button right here. We can just do shift alt down arrow, paste this here, and we can call this modal visit project button. Then we don't want to show the button if there's no link, like when it comes to the chest. So basically, if content.link, if it exists, then we can do the modal project visit project button and target its href and just set it equal to the content.link. And then we can also remove .classlist.remove the hidden class, like so. And then we can add it by default. So we can add the hidden class over here by default. Again, that's display none in our CSS. And then otherwise, we can just add it. So now when I go back, I just added this in Blender. You can see there's no link button here, whereas there's still a view project button here. Super, super cool. Now I don't want it to go and refer out of the experience. So I wanted to open in a new tab. So what we can do is add these two properties. So target underscore blank to open in a new tab. And I think by default now all browsers use no opener. This is just like some security sort of thing. But we might as well just send it. We might as well just put it explicitly anyway. So now when I click on this view project, you can see we have a new link to whatever project that you want. Yeah, so just to show you, I just created a new chest here and put it into my collection. Then I just shift selected everything, file, export. And since we had this, we don't have to change anything. I just renamed it portfolio, exported it, and then just dragged it into my code. And everything worked out straight out of the box. I also changed the images over here. But that is how you would add something if you wanted to. And then in my main.js, I added chest into intersect object names as well as the modal content because I wanted it to pop up a modal. Okay, so now I want our character to kind of move like Crossy Road chicken. Now we're not going to make it exactly the same because there's a lot of nuance here. You can see it's like squashing and stretching, and then there's probably some easing with the rotations and things like that. So it's a little too complex for this tutorial, but we're gonna get the fundamental basis of this movement. So if you have no idea where to start, that's totally okay. But you know, the general advice when you have a problem you can't solve, like character movement in this case, you want to break it down into its smaller steps. So let's say we want to character movement just like Crossy Road. How do we do that? Well, the first thing is we know how to target children meshes, right? And we can see that's in their dot position. So we know that we can adjust a position of like a camera or an object in 3D space simply by setting it to some sort of value, right? Now, how do we get an event every time we click on a button? Well, we know about the key down event listener, right? We also know that we can do dot rotation on an object 3D and set its rotation to something, right? Like math.pi or something like that. So already just by breaking down this complex thing into smaller problems that we know about, we can already have a starting point to. So what we can do is start with a key down and update our character's position and rotation based on that key down value. So let's go to our event listeners. Let's shift alt down arrow here and let's do key down. Let's call this on key down and let's just add it right here. So function on key down. And then if you're not familiar with key down, you can just console.log it or go into the documentations. And now you can see when I do WASD, there's this thing here called key that shows me what key I'm pressing. And then when I use my arrow keys, the key is, arrow left, arrow down, and so on and so forth. So since some of them are uppercase and some of them are lowercase, we don't want to type that out and worry about it. So what we can do is just make it to lowercase and then switch between the keys that we press. We can create a switch statement, switch the event.key value, and then we can just use the .to lowercase built-in JavaScript function. Very, very common. And then we can just do case w, and which is also case arrow up, like so. What we can do temporarily is just set a break statement here, because first we actually need to access our character. Again, let's come back into our loader function. So remember, this is the callback to do things once we're done loading. So if child, so I named it character, so if child dot name equals character, then let's set a variable called character equal to the child. Oops. So let's create that. So let's create all this stuff, kind of wherever you want, but I'm just going to put it. I'm just going to put it here, and I'll just call it let character, and I'll create an object here, and I'll call the instance of the character and just set it default to null. And then we can also set our move distance here. So I'll just, there should be a comma, and then I'll set a move distance here. So how much we travel once we hit the button. And I'll just set it at like 3 or something, which we can always change later. So now when I come back here, instead of character equals child, I'll do character.instance equals set equal to the mesh that we have. So when I have WASD, right, and I'm viewing from this angle, W is going to be going that way, or the up arrow, A is going to be going that way, D is going to be going that way, and S is going to be going that way. Now, if you remember, our camera started here initially, which means we're actually looking at the opposite way. So normally the positive z-axis is coming out the screen, but since originally our z-axis was actually positive here, we're actually looking at the negative z direction. So S is going to be going in the negative z direction instead. We can just do character.instance dot position, and we can just do plus equal character.move distance, just like this. And I want to go back and hit W. It should work. But it doesn't, probably because it's not defined. So either this is misspelled or something else is. And indeed, here it is. So this should be character, like so. Now it still doesn't work because I forgot to add the z here. So this should be .z, like so. And now you can see when I hit W, I'm moving in the z direction, right? So if I do that for all of them, I can come shift alt down arrow, shift alt down arrow, shift alt down arrow. And then I can call this S, arrow down, and then we can minus instead here. Then we can do A, which is arrow left, arrow left. We can go X, and that will be in the positive direction. And then here we can subtract. So this will be D, and this will be arrow right. Now you can see we already have some basic controls, just like that. Pretty cool. And then, just for semantic clarity, we can have a default, which is just, do nothing, return. Okay, so we don't need to log this anymore. Okay, now we clearly have an issue. We don't want it to just like jump to the next position. We want it to smoothly go from one point to the other. So if we go back, we kind of did everything, right? But now we hit another roadblock. Our character's just jumping from one place to another. When you Google it, I'll just speed up the research process for you by telling you, you'll realize that what's happening is that we're just setting it on one frame, right? So we're just adding +2 to the movement, and it's going from here to here. Now, if you remember what I said about request animation frame and how I like to view it as like a movie strip or a film strip like this, what we're doing essentially is just having like, 2 frames, and we're just adding 2, so it becomes instantaneous from one frame to another. But in reality, what we want is to have the starting position and a target or ending position, and then just let the software do it for us in between. So slightly over here, slightly more over to the right, slightly probably in the center here, a little bit to the right, and then a little bit more to the right, and then over here will be the final target position. That way we kind of have a smooth thing. And of course, the more frames you have, the more smooth it's going to look. And that's why in games, people really, really like the frames per second metric. Gamers like high frames per second, right? If you start lowering your frame per second, you're going to start getting a little bit jaggedy, and it kind of looks laggy, and it's a little bit annoying and frustrating to play. Of course, you also have like stop animation motions, which are usually in like 15 frames per second. So you also have like, your stylistic choices there as well. Okay, so ideally what we want is just having a starting and an ending position, and let our 3D software, or in this case 3GS, kind of take care of the rest, and which we call interpolation. So if you look up interpolation, the broad idea of it is just constructing new data points based on a range of known data points. So if we know the ending position and we know the starting position, then we can use some sort of interpolation method. There's very different kinds of interpolation methods to figure out everything in between those frames for us. If I go into Blender, let's say this is my cube starting point, I'll hit insert a keyframe, go to like 20 frames, go GY, and then hit another keyframe, all channels. You can see we only have a starting position and an ending position, but when I hit place, you can see we only have a starting position and an ending position, but when I hit play, the cube is somehow going there, rather like in Three.js where it just teleports there. And that's because of the interpolation mode. And it's because if I right click here, interpolation mode I think by default is Bezier, so you can see there's no change there. However, if I change it to something like constant, now we get what Three.js gets. We just instantly go there. Now here we're delaying it. We're waiting 20 frames before we go there. But in Three.js, it's just like putting it at 2. So if I move this at 2, for example, it'll just jump as soon as I hit my key spacebar, or in Three.js, I hit W, it's just instantaneously going to go to the next frame there. Okay, so then that kind of begs the question, how can we use our animate function or our window.request animation frame, which is what it's using internally, to facilitate a starting and ending position? Well, there would be a lot of stuff we need if we were to do it by ourselves. Now, if we were to do it ourselves, there would be a lot of things that we need. And I was considering doing it for this video, but I felt like it was too intermediate or too difficult for a beginner course. So we're going to take a look at an alternative. So we're going to use an animation library. Again, it's just JavaScript that someone else wrote called GSAP, which is a really popular way to animate things on the web. Basically, it gives us syntax for us to use in JavaScript. Helps us animate things a lot easier than us having to do it ourselves, because it also has a built-in window request animation frame. It also has a bunch of internal properties and internal commands that kind of just figure things out for us. For example, if we set our rotation to math.py, for example, we don't have to use our own math functions. And if we want a jump animation, we don't have to use the math.sign animation. It kind of takes care of that for us by default. And they also do the linear interpolation for all of these behind the scenes. Additionally, GSAP is very, very popular in the creative development space and the design engineering space, so it's kind of good to know GSAP anyway. We'll be doing more complicated custom things in future videos, but for this beginner course, we're just going to be using GSAP. Okay, so let's come to this page in the documentation and grab the GSAP CDN. That way we can use GSAP in our code. Let's come back to index.html and just put it right here, and like so, and now we can just use GSAP. Now we don't have to import them like we did for 3 because we're not using an import map. We're just using the CDN directly. So if you want to, you can update it to an import map and then call it GSAP and then do import GSAP from GSAP just for consistency, but I'm just going to use it straight out of the box because we don't have to do that. Similarly, you don't actually have to do that for Three.js either, but they did that in their docs, so I'm kind of just leaving it that way. Okay, so despite GSAP saving a lot of time and a lot of effort, there's still a few parameters that we kind of need. So one will still be the move distance, and of course the instance as well. We also need like a jump height, so we can like set that as a default of 1. We also still need to determine if it's moving or not. That way we don't keep on replaying the GSAP animation. Set that as false, and whoops, I keep putting semicolons here. And then we can also have a move duration that we can tell GSAP how long we want it to take. So we can just do move duration, and we can set it at like 0.2 seconds or 200 milliseconds. Now again, if we're doing this ourselves, we would need a lot more than what we have here. Okay, so let's go to our key down event, and let's set our target rotations and positions that will update on key down. Then we'll use GSAP to take our current rotation and location and go it to our new location and rotations. So the first thing we want to check is when we press down a key, is it moving? And if it is moving, we don't want to trigger another animate event, right? So we have this guard clause here, and we'll just return immediately. If the thing is moving, just return, don't execute anything below here. Now, the moment we press down our key, we already know the target rotation, right? Because we hit W, and then we're just adding 2 to that target rotation. But our target rotation needs to be relative to our starting rotation. So in order for that, what we do is const target position, like so. And we'll do a new 3.vector3, like here, and then we can just copy the character .instance.position. And if you log out the type of position of any object 3D, it's going to be a type of vector3, which is just an X, a Y, and a Z, just like that. So we're copying the current character instance of the target position, which we're going to update with a key. And then for the rotation, we're not adding to the rotation, we're just rotating to that specific value. So for us, we can just do target rotation and just leave it as a default of 0. So how does that make sense? Well, I don't know the exact directions here, but let's say if I rotate this way, I'm going 90 degrees. And then if I go this way, I'm rotating negative 90 degrees. And then if I'm here, by default, I'm at 0 degrees. And then if I rotate this way, I'm at 180 degrees. Now, let's say I go up, then I'm rotated 90 degrees. When I rotate right, I'm not adding 90 degrees here. Instead, I'm just rotating to 180 degrees. But since I'm already at 90, it's going to act like I just added 90. Now, the reason we're doing it this way is because rotations can start getting confusing if you start adding to them. Like, let's say you want to go from 90 to negative 90. Do you take the short route and go from 90 to 0 to negative 90? Or do you take the other way and make 90 go to 180 and then 180 go to 270, which is going to have the same result as negative 90? So it kind of becomes a mess, which is why we just go to that specific rotation rather than adding or subtracting. So I'll just do Control D to select all those instances and do target position. And then for the target rotation, I'm just going to set it to some value, which I don't actually know if they're right or not, so we can always just change it later. I'm going to assume since our camera was facing this way first, that this rotation will be 0 when we hit W. This rotation will be, this is the Z-axis in the positive direction coming towards us. So I'm going to assume our character is already default rotated. We could confirm that if we wanted to, but I don't, we can, it's just faster if we just type it. So I'm going to set this as 0. This one will be math.py going in the negative Z direction. And then this one, since again, we're viewing it from this way, by default, we're looking at this way, which means X positive direction is going right. So if we hit the left arrow key, that means we want to go in the positive X direction. So we're rotating it 90 degrees. And then here we just want to go into the negative X direction, which is what we have here. And that's also kind of highlighted by our symbols here. They kind of already give us the direction. So I think we intuitively got it correct. Okay, now we can create another function that will just move our character. So let's come over here. And let's just, well, we can put it anywhere. I just do function, and I'll call it move character. And it'll take our target position, right? And our target rotation, like so. And then we can pass that in. So every time we key down, when it's not moving, we want to call the move character function. So we can just do move character, and then we can pass in our target position and our target rotation, just like this, into our move character function. Now we don't want it in the default, we want it out, so just make sure you're not in the switch statement, which I am accidentally in the switch statement, so let me just move that outside of there. Okay, so as soon as this is triggered, that means is moving is true. So we can set is moving equal to true, right? Okay, so the next thing I want to do is create a GSAP timeline. And it kind of sounds scary. If you need a visual representation, you can just go into the Blender timeline and kind of visualize it like this. Or if you use Premiere Pro or some sort of video editing software, you know, you've kind of seen a timeline before. So let's just call it const, and it's pretty standard to call it T1 for timeline 1, and GSAP.timeline. And if we want to add keyframes to this timeline, we can use a lot of different methods, but we're going to be using 2, which means we're taking some initial state and heading to there. So we're going to take our initial character instance dot position. We're going to set its x. So basically what we're doing here, x is basically doing dot x here. And we're going to set that equal to the target position dot x. Again, that's a vector 3 right here, right? We're just targeting the x value of the vector 3. And then here, this x is targeting the value of the character's position. And then, of course, we also want the z direction, and we're going to do target position dot z. Then we can set the duration, right? And we're just going to set that to move duration, which we put at the top, and that will be character dot move duration, like so. And we can do the same thing for the rotation. So let's just copy this, but instead of the position, we'll just grab the rotation. And this time we're only rotating along the y-axis, so we can just do y. And then it's not a vector 3, it's just a value, so we can just instead just do target rotation here. So I also forgot that isMoving is part of our character, so we need to do character.isMoving, character.isMoving here as well. So now if I go back, you can see when I hit my character, it moves and then it rotates. However, I can't actually press any other keys after that. Now the reasons that's happening is because when this triggers, we set it to true, which means every time we press our key again, it'll just keep returning and never execute again. So what we kind of need to do is tell GSAP when it's done playing this to do some sort of action. And luckily for us, if you look at the docs, GSAP has this really awesome cool thing called onComplete. And basically it runs a callback function to do something when your timeline is completed. So all we can do is just character.isMoving, and set that back to false. However, there's still an issue. When we move, it moves and then rotates. That's kind of weird. We want them to play at the same time. So the way to do that is just by putting 0 here in the order value, and it'll just play them at the same time. So now you can do this, and you can see it rotates as we move. Now again, I'm just kind of telling you what features GSAP has, but normally if you had that issue, you'd look it up and then you would eventually figure this out. However, I'm just telling you that, but you know, over time you can develop your own intuition. Now I do see one issue. When I go with my D key, it's going in the right direction, but it's rotating wrongly. So if I go back here, indeed I do mess that up. So it should be divided by 2, not negative math.pi. And now when I go back, you can see that we have everything working. Super, super cool, just like that. All right, so now let's make our character jump. So we can just copy and paste this and move it down here. And of course we want 0, so all 3 of these play at the same time, even though they look like there's an order here, all of them will play at the same time. And again, we have the position, and this time we do want the Y position. And the position that we're going to is the character instance's position of Y plus our character jump height, which we set earlier up above. So now if I go back to the browser, you can see that indeed it's working. However, the issue we see now here is that we always take our initial height, which never resets, and keep adding to it. So now what we have is a flying character. So the way to fix that is actually with yo-yo. So this comes with GSAP, which is really, really nice. And it's called yo-yo. And just like it sounds like, we just set it to true, and then we set repeat equal to 1. Now, if you think that's too slow, you can divide by 2. I think what yo-yo does is it will play the duration to that movement, and then again back when it yo-yos. So what we can just do is just divide by 2. And then now when I go back, you can see that the jump kind of matches when we land and when we start, so on and so forth. It doesn't stay floating in the air. You'll also notice when I hold down a key, it's only going to play the next animation when isMoving is true again. Sorry, when isMoving is false again, then it'll trigger the true. That way we don't have a bunch of spamming, which will mess up the animation. Again, you know, I'm just telling you this stuff, but like, take some time to explore with the GSAP timeline. You can see in the documentation, they kind of have the callbacks that you can put in your GSAP timeline. For example, here we used onComplete, so on and so forth. There's also other stuff here like on start. So when your timeline starts, do you want to trigger something? You could trigger an animation in the scene. So you kind of have a lot of options when it comes to the GSAP timeline. Yeah, so I mean, your portfolio is pretty much done. I mean, if you just want to deploy this, you could totally be happy with that, and not watch the rest of the video. Just make sure people know how to move around with like instructions or like a small HTML pop-up or something like that. However, I will be continuing on with a few extra features that I want to add. They're still going to be somewhat beginner friendly, but maybe a little bit more towards the intermediate side. So I'll explain it a little bit faster and a little more brief now, but hopefully. But if you want to call it a day, if you want to explore things on your own, and yeah, you can totally do that. And for those people, thanks so much for watching, and I hope to see you in my next video. But for the others, I'm going to be continuing on. Yeah, so I just added a small on click to our intersect objects. Originally it was just show modal, but now I'm just checking, okay, if the intersect object we clicked on was Bulbasaur, Chicken, or Pikachu, you could use if statements here and just use if equals Bulbasaur, or I just did this way, no reason in particular. And then I added this function here called jump character, which is just another GSAP timeline that I created. And basically I'm using this Three.js thing here called get object by name. And since we're passing in the string, which is also the name of our mesh, you can just use scene.getObject by name rather than traversing the whole thing to find equals. We used traverse here because we wanted to target all the children and set their cast shadows and receive shadows. And then instead of using find after, since we have a traverse, we might as well just use and check for the name. But if you wanted to, you could totally have done like glb.scene.find and then set the character instance to the find. So if you put in character here, you could set the character instance to that, like if you wanted to. Sorry, I meant get object by name. I think find is also one, but it might work a little bit differently. But yeah, I just made another GSAP timeline to take that scale and do some stuff with it. You can see I have some easing functions here and things like that. Yeah, so if you want, you can just take a look at the code and see what I did there. But yeah, so we kind of have something a little bit cute here. If you need help with that, definitely reach out. I can clarify and explain what I did there. But I encourage you to look through the GSAP documentation and try and understand what I did there initially. I will say I did not introduce a state here, so if you click on it while it's animating, you can see it's going to start glitching out. And honestly, I'm just going to leave that in as an Easter egg because I think it's kind of funny. I also say most people are probably not going to click on it twice in a row because it goes up and then you miss it, so you have to click it when it comes back down. Very few people are going to like click it halfway and kind of do that. Maybe they will, but then it'll just be funny. You'll also notice that when I go to the rotation of 180 and then go to the rotation of negative math pi divided by 2 or negative 90 degrees, it's taking the long way around rather than the short way around. So you can use math to fix that. Yeah, and that's pretty much what I just did here. If you want me to walk you through this, feel free to reach out. But here I just shift the ranges of our rotations to always find the shortest rotation. And instead of using our target rotation as the target rotation, we're using this final rotation here. And now you can see when I go 180 and go into 270 or negative 90 degrees, everything is taking the shortest path and we don't get those crazy rotations like we used to. Okay, the next thing I wanted to talk about is collision detection. Now, I'm just going to be telling you some of the methods, but when you Google these, when you Google like Three.js collision detection online, these are the kinds of things that you'll see. So the first one you'll see is like ABB, collision testing, which is basically checking if bounding boxes of objects overlap and then doing something with that sort of information. So like in video games, if you have a character, like let's imagine you're playing Valorant or CSGO or some first-person shooter like Call of Duty, your hitbox is not the person itself. Your hitbox is actually some other more standardized object, like a rectangle or something. So when someone is shooting at you, it might go between your arm and between your leg visually, but it'll still considered as you getting hit and you would lose some HP points, right? Now, the reason games don't like to use the person themselves as the collision determination is because that would increase so much more mathematical calculations and take a hit on performance. Obviously, for some games, they will use the entire body to detect collisions because they kind of need that mechanic, but a lot of games they don't, and people often refer to this as like hitboxes or things like that. So the idea is, again, since these are, bounding boxes in 3D space that no one can see, Well, that means they're made of a bunch of points, which means if one bounding box, which is made of its bunch of points, if it's overlapping this bounding box, then if a point inside here is overlapping a point inside here, then we just detect, oh, it's a collision, and then we can react to that. So this is kind of like a high-level explanation of this one. Another really popular thing is to use a nav mesh. So basically what a nav mesh is imagine like you create a ground. Like you can have everything, whatever you want, but you create a ground that, again, is invisible, and your character can walk on this nav mesh. Basically, since we are moving, you know that we already know the target position, right? As soon as we hit a key, we already know the target position. So you take that target position, right? Let's say I hit, W, so I want to go this way, and it's not on the nav mesh. So if I raycast directly down from my target position, it'll show that the raycaster is not intersecting with my nav mesh, so we can cancel that movement. Now there's a lot more complexity here, but that's kind of the general idea for a nav mesh. And then another thing is, again, using raycaster, but except, whatever direction the character is moving, for example here, we can have like a wall here or something like this. And basically, the raycaster will determine the length of your intersection from your character to the wall. So let's say right here, it's like distance of 1. And then as your character gets closer, let's say over here, well then the distance between the ray and the wall collision is, I don't know, like 0.1. And then again, if the target position will go below 0.1, it means we'll go inside the wall. So instead of continuing the movement, we just cancel it. So again, this is kind of like a raycaster method, like so. Then you have like physics engines like Canon.js, Amo.js, and things like that. They'll do a lot of the mathematical calculations for you, so not really much to illustrate here, other than if you want to take a look at some of the examples with Canon.js and Amo.js, you totally can. Now, if you wanted to go for like a really, really primitive and basic collision detection system, let's say you have like a box here, you can just check, if player is within this range and this range and this range and this range, allow them to move, otherwise don't. So here you just have a bunch of if statement checks. It's not really detecting collision, just detecting if your character is within a specific range. Now this will get extremely bad when you have complex routes and everything, but if it's like a box, like that would totally work. But, let's say you have like different paths and things like that, you would have to manage like, okay, if they're between this X and Y range, they can only move through this box, or over here they can only move through this box, and so on and so forth. So, and then if you have obstacles, it becomes even more confusing. So there's the method that we're going to be using, called an octree, which is like a data structure. You don't really have to know about that if you don't want to. But basically, imagine you have a scene here and a bunch of objects like here, 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 here. Imagine you have a character like this, and on every frame, you're detecting collisions with all these objects just to make sure there's movement. That would be very performance intensive. So an octree kind of divides up your stuff like so. I'm not doing it to scale or accurate, but basically it divides it. And if your character is within, one of these divisions, then it will only check for collisions inside here. So if there's like an obstacle here, it'll only check for a collision there rather than the entire scene. So it kind of improves performance a little bit there. Okay, so now you might be a little bit confused and a little bit overwhelmed, and you're like, okay, there's so many collision methods. Why are there so many collision methods? How am I going to determine what to choose? What are the pros and cons and things like that? And there's probably more collision methods that I didn't list here and things like that. And in a lot of projects, if you want to, you can sometimes combine different methods, like using a simple one or in some areas and then using this in other areas. And then if your client wants something really quick, even though it's simple, you might use a really bulky physics engine, which will take a hit on performances, but it'll be a lot quicker to implement than some of these other methods. So you have so much complexity, and it's like, which one do I choose? Which one do I work with? How do I know about these? To answer that question, I just want to say, like, don't even worry about it. You're just starting out. Don't even worry about this stuff. Don't worry about optimization. Don't even worry about anything. Just know the method, try and do a little bit of research, and then just try and create something with that method. And then you'll just get better with it over time, and then you'll improve your workflow and kind of just, gain it with experience. What I see a lot of people do is they kind of get overwhelmed and then they kind of just give up rather than doing something. Doing something and failing at it and learning from that is definitely better than just never trying at all. Don't be afraid to fail. You will fail. I've failed 100 times recording videos. 100 times when I create websites. You just kind of see the finished, polished product. But over time, you know, you'll kind of develop it. And when you start working with people, people will like question your design choices and they'll suggest alternative workflows. And then you can take that into consideration and things like that. So yeah, don't worry about it. Just have fun, focus on creating things. And over time, you'll develop your intuition and you'll be all good to go. Okay, so let's go back into Blender and create our collider mesh. Now, if you want to go to the file where before you joined them, you totally could. But what I'm going to do, just because I'm going to mess up everything, is just do file and save incremental right now. And then what I want to do is select Control L to select my entire ground plane and hit P and separate by selection. That way we kind of just have something easier to work with. Then I'm going to go into top view, go into edit mode, go into wireframe, and kind of just box select my level like so. And then I'm going to hold Control and like box select the areas that I know I can never walk on. So you could totally do under the tree as well if you wanted to. So now what we can do is Shift D and then P separate by selection. I right click, cancel the movement. So now what we have is the collider. So we can call this ground collider like so. And then we can just actually just delete all this other stuff because we don't need it. Let's go back to material preview. So this is going to be our collider. So we actually don't need any materials at all. And then for the rest of the scene, we can just use primitive objects. We don't want to use the objects themselves. We just want to use primitive objects because it'll be a lot more performant than using the objects themselves, right? Like instead of having like 6 different objects here and, you know, like one here and one here, we can just use a single box. So what I'm going to do is Shift right click, Shift A, add a plane like here, and just kind of like scale it up arbitrarily like so, SX. And this will kind of be the hitbox area or the collision detection for this. And this will be like that. And then I just want to extrude it upwards a little bit, like here. If you want to change how this looks, you can come into Object and then go into Viewport Display. And instead of textured, set it as bounds. That way you can kind of see it a little bit better. But I don't really mind that much. So I'm just going to change this back to textured. You know, don't forget to delete the bottom face. Not really a big deal, but you know, might as well save as some memory. Again, if you don't like how this box is, you know, consistent with here because this is kind of inside a little bit more and this fence is a little bit out, you can totally adjust the geometry to, you know, put it inwards if you want to. I'm not going to, but you can if you want to. I'm just going to keep everything really, really simple. So I'm just going to do this. I'm going to do the same thing here. And if they're clipping through the sign, that's totally okay. But if you want to, you can totally make a hitbox here as well for the sign. Or adjust this one and like extrude it out. Honestly, I don't really mind that much. Yeah, just kind of be. Yeah, honestly, it doesn't really matter. Just make your bounding boxes how you want to do. How do you want to do them? For example, like for the flowers, for the benches, you might put some. For the rocks, you might put some, or you can just let them clip in between it. You know, it's really up to you. It's really up to you and what you want to do with your scene and what you're okay with them clipping through and whatnot. Alright, so I kind of have all my collision stuff there. Okay, and now we need the walls so we don't, you know, go out of the stuff and things like that. So what we can do, if you want, we do have the topology here to just extrude. So if I go into top view and go into wireframe, and like you can see, like I can like hold control to get the shortest path and just add it with control. The issue with this method here is because I didn't really snap to grid, so you can see there's a misalignment. So for example, if I add over here, you can see that my character would be over here, but then over here it would start clipping inside. So obviously you can adjust that after you extrude upwards, or if you used a grid system, it would be consistent all around and you wouldn't have to deal with that. So instead of just doing that here, I'm just going to create a plane. So I'm just going to Shift right click, add a plane here. I'm going to do RY90. You can start it wherever you want. Then I'm going to go into edit mode, GZ, move it up a little bit, GZ, and then snap it with face snapping onto there. So the origin point is there. It doesn't really matter though. Then I'll just scale it up to get a height that I want. It doesn't have to be the height of the tree. Yeah, and now we can just go into top view, go into wireframe, go into edit mode, and then just extrude this out. So this one actually I'm not extruding, I'm just going to GY. But then here I'll extrude, so E, and then I'll lock it on the x-axis, kind of move it over here. E, and then lock it on the y-axis again, and then I'm going to EX again. Again, my collision is not perfectly symmetrical on all of them, but again, it doesn't really matter. I'll also say, like, depending on the camera angle, you might actually want to increase the collision on one side compared to the other. Because if you put them like the same distance here, and the camera is angled in a way, it kind of completely hides your character. Now there's other ways to get rid of that, like making your mesh see-through and things like that, but that's a complexity for another day. But that's also a design choice you could totally make if you wanted to. So I'm just gonna do EY and whoops, no, it's GY and GY. And then I feel like this original start is a little too close, so I'm just gonna GX move this out a little bit, move this a little bit, and then EY again, like here, and then EX like here. And then for these last ones, I'll just do SX0 just to make them perfectly aligned on the x-axis. You could also turn on vertex snapping and snap them, but now they're perfectly aligned. And then we can merge these vertices. So again, from the side view, we'll do M, and then we'll do at last, which is the last one you selected. So this one first, then this one. This is the last one we selected, and we just do at last. So now if we go into material preview, you can see that, okay, we created some walls here. Super, super cool. Now again, we need to check our face direction, so make sure everything is blue. This is not blue, but all the other ones are. Great. So we go into edit mode, AN, and flip, just like that. So now everything is blue where we want to detect. And then you can see I have some things messed up here, so I can just move that a little bit there. But now we can join all our stuff into a single object. Let's make sure just to move it around to make sure we're not missing anything. We can also turn off face orientation now. Select our ground. And it looks like we got all our collided stuff. And then with the ground as the active object, we can just do Control J and join everything. So we go back into local view. This is our collider object that we're going to be detecting collisions with. And then of course you can always edit it. So if I go out, you can see that this tree level is the same, but this wall is not the same level as this wall. So I can come up here, turn on vertex snapping, and just like GY lock it, and then snap it to this vertex. Whoops, I accidentally went to the ground. GY, yeah, this one right here. And now they're even amount consistency. This might be too close to the trees, so I might do GY and then move it out a little bit. I don't know. Really up to you there. And of course, now that we know that we'll never go outside, you can totally go into wireframe and kind of start deleting some of these extra faces here that are behind the wall because we'll never need them. So we can save some memory. Like so, control, and then maybe over here we can hold control. Here as well. Delete these faces. Okay, sweet. And I accidentally deleted the rest of the level, so I made a mistake there, unfortunately. That's totally fine. We can just move this into a new collection called Collider. And this is why we do save incremental, because when we make mistakes, it's totally okay. We can just go File, Open Recent. I called it before exporting to, so I'll just save this file. And here we have our original thing that I exported. Let's do File, let's do Append. And the incremental one is before exporting 3. So we can double click that, go into Collection, and then look for our Collider. So we called it Collider, so we just add it, and now it's just added to our scene just like this. Now let's take this out and just drag it into its own. Not that that matters, but it's just cleaner that way. Now we can just select everything, do File, Export, GLTF. We can name this portfolio now, and we don't have to touch anything here because we already have this. And then we just hit export. It'll replace over our old portfolio GLB. If you want to version it, you can totally do that, like _v1 or underscore with collider. And I'm just going to drag this in here and replace this. You know, generally when you're working, you don't want to replace things because you might make a mistake and things like that, and you want to trace your steps. But for us, I kind of already know what I'm going to be doing, so I'm just going to replace. You know, but when you're working on a real project, just consider like, okay, are you really confident that what you're changing is correct? If it is, yes, you can replace it, but if not, then I recommend versioning it so you kind of have a fallback. So what I'm going to do is actually create another file called with GSAP. With GSAP, we're getting rid of GSAP primarily because we have differences in elevation, right? So this here is a little bit higher than this here, right here. So in order to account for that when using Octree, it's better to have like a gravity system in place rather than GSAP where we set an initial Y and an ending Y, and it just goes to that value and resets. Because what would we have to do is like raycast down on the target position, realize that its initial Y is going to be higher than this platform, and then add it to the GSAP timeline. And then same thing when we go downwards. In other words, you know, using GSAP with the Octree method is kind of tedious when we have different heights and elevation. If it was just like a flat plane and everything was on the same level, then we actually wouldn't even need the ground plane at all. We would just need this cube here and the walls. We wouldn't need the grass here or the path here or anything else, because everything would be flat and the GSAP will always go back to that same level anyway automatically, which is what we did. But since we have different heights and elevation, it's going to be really hard with GSAP, so we might as well just get rid of it. I did mention earlier in the video that custom controls is a lot more complex than using GSAP, so I'll try my best to explain what I'm doing and hopefully it kind of makes some sense. So the really awesome thing with Three.js examples though is that they actually have an example here with the awk tree implemented. And this is kind of why I also chose this method to do, just because there's an example on it and I kind of wanted to talk about how you can learn from something that you have no idea where to get started or where to even look. So I went to the examples and typed in FPS, and if you click this code button, it'll take you to the code, which I also have open here. But so when it was the first time I wanted to implement something like this, I was just like, okay, how do I even do that? This looks incredibly complex. How am I ever going to figure that out? I wish I just had a teacher to just teach me this stuff, but then I couldn't afford a teacher. So how do you learn something like this on your own? Today, you could probably copy and paste this into AI and get a fairly decent explanation. However, sometimes you won't get any sort of explanation at all. So in that case, you have to do it the old way, where you just copy and paste everything into a new file. And then on the things that you do know about, like here, you can comment on them. You're like, oh, we're setting the shadow camera, so on and so forth, blah, blah, blah. So you know what this does, so you can pretty much quote unquote ignore it. You can leave it in the code, but pretty much ignore it. Same thing here. It's like, oh, I already know what this does. I'm just going to ignore that, so on and so forth. Now, what if you see something that you don't recognize or you're questioning why it's there? Well, you might not know immediately what it is, so you can kind of leave a comment there and then to come back to it. Or what you can do is actually uncomment it and get rid of it. And if something breaks, you're like, oh, okay, maybe I should try something else. Instead of commenting it out, you can like change this to like 50 and then go back and then like see, okay, what did that change or something like that. And then over time, the more you try and fail, you'll eventually start connecting the dots over and over. Like I can distinctly remember when I was first working with this code and first learning it on my own, I had literally no idea what I was looking at. I was like, what even is this? This is crazy, and so on and so forth. And if you don't understand it after a while, definitely go up and search on like Three.js discourse forums and ask for help there and someone will answer. Now I kind of know like, okay, this is like the starting position of the capsule, this is the head of the capsule, and this is like the radius of it. So basically they're using a capsule. I said originally that if you like, let's say you have a character, you have like a bounding box, but you can also use like a sphere or something, or you can use a capsule that kind of looks like a pill. And what it's doing is it's setting this starting point on the first point and then the ending point at the top, and then it's setting a radius of 0.35, so around here, and it kind of creates that capsule shape just like that. Now the reason they're using a capsule instead of like a rectangle or sphere is another technical detail, but a capsule kind of represents a person better, which is why they're using a capsule. And then as you go through it, you can actually get rid of entire functions just to like simplify what you're actually looking at. Because when I was like first doing this, I was like, okay, I don't really care about this throwing ball thing. I'll just add on to it later. So what I did was I get rid of throw ball and then all the errors that call throw ball, all the functions that call it. So everything would just function without the throwing ball feature. And then I could like actually focus on what I was doing. Same thing here. I did like, I don't know what this is doing at all. But then I commented it out and then I realized that when I hit the walls, I no longer get slidey walls. Like right now, I'm sliding against the walls, but with this gone, it was no longer sliding against the walls. So I was like, okay, I don't understand the math here, but at least I know what it does. Same thing here. It's just like, yeah, I don't understand this math function at all. So uncomment it, remove damping, see what that does. How does that affect things? But basically the idea is you don't have to understand the syntax or even how it's connected. I mean, eventually you will, but like the idea is to kind of just like figure out what you know and then piece it back together until you figure out everything. Just because you don't know how something works doesn't mean you don't know what it does. And as long as you know what that something does, you'll eventually know how that thing works. So I'm going to be implementing and sort of explaining, but also sort of learning at the same time. And hopefully you can follow along a little bit and try and use your intuition to see if it kind of matches up with mine. Let's just take a snapshot in our brain, some things that we need. So I recommend you also have this open, but I'll keep mine open on the side and kind of just talk about it when I'm coding. Okay, so the first thing we want to do is update our imports. So I'm just going to copy this from their GitHub code. So here we have our capsule and our awk tree. Again, if you want, you can look at the GitHub repo to find the awk tree code and the capsule code if you want to dive deep into it. And then we need some physics stuff, so I'll just call it physics stuff. Like here, we have our character stuff here, but we can also have physics stuff. So we definitely need gravity, which I'll leave all caps like they do, so I'll do it at 30. And then maybe we have the capsule radius here as well. They had it at 0.35, so I'm just gonna hope that works, but we can also change that as well. Then we can have a capsule height. Whoops. Capsule underscore height. And we can set that as 1, which is what they had for theirs. And we can have like the jump height, so we can do like jump height. And we can set it at like 15. It's also technically a force, but I'm just gonna call it height. And then we can have like a move speed. And I'll just set that at like 1 for now, but you know, it doesn't really matter. We can change that later. We could use is moving, or we could like can move. Doesn't particularly matter, but since we have jump height here and move distance here, we can actually just get rid of this here. And we don't need move distance anymore, and we don't need move duration either. Okay, cool. So we might need something a little bit later, but this should be okay for now, at least intuitively. And then we need to create our octree, so I'll just const collider octree, and it'll be a new octree, like so. And then we can create our player collider, the capsule that's going to follow our player. So we'll just do const player collider equals, whoops, new capsule. And it takes 2 vector 3, so the starting position, so new 3, whoops, 3 dot vector 3. Whoops, vector 3. So for the starting height of the capsule, which is the bottom half, remember when I do that capsule, we're just going to start it at the capsule radius, right? Because the capsule radius itself will fill up and hit the ground for us. And then we don't want in X or Y, we just want it straight up and down. And then we can copy and paste this like so for the ending point, except this time we'll do the capsule height rather than the capsule radius. And then for the capsule radius, well, we can just set it to the capsule radius, which is the 3rd parameter here. So again, just to recap, we have our capsule radius, 0.35, and then we have our capsule height, which is right here, and our capsule start, which is right here. And then we have the radius of 0.35 around here, so we have our capsule around our character. Straight up and down, this isn't a good drawing, but you get the idea. And then we might need a variable to check if the player's on the floor. So let's just do if player on floor equals false. That way, when it's on the floor again, we can say, okay, they can actually move again. And then we also need our player velocity. So I'll do let player velocity equals new 3 dot vector 3, just like so. Okay, now let's generate our octree. So let's go to our loader. And in here, we can just shift alt down arrow to copy this. We called it ground collider, like so. We can just set our collider octree from graph node, this specific child, if the name is ground collider. So we're generating our octree based on our ground collider mesh. Now we also want to spawn our capsule the same place that our child is, because right now if we add a capsule to the scene, it'll just spawn in 0, 0. So let's do our player collider, which again is a capsule. We want to target the start, and we want to copy this child's position. And this will copy the X, Y, Z position, and then we can add a vector to it. Will just be the starting vector itself. We might as well just copy and paste this, like so. So we can just copy and paste that in there. So if you think about it, let's say the child is at 10, 10, 10. What we're doing is we're copying that as the player collider start, and then we're adding the capsule radius, which is 0.35. So our capsule is going to start here. Then we want to do for the end, same thing here, except again, this will be capsule height, and we want this to be end. So it's going to be at the same position as this one. The Y value is just going to be higher than this one. Okay, so let's go now to our GSAP controls. So this is for Bulbasaur and all that kind of stuff. So we can hide that. Same thing here. Okay, so we no longer need move character, because we can just update the player velocity and the target rotation in our on key down event. And then since now we have to use the request animation frame loop, we'll create a separate function that just updates our player on each frame. So let's come over here and do function update player, like so, over here. And then this function will call on every single frame. So let's just put it in here like so. Update player, like here. Okay, so since animate function plays on every single frame, and our character is also loading when the animation frame is playing, our player instance might not actually exist when we do it. So we can check if character does not exist, the instance does not exist, we can just return it with a guard clause. And this will prevent any sort of errors. Alternatively, if you don't want to put it in the function, you can totally just come over here and just do like if character.instance, like if it exists, you know, we can update the player. Nothing particularly wrong with this one either, but I'm just going to leave it as a guard clause in here. So if the character doesn't exist, just return. All right, so let's update our player velocity. So these will be player velocity instead. So player velocity, and then we can get rid of this because we don't need it anymore. And then in our update player function, we're going to lerp to the target rotation. So let's actually bring out this up outside of this function, and let's just bring it up with the rest of our player stuff. So maybe here. Then instead of scrolling back, we can just hit Alt back arrow or left arrow to go back and forth, or right arrow to go back and forth where your previous cursor positions were. You can see it's also right here as well. And then after this switch statement, we can just update the player velocity.y. So we'll do player velocity, the y direction, and we equal that to the jump height. And then we can set character is moving equal to true. So character is moving, and we can set that equal to true. Okay, so now in our update player function, we'll check if the player is not on the floor. So if the player is not on floor, then we will subtract on each frame from the player velocity y direction minus equal the gravity that we set, like so. Now subtracting 30 from the y direction on each frame is really, really large. So we can multiply by a factor like 0.01 or something like that. Now in their example, they use delta time, which is good because they need easing and they need continuous movement. We're going abrupt and at consistent movements every single time. I think Crossy Road does have some sort of easing to it, but we're just going to go with something a little bit more static. And that's why I'm using constants here rather than using delta time. So now we can actually move our player collider. So we'll just do player collider dot translate the player velocity vector. We'll just clone that, and then we'll multiply it by a scalar, and we're just going to keep it the same as the gravity one as well. So 0, 1, for example. Then we need to character. Then our position can copy the position of the player collider. So we'll do character.position.copy, the player collider.start. And then for the character.position.y value, we're going to subtract minus equal the capsule radius, because again, the start is over here. So our character would like kind of exist up here, right? And then we just subtract this area here. So our legs are down on the floor instead. And then we can use linear interpolation, a built-in 3 math utils function to create our looping rotation. So we can do character.rotation.y equals 3.math utils.lerp. And that takes 2 vectors, so character.rotation.y, the target rotation that we set, and then 0.1. Okay, so let's take a look at what we have now. So if we go back into the browser, cannot read properties of undefined copy. So if I click on this, okay, whoops, yeah, it's not character.position, that's the object itself. So these should be dot instance. So right click, right arrow once, dot instance, like so. Yeah, so at least we have something now, but you can see the gravity's working and our character is falling down there. Okay, so now we need to actually detect collisions with our ground. So we can do that right here. So let's do player collisions, and we'll just create this function up here because why not? So we'll do function like so over here, and then we can detect collisions with a built-in octree method, and we can log the result. So constant result equals collider octree dot capsule intersect and we'll just pass in our player collider. So is the octree intersecting with our player collider? And then we can set by default, the player on floor to equal false. And we'll reset this right after if it is on the false. So if results, which means we have some sort of collision, then check if it's the ground. So if player on floor equals results dot normal dot y is greater than 0. So how does this work? Well, we're taking the resulting collision and checking the normal y value. If it's greater than 0, that means we're on the floor, and this will be set to true. So this is an expression that will be set to true if you're on the floor. Well, how does that work? Well, if you're a player here and your capsule is like this and you're on the floor and you're colliding with the floor, well, the normal of the floor in the y direction is going to be up, which means 1, right? It's going to be in the direction of 1, positive y-axis, which is greater than 0. So that's going to be true. And then their next part here is player collider dot translate results dot normal dot multiply scalar by results dot depth. Okay, so what this line is doing is it's literally taking how deep you would go inside your mesh if it was colliding and just translating it back outward. So what update player does is it's just moving your capsule around, but player collisions is the one that's actually detecting collisions. So let's say you have a capsule like this and you have a box like this. Update player will just move your capsule in here. But the thing is, we're calling player collisions. So player collisions will check, okay, the result is indeed that we have a collision. So if results, so we do have a collision. And then since the normal of this thing is going to be pointing this way, we're going to take this depth, multiply it by the normal of the vector, and just translate the collider back that way. So every time you press your movement key against this wall, it's just going to immediately push back to where your original point started. So essentially what it's doing is pretty much canceling your movement command. It's like if you add 5, and then someone's like instantly subtracting 5. So that's kind of what this is doing right here. Now if the player is on the floor, we can reset is moving, because when it's on the floor, it's not going to be moving. Not for us at least. So if player on floor, then character is moving, dot is moving, equals false. And then we can set the player velocity of x, so player velocity at x equals 0, and the z to 0 as well. Okay, now we go back, see our character is not falling through the wall now, so that's really good. But if I hit one of my keys, it's like teleporting somewhere. So this kind of suggests that we're adding a wrong sort of distance to it, and indeed we are. Move distance, I think we got rid of, so it's null. This should be move speed now. So now if I go back, you can see we actually have the intended behavior that we want. Except now you can see it's really, really slow, and it's kind of like walking on an astronaut or things like that. Okay, so we can fix all these issues by making this a little bit faster. So maybe we can do like 0.3, 0.35 or something like this, something faster. Yeah, now it feels a little bit better. It's a lot faster. The move distance is still a little bit too small, so we can come up to the move distance, move speed, and maybe add it to like 10. So if I go back, you can see that, oh, we're actually jumping a lot. And we might, if your colliders are too short, you can actually jump on top of them. You can see I just jumped on top of the bench there, and then I can jump over the wall and fall off the edge, which is kind of funny. So we can reduce the amount of jump height as well, right? So actually I want to tone down the move speed because 10 is a lot. But we can also change down the jump height as well. So if that's a little bit too high to you, you can just make it like 10 or something. Just play around until you get something you like. And yeah, so we pretty much have the same thing that we have in GSAP now. Again, we just need to normalize the rotations because, again, if I go this way and go this way, it's going to take the long way around. So what we can do is just come back here and copy our function that we created earlier to fix this issue. And then right before we lerp, so let's just search for lerp. Right before we lerp, we can just place this here like so. And then we can do final rotation instead of target rotation. So that'll fix things up just like that. And if you think the rotation is a little too smooth when we turn, which it seems like it is, you can adjust that with a custom function if you want, or you can adjust our linear interpolation factor and change it up to like 0.4 or something higher. And now you can see it'll be a little bit more abrupt when we rotate. Another really small issue that we have is as soon as we play the page, you can see our character goes from this direction to this direction. And that's because our player character itself already starts with a rotation in our GBL file. So if you want to, you can like child.rotation here and like set the default rotation to be 0 so it doesn't rotate. Or you can just match our target rotation to what the character already has, so math.pi divided by 2. Of course, if you want a different rotation than what's in the GLB file as well as the target rotation, you can re-export your GLB file, or you can just make them the same. So you can assign it on the onCompleted load function down there, set the child rotation to like math.pi, and then also set the target rotation to math.pi. But here I'm just setting it equal to what it was by default. And now you can see we don't have that spin anymore. Okay, now what we need to do is set a respawn key, or in the event that somehow our octree glitches or we just miss a collision thing somehow and they can like jump over something. So in the event that happens, let's create a respawn function. So let's come up here. Let's go into our character, and then maybe we put it in here. So spawn position, and it'll just be a new 3.vector3 like here. And then we can set our initial one. We could set it here by logging out the character position, but we can just copy it directly in our load when the model is loaded. So here, if child, we can just do character dot spawn position dot copy the child dot position, or the character position in this case. And we can put like a spawn position here, so we can come over here and just do like function respawn character. Then we can do character dot instance dot position, and we just copy the spawn position. Whoops, that should be character dot spawn position. And of course, we also need to update our colliders. So what I'm going to do is just search player collider dot start, and then just grab this here, and then hit alt back arrow, and let's come over here, paste this just like this, and then we can replace child position here with spawn position. And then we can reset the speed and everything, because let's say we press W while we're going downwards, it's going to go forward when we land. So maybe you want that, you know, it doesn't really matter, but I'll just set it back to 0. So I'll just set it, the vector all back to 0, 0, 0. And then we can set character is moving equal to false. So let's just make sure this works. We can first do a key down event. We can first do a on key down event. So this, we could just put it in here, like case R for respawn, and that would work, but this is kind of like associated with the controls, so we might as well just keep it separate. And what I'm going to do is just put it up here, and we'll just do the same thing. If event.key.toLowercase, like so, equals R, then let's call respawn character, and let's just return. We don't have to do anything in the back. Whoops. Let's see. Okay, I'm missing a parenthesis here, and I need to get rid of this parenthesis. Okay, so when I walk, let's hit R and see what happens. Okay, so we do respawn. That's pretty cool. If you don't like how it just teleports there and has no action whatsoever, you can add like a vector here and put the Y up to like 20 or something, or like make it fall from the sky. And since we are updating our gravity on every single frame, it will automatically start subtracting from the Y value. That way it'll kind of fall from the top instead of like just stand there. You can do that if you want. I'm not going to be doing that. I think it's totally okay the way it is. But at least we know respawn position is working. Yeah, so what we can do is, sorry, I don't know why I'm coming down here. We could put it in here if we wanted to, but I'm just actually going to put it in update player. So I just hit control and click there to go to the code. But basically we can just check, you know, if the character is fallen. So if character.instance.position.y, if it's less than, I don't really know, I'm just going to say like -20. Then let's just respawn our character, and then we don't have to execute anything below. We can just return automatically. So if you console.log our level, we're at like 40 in the Y axis or something. And so anything below like 40 or whatever our level at means that our character is already out of bounds and it's like off the level. So this will kind of just let it fall off a little bit into the darkness, which is kind of funny. Before it respawns. And so you'll see a lot of games like they let you fall for a little bit amount of time before they respawn you. So that's exactly what we're doing here. You know, it doesn't really matter what value you put this, as long as it's lower than your scene. Otherwise you're just going to keep on perma respawning every time you go below y. Let's say you have like a down elevation that goes below -20, it's like gonna automatically respawn your character. So just make sure it's well below everything. So let's kind of just trace this stuff. Let's say we have a player on our screen, right? And then we also have a capsule, like so. And then we hit a key, and then the player velocity gets updated with our move speed. So let's say we're starting at 0, 0, 0, which is our velocity. Then we're adding our move speed in the z direction. So let's just say that would be, so let's say we hit W. So we have 0, 0, and then 10 in the z direction. And then we also have plus the jump height, which I think is also 10. So we can do 10, 10, 10, 0, 0, 0. So now each frame, it's checking update player. So what does update player do? Let's go to update player. We have some guard clauses, but we can just ignore that. So since our y value is set at 10, that means we're not on the floor. So every single frame, subtract some amount of value from the y. So let's say we go through one frame. That means it's going to be a lot smaller than what I'm writing here, but let's just say it's 9 and 10. So this will be our first frame for now. And then what we're doing is we're taking our player collider, this capsule, we're translating to our player velocity that we cloned multiplied by this scalar. So that means on each frame, we're going to be going 0.035 closer towards our player velocity. Then we're checking for collisions to make sure that we can actually go towards that velocity. So we have this built-in thing. We don't have to write the math at all. We can just determine if it's intersecting with anything. And if it is intersecting with something, if there's a collision, then we can check if the player is on the floor, if the collision is the floor, which I explained a little bit earlier. And then if the player is on the floor, it means they're not moving. So for the one that Three.js did in their documentation, when they're on the floor, they can still be moving. For us, when we're on the floor, we're not moving at all because we're always up in the Y when we're moving. That's just the nature of the way we're controlling. So that's why we set it to false here. And we want to prevent any movement when we're on the floor, so we just reset it here and wait for our next jump. And then here, I also explained this earlier, it's literally pushing out how deep your capsule would go. Like if you go 5 deep with this depth value, then it's just going to push you 5 units back outside. Okay, so since our player collider now has a good place, we can just copy it. Our character instance position can just copy the player collider, again, which is translating towards our player velocity on every single frame. And we can just copy it. And then again, like I said earlier, our character is going to be starting higher than the capsule because the starting position is up a little bit, 0.35, so we just subtract it. You could totally just do from the end as well and then make the mathematical adjustment that way as well, but we just did it this way. And then I made this earlier, but I might as well just explain it briefly. If you want, I highly recommend you console.log every single point and go and try different target rotations and kind of like trace what I'm doing here. But basically what we're doing is we're taking a target rotation. So let's do the one that was glitching out, which was 180 degrees or math.pi. And then we were going to -90 or negative math divided by pi. Let's just work in degrees for now. What we're first doing is taking the rotation value between these two. So -90 minus 180 in this case is going to be -270. And there will be times where the rotation might be larger. So we're modulating by 360 degrees. For us, just to keep it within the range of 0 and 360, but this doesn't really change anything. We still get -270. And then what we're doing here is adding 540 degrees, and this will make any angle. So adding 270 and 540 will just make this now positive 270. And then again, if there's overkill, we're just checking it one more time to moduli by 360. It's again still 270. Taking 270 minus 180, and then we get 90. So the actual rotation is 270, but in the end, we get 90, which is what we want. And then so here we have 180. So we have our character instance rotation, which is 180, and then we just plus 90. So then we go to 270. So instead of going from 180 back to 90, back to 0, back to -90, we just go from 180 to 270. So why are we minusing by math.pi? Well, this way it keeps us in the range between -pi and pi. So if I go, for example, from 180 to 0, this is going to be my max amount of rotation. Anything above 180, like 270, it's going to take the long way around, and we don't want the long way around. So by normalizing it only between negative pi and pi, we kind of prevent it from taking the long way around and only take the shortest path possible. And then for this bottom one here, we're just using the linear interpolation function that's built into Three.js. Starting point, ending point, linearly interpolate between those two. And then this is just like determines how jaggedy it is or not, or how smooth it is. So again, I think I mentioned it earlier, but you can see we have a starting point and ending point. You can just think of it interpolating just like this in Blender. You know, we don't have all the keyframes in between. We could technically have a keyframe and set it in between for each one, but we're not doing that. We're just letting the software figure out that data in between for us. So that's essentially what we're doing here. And again, this is happening on every single frame. We're calling update player on every single frame. Yeah, so honestly, congratulations. We did something very, very, very difficult and implemented it into our own code. What we did was we analyzed code that we didn't understand at all. We identified the parts that we could apply to our own application, modified certain parts of it, right? Like we got rid of damping, and then when we were on the floor, we removed our velocity. So we did a lot of differences. So we updated existing code to fit our own stuff. We understood parts that we didn't understand before, and we broke down a really, really complex thing, which is custom movements into their own parts, and added that into our own application. So we did a really advanced concept together, and I hope by walking you through that process, you kind of develop, you know, how to think, how to approach problems. And I encourage you to take some time to take a look at some of the other things and see what you can figure out, what you can play around. It doesn't have to be this, but any code that you think might be a little bit too difficult for you. So again, just break down, uncomment stuff, comment stuff, change parameters here and there, break stuff, and kind of just see what sticks. Eventually, you'll see these things repeat over and over again in a variety of different open source code repos. The more code you read, the more methods you'll learn, and over time, you'll just build up this web of knowledge and can like tap into it and make connections between them. Okay, now we can just get rid of our thing. We actually don't need these console logs. Let's get rid of all our console logs because we don't need those anymore. We don't need this helper anymore. You can leave it uncommented if you want it, but I'm just going to get rid of it. And then for our ground collider, we don't want to view it anymore. So we can remove it from its parent. So we'll just do child.remove. Remove from parent like so. Hey, I'm from the future here. I just want to say I made a mistake here. If you look up a traverse on Three.js documentation, modifying the scene graph inside the callback is discouraged, so you might be facing a small little error there. So instead of child.remove from parent, you can just do child.visible and set it to false. I'm missing a few optimization things there, but that is a topic for a more advanced video. And now you can see our collider's gone, but it's still working effectively. And then we still have this helper in. So let's search for our other helper. Okay, yeah, we want to get rid of our shadow helper. So now we're back to what we started. Super, super cool. Okay, so now let's make our camera follow our character. That way we don't have to keep moving around. If you want to leave it moving it around, you might have to add some user restrictions, but I'm just going to have it follow our character by default. So let's go to our animate function, and on each frame, we can just set our camera to look at our player. So what we're going to do, I think I named it camera, our orthographic camera. So camera.position.copy our character.instance, character.instance.position, like so. And we want to add our camera offset. So I haven't created this yet, but we want to add a vector of camera offset. So this is going to be our starting position. So I don't remember where we set our camera. It doesn't really matter. Let's just jump to it. So our starting camera position here is negative 13, 39, 67. So we'll set our const camera offset. Our const camera offset equal to a new 3.vector3. Vector 3. So we'll set our const camera offset equal to a new vector 3, like so. And it'll just be of these values, negative 13, 39, and negative 67, like so. And then the last thing we need to do is actually have our camera look at it. So there's a built-in function called camera.lookAt where you can just look at something. And then we're just going to look at our character position. And of course we have an issue here because, again, character instance might not exist. So we can also just check if character.instance, or we can put it in update player. But since it's a separate thing, I guess we can just check for it here anyway, so whatever. If I go back, you can see that, okay, we have something working. But now the camera, every time we go up, is also following the thing. So maybe you want that, but I definitely don't. We can just come over here and just do const target camera position equal to a new 3.vector3, like so. We'll just take this and add the offset of the x and y, sorry, the x and z, but not the y. .x plus camera offset .x, and then for camera offset y, we can just leave it as camera offset y, and then for these, we can put in z here, like here. This will just be z, so we'll just, whoops, let's just control D, put that z there. And then we can have this go down here, so I'm just going to copy this instead, like so. And whoops, I think I got rid of my lookat function. Oh, well, that's fine. We can just do camera.lookat. Again, we can just do the x and z here, so let's just copy and paste this. Just put it in here, comma. This doesn't need a comma, but here. And then for this, we'll just look at the camera.position.y and then subtract our offset. So we added 39. So we're just getting rid of our offset to look at the camera.position.y value. And we can adjust this depending on how much of an angle we want. So now if I go back, you can see that, okay, now we have our camera following the character. Super, super cool. Now let's get rid of our orbit controls because we no longer need them. So let's go over here and we can just get rid of them just like that. And then we can do camera.zoom, I don't know, we can set it to like 2 or something. And then we need to call camera.update projection matrix. So now you can see it's kind of zoomed in, which is a little bit better. Okay, so before we deploy to our GitHub and let the world see something, I just want to leave you with some final exercises that you can tackle on your own once the video is over. And these are also implemented in my code, so if you're stuck, you can kind of look at one method to implement that thing. Obviously, there's a lot of different methods to implement a similar thing, but here at least you have one single solution that you can reference, if you need to. So the first exercise that I'll leave you with is implementing a theme toggle. So here you can see I can switch from day to night mode. Now this might seem scary, but again, try and break it down into what you know. You know how to set a color of a material. So how do you set a color of a light? And then how do I get the transition? Well, maybe I can use GSAP to set the transition, so on and so forth. So again, try and break it down into small steps and see what you can do from there. The second exercise I have for you is a loading screen. So how do we make a loading screen in Three.js? Well, honestly, I don't even know myself. So I would go onto Google and type in loading screen on Three.js and see how other people have tried to make their loading screens with Three.js. And they might refer you to some really, really good documentation that'll tell you how to implement a loading screen. And then again, we know how to look at documentation. We know how to implement documentation and read parameters and things like that. The last exercise I have is less of Three.js at all, honestly, but it's more about implementing mobile controls. So this is more of a JavaScript exercise. For me, my mobile controls is just like this. It's a simple click like here. You could definitely use like a swipe gesture if you wanted to. And then here you can see I have a very, very basic loading screen. It just loads and then fades out. Honestly, but beyond these exercises, there's so many other areas you can look at. For example, the trees, they're all the same, so maybe we could do something with instancing and optimization if you're kind of down that route. Maybe you want to make a different kind of world rather than a blocky world. Maybe you want to update some things in your portfolio and then re-upload it. It's really up to you. Whatever for future direction that you want to take it, you can totally take it. All right, so create a GitHub account if you haven't already and create a new repository. I'm just going to call this Bella's Park, but give it whatever name you want. And then everything is fine here, and we can just create our repository. Now we can click this here to upload our existing files. So I'm going to go into wherever I saved my stuff. So right here, my stuff, VS Code projects Bella's Park. And I'm just going to hold Shift to select everything and just click and drag just like that. And then you can get a little bit excited. Folio. And then, yeah, whatever. And let's just commit that. So I added a README, which is why you see this here, but you can just ignore that. So now what you want to do is go to vercel.com and create a free account. And then you can come over here and do add new project. And it should automatically detect your last repository once you connect to your GitHub account. So make sure you connect there. Then you can just hit import, and then you can just hit deploy. And when it says ready, you can just click this and navigate here. And now you can see that you've just deployed your portfolio to the world just like that. Super, super cool. That's really awesome. Yeah, so thank you so much for sticking around. Hopefully this video helped. Hopefully you learned a few things. And right now, like, the sky is really the limit. You can do a lot of things now. Don't be afraid to try and fail over and over again. And don't hesitate to reach out if you have any questions. Yeah, that's pretty much it. Take care. Hope to see you in my next video. Peace out.